Welcome to our course on Spring Data. Let's take a few moments to talk about the contents of this course and what we'll be covering within its lessons. So, of course, our topic is Spring Data. For those of you not familiar, Spring Data is a project within the Spring portfolio that allows us to easily access data within our data stores. So we build these applications and we need to store information. So we normally do that in something like a relational database or maybe a NoSQL database. And then our application needs to access that data. And this is Spring Data's sweet spot. It makes accessing data easier. The project facilitates access to data within several types of data stores. And what you'll see is that you'll use a very flexible and consistent approach to performing those data persistence operations in your application. So while your projects may be connecting to different data stores, the method that you use to persist information to them will seem very similar as you work across the different modules in the Spring Data project. And this brings us to our next point. The Spring Data project is really an umbrella project that consists of multiple modules. Usually a module corresponds with a data store. So for example, there is the Spring Data Mongo module, and that module is used to retrieve and store your information within a MongoDB data store. Now, some of the modules are a little bit more generic. So for example, there's a Spring Data JPA module, and that's used to work with relational databases. Each of these modules uses principles that are contained within the core of the project. And the main principle you'll see is the repository concept and the repository approach to accessing our data. The project is relatively mature. It was released in 2010, and since its release, it has continually been improved and additional modules have been added as new data stores arise. Now let's talk about why folks use Spring Data and why this course is worth your time. This is a pretty easy sell. The main selling point of Spring Data is that it's going to reduce the amount of time it takes to put a persistence layer in place. So we always have to build out some sort of layer or some sort of approach to persist the data within our applications. Normally, we use technologies such as JDBC with prepared statements, or maybe you use an ORM, or maybe you built your own custom framework. Well, Spring Data is superior to all of these approaches. With JDBC, it's kind of clumsy. You're opening and closing connections, and you better make sure you do that or you're going to leave them hanging. With an ORM, there's several varieties out there you can choose from. But normally what you end up doing is applying some sort of DAO pattern that you use to provide a consistent layer to persist your data. With a custom-built framework, you're really subjecting yourself to any errors of that framework you build because it's not going to receive the usage of something like Spring Data. So Spring Data is going to have all its bugs flushed out and addressed by a large open source community where your resources with that custom framework are really limited. Let's talk about another benefit of Spring Data. Spring Data adds predictability to your code. I believe that predictability is the most important characteristic of code. When I can look at code and predict how it's going to behave. So if I know some particular features in place and I can predict how that feature is supported in the different layers of the application and in the architecture of the application, that is a well-coded piece of software. And Spring Data does just that. You're going to use the repository interface, and the repository interface is well established, and you're going to be able to use that approach across your application and across a portfolio of applications. The repository interface is very easy to understand, and all of the methods on the interface are very self-documenting, so it's very easy to read code that is written using the Spring Data project. Along the same lines as predictability, another benefit of Spring Data is the ability to access multiple data stores. So you can access your traditional relational database. You can also access a NoSQL data store. And the great thing about the project is that the approach you take to access those data stores is going to be fairly consistent. So when you use a module, the core principles of the Spring Data project are still instilled within that module. And when you attempt to access a different data store, you can apply the knowledge that you have from working in one module to another. And at the same time, you're able to access this whole variety of data stores using the project. And finally, this is probably the strongest point of using Spring Data. Spring Data encompasses all of the evolution that has occurred with regards to persistence in Java applications. So as we said, we started out with JDBC, and then we had this great idea of using an ORM, and then ORMs were kind of standardized under JPA, and then we started applying patterns when using an ORM, such as the DAO pattern, and then we've started to look at building out REST interfaces, which support things like microservices. Well, Spring Data takes all of that evolution and really packages it up into one project. So you can really take a great leap forward in how you persist data within your applications by learning to use Spring Data. Next, let's talk about the contents of our course. Our course is really divided into four main sections. First, we're going to take a look at the Spring Data project, and we're going to learn pretty much the basics about it. Then we're going to look at working with Spring Data by using the JPA module. And this will probably be the largest section of our course. We're going to learn all of the basics of working with a repository, of defining custom query methods by using the Spring Data JPA module. And the Spring Data JPA module interacts with a relational database. So, the king of data stores for about 40 years. So it's a very appropriate place to start. We're next going to move into the Spring Data Mongo module. And this is going to give us some experience working with Spring Data and a NoSQL data store. You'll see that many of the basic principles that we learned within the JPA section of our course will be applicable when we start to work with Mongo. Next, we're going to kind of continue the evolution, and we're going to move to the Spring Data REST module. And we'll learn how to expose our data via a REST API that is constructed and implemented by Spring Data. Okay, now let's talk about some prerequisites for the course. What should you know ahead of time? Well, Java. This is not the place to start your journey of learning Java. You should have experience with the language, and you should understand XML, and to some extent Spring Core. You should also understand the principles of object relational mapping because it's going to be very applicable throughout the course. So I would say this isn't a beginner course, but at the same time, you don't have to be an expert. This course is really here to facilitate your journey from a beginner to an expert. So those of you in that intermediate range, this is a very appropriate course for you. In our introductory chapter, we're going to talk about some of the core concepts of the Spring Data project. This chapter aims to lay the foundation that will guide you through the rest of the course. Persisting data really isn't that complex, so we're going to keep this chapter fairly straightforward. Most people subscribe to the idea that you build out a domain layer that has domain objects, and those domain objects relate to your business and store the information about your business. Next, a service layer is used to make changes to the underlying domain objects within the system. At that point, the need arises to persist those changes to your domain objects into your data store so that they may be accessed at a later time. It's fairly simple, but traditional approaches to data persistence, such as JDBC, or even using something like an ORM such as Hibernate, are more complex than they need to be. And that's really the concept of Spring Data. It's simplifying data persistence. In this chapter, we're going to discuss some of the features that make working with data so simple when we use Spring Data. You'll see the benefits and advantages that you will receive as a developer when you choose to incorporate Spring Data into one of your projects. We'll also discuss the core concepts that underlie the framework. These core concepts are not overly complex, and they eliminate much of the complexity that is introduced with traditional data persistence approaches. Once we have discussed the Spring Data project and its features and concepts, then we'll install the tool that we'll be working with throughout the course. And that is the Spring Tool Suite, which is a version of Eclipse that is made available by the folks at Pivotal. So the folks at Spring have created a customized version of Eclipse that will support our development of Spring projects. Once we have installed the tool we'll be using throughout the course, then we're going to take a look at Spring Data in action. So we're going to just run through a small demonstration to see the different pieces of a Spring Data project, and we'll discuss how they work together in order to make our lives as developers much easier when it comes to data persistence. In this lesson, we're going to take a look at some of the features contained within the Spring Data project. We'll see how these features make our lives as Java developers much easier. Before discussing these features, I'd like to talk a little bit about the motivations behind the Spring Data project. The folks at Spring don't just create a new project out of the blue. They often look for a common concern amongst the Java development community, and then they will build a project to address that concern. So the Spring Data project was created because the folks at Spring saw an opportunity to improve how Java developers access data. We built these applications and they all had some form of data persistence. We need to store and retrieve data. And the folks at Spring were able to make data persistence much easier by doing a few things. First, they simplified how we configure our access to different data stores. So you'll know if you've ever worked with a relational database or NoSQL database, you need to build out specific components. So for Hibernate, we have a session, or if you're using JPA, you have an entity manager. And those components need to be configured. We need to provide a port number. We need to provide a server name. There's all this configuration that goes into connecting to these data stores. And Spring Data provides a simple Spring-based approach to creating those components that connect to the data store. Another motivation behind the Spring Data project was to provide a consistent approach to accessing data within our applications. So when you use Spring Data, the approach you use to access data within a relational database will look the same as the approach you use to access data within a NoSQL database. We'll see in a minute that we use the repository interface. And the repository interface provides us with a standard set of methods to access the data within our data stores. So our data access code looks very consistent across projects and within our applications. Now, while we have this generic approach to data access, Spring Data also preserves the specific features of our data stores. So for example, if you're using JPA with a relational database, you can still write JPQL queries. Now, you can't do that for a NoSQL data store, but Spring Data allows you to use the features specific to the underlying data store you're working with. So you kind of get the best of both worlds. You get this generic approach, but you still get the features of your underlying data store. Another goal of the Spring Data project was to facilitate the construction of REST APIs. Many applications have moved to browser-based communication where we're accessing data via AJAX calls or through JavaScript. And there have been components built into Spring Data that makes building these REST APIs much easier. Now that we know what the Spring Data project is trying to achieve, let's talk about some of the features that allow the project to achieve its goals. We mentioned the repository interface, and repositories are used to connect our domain object, our POJOs, our entities, to our data store. So we have this object model or domain model, and the repository provides us with a familiar interface that we can use to persist data to a data store. Now, one of the neat things about repositories is that we can create these methods, and the name of the method will define a query that the Spring Data project can derive from our method name. So I can write something like find by last name, and Spring Data can inspect that method name and derive some query, like maybe something like select star from person, where last name is equal to some value. We'll see this in action in a little bit. It's a very powerful feature that saves you from writing a lot of SQL. Another neat thing about the Spring Data project is that it has built-in support for paging. So how many times have you wrote paging code so that you can access, let's say, the first 10 items in a result set, and then the next 10 items, and the next 10 items? Well, that's all built into our Spring Data repositories, and Spring provides the implementation of that paging feature for you. And it also works hand in hand with sorting capabilities that can be built into our repositories. As we mentioned before, there is a lot of facilitation for configuration of different data stores. So Spring's going to provide you with a lot of out-of-the-box features that contain the configurations you need to connect to your favorite data store. Spring Data also provides integration with Spring MVC. So if we are developing a web application, one of the best choices for building out your persistence layer is Spring Data because of the tight integration between the two projects. And finally, I can't stress this enough, but Spring Data provides you with a consistent approach to your persistence layer or your data access layer. And that allows developers to move from one project to another, or one piece of an application to another, and they know what to expect as far as data persistence when they make that transition. It's very beneficial to your project teams and your projects to have a consistent approach in place to something as important as data persistence. And finally, you'll notice that this whole time I've been talking about data stores. I haven't mentioned any particular database vendor, any specific NoSQL implementation. That's the great thing about Spring Data. It connects to easily over a dozen data stores, some relational databases, a lot of NoSQL databases. So there is a wide variety of data stores that have Spring Data offshoot projects that you can use to connect to those data stores. And under the generic approach that we will see in Spring Data, it becomes pretty simple to switch out those data stores as long as you're not tying into specific features of those data stores. So we see support for things like MongoDB, Redis, Couch Database, Hadoop, Neo4j, and the list goes on and on. This is not an entire set of the data stores supported by Spring Data. Just know that there is great support out there for many data stores, and when you choose Spring Data, it's going to make connecting to and persisting data to these data stores much easier. In this lesson, we're going to talk in detail about two of the core concepts that make up the Spring Data project. The first concept that we're going to talk about is the concept of a repository and how that plays into Spring Data and your applications. Some of the Spring developers will mention a value proposition. And basically, what they are saying is if you accept the Spring framework and you incorporate it into your applications, they're going to deliver some value to you. Now, what you need to understand about that statement is that you are accepting their approach to building applications. And I agree with this approach, but it all starts out with this concept of domain objects. Domain objects have several names. You'll hear them referred to as entities. Some people will call them POJOs, but basically they are objects that relate to the business area that we're working within. So, for example, if this were an e commerce system, our domain objects may be something like an item, an order, a line item on that order. If it were something, let's say a library system cataloging books, we would have books, authors, they would make up our domain. So they are objects that are related to the business, and we model them within our Java classes. So we build these domain objects that make up our domain object, and then we work with those objects in our services. So here we see a service, and we see several instances of domain objects within it. And you'll notice we no longer have our traditional rectangles. Now we've actually modified those shapes. So our services perform work on instances of our domain objects. So maybe if we are looking at an item within an e-commerce system, we make a change to the price of that item, we change its description, maybe we change information about another domain object or entity that corresponds with the manufacturer data. So our services perform all of the work of our application and they modify instances of our domain objects. And then the repositories come into place. Repositories allow us to persist those domain object instances to our different data stores. We need to store all of the information that we collect in these instances of our domain objects within persistent storage or within a data store. So our repositories are the key to persisting that data. That way, when we leave the website and we come back, it's there. Or when we make an order in an e-commerce system, it shows up underneath the vendor's view of the system. So persistence is very important, and that's what repositories do. They persist instances of domain objects or instances of entities. So within our diagram, we see that our repositories are persisting the changes made on our domain objects by the service to our data stores. Now, this is a complete oversimplification of how an application works. Normally, under the Spring paradigm, there's also controllers in here which process requests coming into a web app. But in a nutshell, we're looking at domain objects, repositories, and services. So just to wrap up our look at repositories, we're going to take a look at the repository interface. So here we see the CRUD repository interface, and it extends the repository interface. You see that it accepts generic type parameters, and those type parameters help define several method definitions on that interface that help us perform all of our persistence of the entities or domain objects within our system. So here we see we're able to save an entity, we're able to retrieve an entity, we're able to check if it exists, we're able to pull back a collection of entities, and we're able to delete entities. So basically all of our CRUD operations are available to us via the repository interface. It's very important that you understand repositories because they are really the central interface within Spring Data that is going to be used within our data access layers. The repository interface allows us to reduce a lot of boilerplate code that we would need to write if we were to use something like JDBC. Moving on, another core concept within Spring Data is the idea of derived queries. So we can place methods on our repository, and by the way we define the method name, Spring Data is able to derive a query. So here we're looking at a repository that has a find by first name method upon it. It accepts an argument of type string that is named first name. And if we look below, we see the equivalent query that Spring Data will generate based upon this method signature. So you see that it is first peeling off the find by prefix on the annotation, and then it is taking the first name token from that method name, and it's using that to form our predicate. So we see where p.firstname is equal to some parameter. And that parameter, notice how it's color coded in red, is equivalent to the argument that we pass into our find by first name method. So that's how Spring Data is going to construct that query. And it gets the type information from our generic types that we specify on our repository interface. So you see that we provide a generic type of person as the first generic argument, and that ends up forming the from portion of our query. So here at the bottom, we see the equivalent JPQL query that would be issued if we had this method on our repository interface. And that's all available by Spring Data's ability to derive queries from method signatures. Throughout our course, we're going to take a real hands-on, in-depth look at these two core concepts, but this lesson should give you an overview of some of those basic principles that really form the foundation for Spring Data. In this lesson, we're going to walk through the installation of the Spring Tool Suite. Spring Tool Suite is an integrated development environment, or IDE, that we will be using to complete our lessons within the course. To get started with the installation of Spring Tool Suite, or STS, we need to open up a browser, and we're going to Google Spring Tool Suite. And here you see the first link returned is the spring.io/tools site. And if we click on that link, we are going to be taken to the STS homepage. On the homepage, you will find a description of the tool, and if you read into it, you'll find out that it is an Eclipse-based IDE that has been customized to facilitate the development of Spring applications. On the page, you will notice a link to download STS, and you also see the option to see all versions. So we want to click on the See All Versions link so that we can download an installer that is specific to our operating system. So on this page, one thing you'll notice is that we are currently on STS 3.7.1, and that is the release that we will be using throughout the course. I am on a Windows system, so I will select the Windows platform, and then I need to select the 64-bit installer. Now, if we click on that link, you'll see that it is a zip file. So that's how the IDE is distributed. And I'm not actually going to download this zip file because I've already done that ahead of time. So you do not need to wait on this file to download. So I'm just going to cancel that download, and then I'm going to navigate to my desktop. On my desktop, you'll notice that the Spring Tool Suite 3.7.1 zip file has been made available. So the next thing that we need to do is extract that zip file. And to do that, we're just going to right-click on the file and then select your favorite extraction tool. Mine happens to be 7-zip. So I'm just going to use 7-zip to extract to this spring-tool-suite directory. And you see the version information's on there. and that will begin the extraction of the IDE. And now that we have finished extracting that directory, we can double click to open it up. And what you'll see is that within this directory, we have an sts-bundle directory. And inside of there, we have three other directories. The first being the legal directory. We're not going to cover that. The next is the pivotal-tc-server-developer directory, and this contains the Tomcat server that will be integrated with our IDE. So this is a Tomcat server that has been outfitted with different features by the folks at Pivotal, who is the parent company behind Spring. You'll also see the STS folder, and we're just going to drill down into that folder, and you will notice that this looks very much like your typical Eclipse installation. You see a lot of folders that you'd recognize if you were to install a vanilla version of Eclipse. Now, what does differ is the sts.ini file, which is some configuration for STS, and the sts.exe file, which is actually going to launch the tool itself. So we'll double click that file, and it's going to bring up the splash page, and it's going to begin loading our tool for our use. As part of our first launch, we need to specify a workspace that will house all of our projects for the course. So what I would recommend is clicking on the Browse button and adding a new directory to your desktop. So simply click on Desktop and then hit Make New Folder. And we're going to call this directory sts-workspace. And once you have that directory specified, just hit OK. Now also be sure to check the Use this as the default checkbox. This will prevent this dialog from popping up every time we launch STS. Once you have specified these settings, click on OK, and the tool will continue to launch. So once the tool launches, I'm just going to resize it a little bit so we can get a better view of it. You'll notice that STS displays a dashboard that gives us some information about recent news with the Spring framework. So at this point, we have installed our tool and we're able to use it to work through our lessons. In this lesson, we're going to take a look at the core components that make up a Spring Data project. To see these components, we're going to work with a simple Spring Boot application that we have created in order to persist a simple book entity. Spring Boot is a tool provided by the folks at Spring that helps simplify the configuration of Spring applications. So much of the configuration of this project has been done behind the scenes by Spring Boot. But that brings us to the first component of a Spring Data project, and that's the configuration aspect. Here you see the application.properties file, and this file contains several pieces of configuration that dictate Spring Data's behavior. So here we see the spring.jpa.hibernate.ddl auto property, which has been set to create drop, and that's just telling Spring Data how to create the DDL within our project, and it's going to be auto-generated by Hibernate. You see we're also setting the showSQL property to true, and that's going to provide us with a little bit more verbose logging in our application. Now, if we look at our Spring Data Demo application class, you're going to see that it has been annotated with the Spring Boot application annotation. And that's going to provide a lot of configuration behind the scenes. It's going to inspect the starter projects within the POM, and that's going to pull in our various dependencies for our application and put a lot of conventions in place that alleviate the need for us to do a lot of configuration. The next item we're going to take a look at within a Spring Data project is our domain model or our entities. So within this project, we are using JPA, And you'll notice that we have this book class that represents an object within our data model. We have annotated all of our fields on the book class, and this serves as that domain object that we would like to persist into our data store. So if you'll remember, within Spring Data, we use repositories to persist our domain objects. So here we see the book repository interface. And you'll notice it's just an interface, but it extends a JPA repository. And that is a flag to Spring Data that it needs to provide an implementation of this book repository. You'll also notice the repository annotation on this interface, and that also will be picked up by Spring Data as a marker to create the implementation of this repository. So all of the persistence logic that needs to be created to insert, update, delete, or read this entity or this domain object from our data store will be provided by Spring Data. So when we look at our Spring Data Demo application, you'll see the main method just grabs an application context, pulls the repository out of the application context, and then we create a new book and we persist the book using the save method. And that's it. You don't see any prepared statements. All of that is done behind the scenes. You're not handling any exceptions that may be thrown from your persistence code as you would with JDBC. So you can see how simple it becomes to persist to your data store. So let's just quickly run this application, and you'll notice that the Spring Boot console fires up within our console, and then we have the table being created, and you can see that within our logs. And then we insert our book entity, and then eventually we clean up our DDL because we've specified the create drop option within our configuration properties. So this should give you a glimpse of how simple it is to write data to a data store using Spring Data. It's going to simplify the way you write code within your applications because you are no longer responsible for writing all the plumbing code to save data to and from your database. In this chapter, we're going to focus on using a variety of approaches to configure a Spring Data JPA project. Now, while we'll be focusing on JPA, the concepts and lessons that we learn in this chapter will be applicable to other projects within the Spring Data umbrella. So for example, the approach we take to configure our Spring Data JPA project will teach us some core concepts that we can then apply when configuring a Spring Data Mongo project. When working to configure a Spring project, we have a number of approaches available to us. Spring allows us to configure our projects using XML, annotations, and Java configuration. About 2 years ago, another approach was introduced, and that is the Spring Boot approach. So Spring Boot is a separate project that attempts to really simplify how you stand up a Spring project by applying several conventions. So it's very opinionated in how the project should be configured and the type of underlying technologies used. So we will first see how to configure a Spring Data JPA project using Spring Boot. And when we perform this configuration, you're going to see that a lot of the configuration work has really been handled for you and is transparent to you. Now, this is great because it reduces the time it takes to establish a new project. However, we are relying upon Spring to make the right decisions for us. We don't have the granular control over the configuration that we may see in other approaches. My preference for configuring any Spring project is to use the XML configuration. I find that there is very good support for XML configuration within STS because it is one of the oldest approaches to configuring a Spring project. So there are a lot of resources out there when we look to configure a project using XML that we can rely upon, and it's also very well integrated into the tooling that we use. XML configuration also lends itself to being very easily integrated with annotation configuration, which I also like to use when I configure any Spring project. Throughout the remainder of this course, we will be using XML configuration, but within this chapter, we're going to take a look at the Spring Boot approach, as well as the Java configuration approach and the XML configuration approach. So we'll see each configuration approach in action. In order to work through a Java configuration approach and an XML configuration approach, we need to use Maven. And Maven is a build management tool that has an excellent dependency resolution feature. If you're not familiar with Maven, O'Reilly has another course, which I have created, that will help you get up to speed on that technology. Within our course, we're going to build out a base Maven project that we can then reuse throughout the course anytime we're configuring a project for a new data store. Once we have our base Maven project in place, we'll move on and start to actually perform the configurations for a Spring Data JPA project. And within that project, we're going to be discussing many of the JPA components that we'll be using. As you know, JPA relies upon an entity manager to persist instances of an entity. And it also relies upon some transaction management features that are all provided within Spring. We'll discuss these components throughout the chapter, but if you'd like to learn more about JPA, O'Reilly has another course on JPA which I have created. So there's some background resources you can use to get up to speed on these other technologies. One of the nice things that you'll see is that Spring provides a lot of out-of-the-box support for JPA. You'll see that Spring has created different classes that perform the integration between your JPA provider, which in this case will be Hibernate, and the underlying Spring framework. So there's great integration between Hibernate and Spring Data. And one of the ways they do that is providing a bill of materials. It's called a BOM. And it's actually a way that the Spring Data project helps manage the dependency versions within a project. So we'll see how to add a bill of materials to our Maven project that is going to resolve a lot of the dependency resolution nightmares that can occur when you configure a new project. In this lesson, we're going to walk through configuring a Spring Data project using Spring Boot. Spring Boot is by far the quickest method of setting up a Spring Data project, but as we'll see, you will sacrifice some transparency within your project configuration. So to get started, simply go to File, then go to New, and then go to Spring Starter Project. This is going to open up a dialog that will allow us to establish our Spring Boot project. So I'm going to change the name of this project to Spring Data-Boot, and then we need to provide the type of project, which is going to be a Maven project, and we need to provide the group and artifact IDs for this project. So I'm going to use com.o'reilly.sdata. And for the artifact ID, I'm going to use spring-data-boot. We can go to the packaging option to change the package structure of the application. So we use com.o'reilly.sdata as our root package. With this configuration in place, we can click on the Next button, and this will take us to a form where we can select the different components that we would like to see within our Spring Boot project. The Data option allows us to specify which Spring Data project we're going to be using. As we mentioned, there are several Spring Data projects, and getting started, we're going to be working with JPA. So if we click on JPA, we will then have the Spring Data JPA starter added to our POM for the Spring Boot project. Below the data option, you'll notice the database option. So this allows us to specify the type of data store that we will be working with within our project. We're going to use the embedded H2 database for all of our examples. With that selected, all I need to do is hit Finish, and Spring Boot and STS are going to begin building out our project. You see it being constructed on the left within our Package Explorer. If we navigate to our new project and expand it, you'll notice that we have the traditional Maven structure in place, and within that Maven structure, we have our package that we specified, as well as the application.properties file within the source main resources source folder. So let's open up application.properties. Within this file, we can specify our properties for the Spring Data project's configuration. You'll notice that we can take advantage of IntelliSense when using STS to create our application.properties file. So I'm just going to set some options for Hibernate. So the first one we want to set is the create drop value for the DDL auto property. And this just tells Hibernate to build out our schema. Next, I'm going to set our logging level. So we get some debugging output to our console. So I'm just going to set that to debug. And then finally, I'm going to set the spring.jpa.showSQL property to true so we can see our SQL statements be executed by Spring Data. So we'll save that file and we'll navigate back to our Package Explorer. And within the com.o'reilly.sdata package, we're going to create a new class. So we'll just use the new dialog by hitting Control-N and we'll select class. This is very simple working with Eclipse, so we're not going to work through that. We're going to call our new class book, and we're going to put it within a data.entities package. With that in place, we simply click on Finish, and our new class will be created. Now this class needs to be annotated with JPA annotations, so we're going to make it an entity, and we're also going to specify a table name of book. Next, we'll import these annotations by holding Control, Shift, and pressing O. This will bring up the Organize Imports dialog, and be sure to choose the javax.persistence.entity type, as well as the javax.persistence.table type. Now, with our annotations in place, we're going to add some fields to our book class. The first field we're going to add is a long by the name of book ID. We're also going to add a string title, as well as a publish date. And we're going to add an integer for the page count. And finally, we're going to add a big decimal for the price. We'll import all of these annotations. Be sure to select java.util.date when you import those annotations. Next, we're going to create getters and setters for each of these fields. So hold Control Alt, press S, and then hit R. This is going to bring up the Generate Getters and Setters dialog, and you can simply select all and click on OK. The final thing we'll do is we will annotate our ID for the class using the ID annotation. So we'll select the javax.persistence.id type, and then we will add the generated value annotation, and we'll specify a strategy of type identity. And that simply tells Spring Data how to generate the primary key for this entity. With this in place, we're going to create our next component, which is our repository. So simply go to the com.o'reilly.sdata package, then access the new dialog by hitting Control-N, and we're going to create a new interface. This interface is going to be named Book Repository, and we're going to have that interface extend the JPA repository interface. So click on the Add button next to Extended Interfaces, and then simply type JPA repository, and we'll need to specify two type arguments for this interface. So the first is the type of the entity, so book, and then the second is the type of the ID of the entity, so that is a long. With that in place, we simply hit Finish, and then we import our types, and we can also add the repository annotation to this new interface. And at that point, our repository is in place. Now we can navigate to our Spring Data Boot application class and begin to write our logic. So the run method returns a type of application context. So we're just going to assign that to a variable named context of type application context. And then we're going to pull out the book repository from that context. So I'll just call that repository, and we can get a bean, and we'll just specify the book repository as the type of the bean we would like. And we can now work with that repository in order to persist a book. So let's build out a book first. So we'll set the title on the book, we'll set the page number, and we can set the publish date simply to a new date. We don't need to set all of the fields on this entity for our example. And then we simply use the repository to save our book. And at this point, we have built our Spring Data application, which has been configured using Spring Boot. You'll notice we didn't have to provide much configuration because that is all done behind the scenes by Spring Boot. So we can now run this application. So just right-click within the editor, go to Run As, and then you can select Java Application. And at that point, you'll see the console fire up. And if we expand the console, we will see that our entity has been persisted. So this is how quickly you can establish a Spring Data project with Spring Boot. One caveat to this is that Spring Boot is relatively new. Many folks do not have it running within a production environment, and it does cover up some of the details of your project's configuration. In this lesson, we will set up our base project that we will be using throughout the course. So as we work through the course, we're going to be learning how to use different configuration types and how to configure Spring Data for different data stores. When we encounter one of these new configuration types or a configuration for a different data store, we're going to revert back and use this project as our base. To get started, we're going to go to File on the menu and click on New, and then we're going to go down and click Maven Project. Check the first checkbox which says Create a Simple Project, and then click Next. Now we must enter a group ID for our Maven project, and that's going to be tom.o'reilly.sdata. And now we must specify an artifact ID. And the artifact ID that we're going to use is spring-data-course. We'll also use this as the name of our Maven project, and we will not provide a description because it's not necessary. With that in place, simply click on Finish, and our new Maven project will be built. So if you're familiar with Maven, you know that a Maven project contains a pom.xml file, and that can be found by expanding the course within the Package Explorer, and then scrolling down to the pom.xml file. And when we open that file, you're going to see a user interface provided within STS that allows us to work with our POM. The POM provides a list of the artifacts that our project is dependent upon, and they're referred to as dependencies. So if we click on the Dependencies tab, we are able to specify the artifacts that we need to build out a Spring Data project. Now, there are multiple modules within Spring Data, and some of them have different major and minor version numbers. To help us out with this, the folks at Spring have created a BOM, or a bill of materials, and it helps facilitate aligning the different versions when we work with Spring Data. In order to add a bill of materials, we simply navigate to the Add button within the Dependency Management section, and we put in Spring-Data-Release Train, and here you'll see that we get this artifact, and if we expand it, we see all of the different releases for Spring Data. Now you'll notice some have numbered versions with major and minor versions, and then others have names. And if you recognize these names, it's kind of cool what they did. These are the names of some famous developers. So currently they are on the Gosling release train. And so if you're familiar with James Gosling, he is one of the founders of Java. And we put that POM in place, and that's going to specify the versions that we need for our different dependencies, and then we don't have to sort that out. Now, one thing you'll need to do is you'll need to click on that artifact and then hit Properties and change your scope to Import, and then simply hit OK. So at this point, we have added our bill of materials, so we can proceed with adding our Spring Data dependencies. And the dependency we want to work with is the Spring Data JPA dependency. This first section of the course will deal strictly with JPA. And if we scroll all the way down to the bottom, we will see the org.springframework.data group ID. And we want to use the official Spring libraries, so we want to stay within that group ID. And you'll see that it initially puts the version, but you can just remove that version and then hit OK. And once we do that, we can save our pom.xml file, and you see that the version is specified for you, and it indicates that it is managed, and that came from the bill of materials. The next thing we need to do is to provide our JPA implementation. So we're going to add the Hibernate Entity Manager, and we'll want to use the org.hibernate group ID, and that will give us the latest entity manager from Hibernate. So that's our JPA implementation. Next, we'll add our database. So just click on Add, and then just type in the group ID of com.h2 database, and then select the h2 artifact. Next, we're going to add the dependencies for our logging framework. So we're going to use SLF4j on top of log4j. So we need to add several dependencies here. The first one that we'll add is the SLF4j API. And once again, we're going from the folks at SLF4j. So make sure you're within the org.slf4j group, and then simply pick out the API and add it. Next, we need to add the SLF4j log4j 12 artifact, and we'll pull that from the org.slf4j group. And then finally, we will add log4j itself. So I'm just going to click on Add, and then log4j, and this one's always hard to find. But if you scroll down, you'll see the log4j artifact, and we can add that in. And it always comes back as a bundle, so you need to change that to a jar file within the properties. So I just clicked on Properties, went to Type, and changed it to jar. At this point, we can save our pom.xml file, and we have the necessary libraries in place in order to work with a Spring Data JPA project. Now, as we work with different data sources in the course, we'll be changing this up a little bit, but as far as the configuration types, we won't need to modify that. So now let's take a look at our project, and you'll notice on the left side of our screen that we're using Java version 1.5. Not recommended at this point. Java 8's out, it has lambdas, all sorts of other goodies out there, streams. So we'd like to take advantage of those. So we're going to swap out our JRE version that Maven has specified for us. So just right-click on that JRE system library, and then click on Properties, and here you can see that you can change your execution environment. So currently I'm using my 1.8 JRE, but I'm restricting myself to 1.5, so let's go to the Java SE-1.8 version, and now we will use a more up-to-date version of Java. You can also just click on the Workspace default JRE if you have a favorite setup that you like to use, and that's what I'm going to go ahead and do. The last thing we'll do is add a log4j.properties file to our source main resources directory to configure log4j. So just use the new dialog and insert a new file and name it log4j.properties. And within your working files, you will find a log4j.properties file that will contain this configuration. So I've just copied it in place. We're not going to cover log4j and go over it in detail. But with that in place, it completes the configuration of our project, and we'll be referring to this project when we need to revert to our base project in the course. When building a Spring project, one of the options we have is to configure the project using Spring's Java configuration. In this lesson, we are going to create a Spring Data JPA project that is configured using Java. To get started, we're going to create a new class within our base package, and we'll call this class Data Configuration. We're going to annotate this class with the configuration annotation to specify to Spring that we're going to be defining beans within this class. Next, we're going to enable JPA repositories, and we need to tell Spring Data where to find our repositories. So we provide a package name, and in our case, it's going to be com.o'reilly.sdata. Next, we need to enable transaction management so that we may use the transactional annotation on our methods contained within our beans. Finally, for our last class level annotation, we need to enable component scanning so that Spring can go find our beans that we have declared within our project. Once again, we're just going to scan the entire base package. At this point, we're ready to start declaring beans within our configuration class. So the first bean that we need to add is the data source. So I'm going to declare a method that returns a type of data source, and that's a java.sql.dataSource, and its name is data source. Within the body of this method, I'm going to use the embedded database builder in order to construct our data source. So we'll invoke the noArgument constructor, and then what we're going to do is we're going to invoke the setType method on the builder, and then we specify an embedded database type of h2, and then we invoke the build method on the builder, returning our data source. So at that point, we have our data source configured, and we're able to move on to our next bean. Our next bean is going to be of type Entity Manager Factory, and we're going to name this method Entity Manager Factory also. So within the body of this method, we need to construct our Entity Manager Factory. To do that, we need to inject several properties on that bean. So the first one is the Hibernate JPA Vendor Adapter, and I'm just going to name this object Vendor Adapter. And we can invoke the noArgument constructor on this object, and then we can start to set some of the properties on the vendor adapter. The first property that we are going to set is the generated DDL property, and we'll set that to true. This will tell the JPA vendor implementation, which is Hibernate, to automatically construct our tables when we start the application. And that's specifically the point of a vendor adapter. We're specifying our different JPA properties. We can also specify specific vendor implementation properties for Hibernate using a regular properties object. So we're going to create a new properties object, and we can invoke the noArgument constructor to build out the properties object, and then we can begin setting properties on this object. The first one we'll set is the Hibernate HBM2DDL.auto property. And this tells Hibernate to auto-generate our DDL and what approach to use when it does. So here we're saying create the tables once we start the application and then drop them once we close the application. The next JPA property that we're going to specify is the Hibernate.dialect property. And we're going to set this property to org.hibernate.dialect.hsql dialect. So this is telling Hibernate which database vendor we are using so that it can properly format our SQL. Next, we're going to create our Entity Manager Factory bean, which will build our Entity Manager Factory. So to do that, we're going to use the local container Entity Manager Factory bean, and I'm just going to name this object Factory, and then we can invoke the noArgument constructor, and then we can start setting the properties on that Factory bean. The first one we set is the data source, and we can do that by invoking our data source method. Next, we want to set our packages to scan, and this is specifying which package contains our entities. So once again, we're just going to use our base package of com.o'reilly.sdata. And now we can set our JPA vendor adapter. So we pass in that vendor adapter that we have just constructed. And then we can pass in our JPA properties. So there we pass in those vendor specific properties. And then after all this is done, we invoke the afterPropertySet method, which is a method on the initializing bean interface that the local container entity manager factory bean implements. And with all that, then we return the actual entity manager factory by invoking the getObject method on our entity manager factory bean. So it's quite a bit of configuration there of that bean, but we're all said and done. We have our entity manager factory. And then there's only one last bean that we need to provide, and that is a platform transaction manager. So we declare a new public method that returns a type of platform transaction manager, and then we will name this method transaction manager. So to create our platform transaction manager, we're going to declare an object of type JPA transaction manager, and we'll just call that TX manager. And then we will invoke the noArgument constructor on that object. And then we're just going to set the entity manager factory property on this object by invoking our entity manager factory method. And that's going to inject the entity manager factory, marrying up our platform transaction manager with our entity manager so that we can conduct our persistence operations within transactions. And then simply after we have injected that property, we just return the transaction manager, and that completes our setup of our Spring Data JPA project. In this lesson, we will learn how to bootstrap our Spring Data JPA project, which has been configured using Spring's Java configuration. Before we get started, there's a few pieces we need to add to our project. The first piece that we'll need to add is our repository. So within Spring Data, repositories are always interfaces. So I'll open up the new dialog and I'll type interface to create a new interface. We'll name our interface Book Repository after the entity that is going to be persisting. Now, we need to have our book repository extend Spring's JPA repository interface. In order to complete the configuration of the JPA repository, we need to provide two type parameters. The first type parameter is the type of the entity that we will be persisting using this repository, and that is the book type. The next type parameter is the type of the entity's ID, which is a long type. After we've provided this configuration, we can click on Finish, and our new interface will be created. Just to be explicit, I like to add the repository interface to the newly created interface. The next piece we need to add is a service. So we're going to create a new class, and I'm just going to call this class Book Service. We'll hit Finish, and our new class is created. The first thing that we need to do is we need to annotate this class with the service annotation so that when the component scanning occurs in our project, this class is picked up and made a bean. Now, once this class is a bean, we can auto-wire the fields on this class. So we're going to add a book repository field to this class, and we'll auto-wire it using Spring. Once we have our field auto-wired, we're going to use the repository within a method that we will call save, and this save method is going to accept an argument of type book, and we'll name the argument book. Now, within the body of this method, we're going to use our repository to save the book entity that is passed into this method. So at this point, we have a book repository created and a book service that has the book repository being injected into it so that we can perform persistence operations within our service. I'm going to go ahead and save these two classes, and now we're going to begin to build out our application. So I'll create a new class, and I'll name this class Application. Within the application class, I'm going to add a main method so that we can perform the logic of our application. The next part is very important. It's how we bootstrap our Java configured application. So we use an annotation configuration application context. And I'm just going to call this new object context. And then what we can do is we can use a annotation config application context constructor that accepts a class. So let's maximize our editor here so we can see everything. And we see our constructor, which accepts a class. And what we'll do is we'll pass in our data configuration class, which contains all of the configuration that we have specified for our project. So here we see the data configuration class, and it's defining these three beans that contain our JPA implementation and how we have configured those beans. And it's also establishing some component scanning as well as enabling our JPA repositories. So we pass that class into our application context. And then what we can do is use the try with resources syntax in order to ensure this resource is closed once we're done performing our logic. So within this context, we will have a book service bean. So I'm just going to declare a new object of type book service with the name of service. And then we're going to pull that bean from our context by type. So we'll pass in a book service class to the getBean method, and that's going to retrieve our book service bean. Next, we will construct a new book using a constructor that accepts the title. So we'll just say first book. It also accepts the date published, so we'll use a date object that will pass in, and that will just be today's date. Then they want a page count as well as the price, which is a big decimal. So we'll say our book cost $26. It has 33 pages. Its title is first book, and it was published today. Next, we'll take that book entity, and we will pass it into our service's save method, which will in turn invoke the save method on our repository. So we can kick off this application by right-clicking within the application and going to run as and clicking on Java application. And then we see within our console that our application runs and our entity is persisted. So let's talk a little bit more about what happened. So we created this annotation config application context and we passed in the data configuration class. The data configuration class is a Spring Java configuration class that defines the configuration for our Spring Data JPA project. One of the important pieces is this enable JPA repositories annotation, which specifies a package to scan for the specific repositories in our project. Also, we component scan that package in order to find any beans that we declare. We declare our JPA components within our data configuration class, and once the project begins to bootstrap, we perform our scanning. So we detect the repository because of the JPA repositories annotation, and that is implemented and made a bean. Next, we detect our service and we inject our repository. So now we have a service loaded with a repository capable of performing data persistence. If we look in our application, we're pulling that from our context, creating a new entity, and then persisting that entity to our data store. So this should give you an idea of how a Spring Data application is configured and constructed using Java configuration. In this lesson, we will learn to configure a Spring Data JPA project using XML configuration. XML configuration was the first available option for configuring Spring projects. To get started with XML configuration, simply expand your Spring Data course project and within the source main resources directory, create a new Spring Bean configuration file. So we'll use the new wizard and we'll select the Spring Bean configuration file. And now we need to provide a name for our configuration file. I'm going to name my configuration file applicationcontext.xml. With that name in place, we can click on Finish, and STS will generate an XML file for us to specify our configuration of our Spring Data JPA project. At the bottom of your screen, you'll notice several tabs, and we want to click on the Namespaces tab. Namespaces are a way to provide basically shortcuts for XML configuration. Spring provides several namespaces that we're going to utilize to build our project. The first is the context namespace, which we'll include, as well as the JDBC namespace, which will help with our data source, the JPA namespace, which is contained within the Spring Data JPA project, and then finally the transaction namespace, which helps us enable transactions for all of our persistence operations. With those namespaces selected, I'm going to save the application context and then navigate back to the Source tab. At this point, we can begin specifying our configuration with the help of these namespaces. The first piece of configuration that we'll put in place is some component scanning. So we're going to component scan our project to pick up the classes that are annotated with the service annotation, the repository annotation, or the component annotation. And to do that, we just specify our base package of com.o'reilly.sdata. And you notice that Spring Tool Suite is helping us out with some autocomplete there. So it's always helpful to use that so you don't have any typos. The next thing that we'll specify is our JPA repository location. So once again, we're supplying a package, and it's going to be the com.o'reilly.sdata package, and we can close that tag off. Next, we will set up our transactions. So we use the transaction namespace, and we just say that they are going to be annotation driven. And now we can use the transactional annotation within our Spring Beans to make our method invocations transactional. Next, we will declare our data source by using the JDBC namespace. So I'm going to use the embedded database tag within the JDBC namespace. And there are two attributes on this tag we can set. The first is the ID, which I'm going to set to data source. And then we can specify our type, and we can use IntelliSense to help us out here to select H2. And there our data source is configured. Next, we'll declare a bean for our entity manager factory. So we'll give this bean an ID of entity manager factory, and then we have to specify the type of our bean using the class attribute. And once again, Content Assist can help us out here when making sure that we get our class name correct. So there's the local container entity manager factory bean, and now we can provide several properties to this bean. And the first will be the packages to scan property. And here we're just going to be pointing at our package, which will contain our entities. And we have the book entity within the com.o'reilly.s data package. So we'll go ahead and specify that value. And then we'll move on to our next property, which is actually our JPA properties. To set these, we'll use the props tag within our configuration, and this allows us to set a set of properties that we can configure our Hibernate entity manager with. So the first thing that we're going to set is the hibernate.hbm2ddl.auto property. And for the value, we're going to specify create drop as our strategy. We've discussed this. And then we're going to specify one more property. We set the key to hibernate.dialect. And now we provide a value. And our value will be the org.hibernate.dialect.hsql dialect. So we're specifying which database vendor we're using so Hibernate can get our SQL correct. This should all look familiar. We're just using a different syntax at this point. We also need to provide our entity manager factory bean with a reference to our data source. So we'll just reference our data source bean. And then finally, to complete this bean configuration, we need to provide a JPA vendor adapter. And this allows us to specify our JPA properties to our JPA implementation. And when we use this, we can avoid making a persistence.xml file, which is always nice to keep your configuration consolidated within the same spot. So we specify a bean as the value of this property, and this bean needs to have a type defined, and we'll specify the type as Hibernate JPA vendor adapter, once again taking advantage of IntelliSense. And now we have a single property on that bean to set, and that property is the generate DDL property, and we're just going to set that value equal to true. We can also configure the show SQL property while we're here so that the SQL is displayed when we execute our persistence operations. So that wraps up the configuration of our entity manager factory bean. And now we just need to provide one final bean for our transaction manager. So we'll give this bean an ID of transaction manager, and we're going to specify its type, which will be a JPA transaction manager. And then we're going to have one property to set on this transaction manager. And if you remember, it's the entity manager factory, and we just provide a reference to our entity manager factory bean. So that will set up our entity manager to use transactions so we can persist entities as part of one atomic commit. And that wraps up our configuration. So if we look at our project, you'll see that I have left the entity book, the repository, book repository, and our service in place. So now we just need to specify our application's logic. And to do that, we will bootstrap our application by using a class path XML application context. So I'll just call that context. and then we'll invoke that application context using a constructor. And all we do is we provide the name of our XML file that contains our configuration. So we provide the value of application-context.xml because it points to our Spring Bean configuration file. Now you'll remember we had the book service. So we'll pull that service from our IOC container by invoking the getBean method, and then we'll pass in the book service type. Now we need to create a book. So we'll use the constructor. Let's go catcher in the rye, and we'll say it was written today. That's obviously not true, but we'll import the date annotation. We'll say it's about 250 pages long, and if we're selling it, it's going to cost $15. Okay, so we have a instance of book which serves as our entity, and then we use our service to save the book into our data store. Okay, so with that in place, we'll go ahead and we'll run our application. And if we look at our console, we see our IOC containers start, and then you can see that we did indeed persist the book into our data store. So in conclusion, this lesson taught us how to configure a Spring Data JPA application using XML configuration. We saw the various components that Spring Data provides us out of the box that really help us stand up our applications more quickly. In this chapter, we'll take a look at some of the basics of using repositories within Spring Data to perform our CRUD operations. Within Spring Data, repositories are defined as interfaces. Often, we will create our own interface which will extend one of the repository interfaces provided by Spring Data. The Spring Data project is then able to detect these interfaces and build out their implementations. And this allows us to perform data persistence operations without providing the implementation ourselves. That implementation is provided by the Spring Data project. Within this chapter, we're going to learn more about the repository interface, and particularly we'll take a look at the repository type hierarchy. So within Spring Data, you'll see that the basic interface is the repository interface, and this serves as a marker interface for the framework. Further down the type hierarchy, you will see the CRUD repository interface, and that's going to have a lot of your basic CRUD operations, allowing you to save entities, delete entities, to find entities. Spring Data also provides a paging and sorting repository, which provides us some mechanisms for retrieving our data in pages, as well as performing different types of sorts on our entities that we return. Primarily in this chapter, we'll be working with the JPA repository, which extends the paging and sorting repository. So we will define our own repository interfaces that correspond with our entities and extend the JPA repository interface. Within our lessons in this chapter, we'll be using the JPA repository interface to perform CRUD operations against our data stores. So we'll take a look at the available operations or methods on these repository interfaces and how we can use them to persist our entities to a data store. Finally, we'll take a look at how we can modify the methods exposed on our repository definitions. Spring Data allows us to pick and choose which methods from the underlying type hierarchy can be exposed on a custom interface that we create. In this lesson, we will learn to work with the methods on our repository that allow us to retrieve instances of an entity from our data store. If we explore our book repository interface, you'll notice it extends the JPA repository interface. And in turn, that interface extends the paging and sorting repository, and that interface extends the CRUD repository interface, And the CRUD repository interface actually extends the repository interface, which is just a marker interface. The CRUD repository interface contains all of the methods that we will work with when persisting our entities. In this lesson, we are particularly interested in the find one method, as well as the find all method, and the find all method, which will accept a list of IDs. So let's close those interfaces. And before we are able to actually query for any entities, we need to add some entities into our data stores. So we need to put some records in there to return. So you'll see that we have this init.sql file, and it adds roughly 7 books into our H2 data store. Now, in order for this init.sql file to be executed, we need to configure a Hibernate property within our JPA properties. So I'm just going to duplicate one of the properties, and we'll change its key to the Hibernate HBM2DDL.import_files key. And this allows us to specify a file that should be ran after our DDL is created. So this is a great place to put our init.sql file, which will then populate our data store with the records that we have created. So I'm going to go ahead and close our configuration file, as well as our SQL file, and now our repository. And this will allow us to explore the retrieval methods on the repository interface. To get started, the first thing that we need to do within our application is pull the book repository bean from our Spring IOC container. So I'm going to declare a new object of type book repository that is named repository, and then I will invoke the getBean method on our context to pull the book repository bean from the Spring IOC container. And you see that I'm simply providing the type of that bean that I would like. With the repository pulled from the IOC container, we can now begin to retrieve our books from our data store. So I'm going to declare a book object, and then I will use the repository and its find one method to retrieve that book. Now the find one method just accepts an argument with the key of our entity. So in our instance, the book is keyed by a long, so we need to provide a long to the find one method that corresponds with the ID of the book we'd like to retrieve. So we're going to retrieve the book with the ID of 1. Next, I'm going to send that book to the console by just passing it to the system.out.println method, and we have implemented the toString method on the book object. So with this in place, we're going to run our application, and you'll see within our console output that we have printed out all of the fields on the book that corresponds with our toString implementation. And then you'll notice that we have this SQL that was executed on our behalf by the repository. And you'll notice that it includes a where predicate where it is inspecting the ID of the book and using that to discern which book should be returned. So now let's return to our application, and we're going to take a look at the find all method. The find all method is used to retrieve every entity instance within our data store. So we're going to pull every book record from our H2 embedded database. Because we're returning more than one book, we need to use a collection, and we'll change the name of our object to match that we are returning more than one book. So we'll go with books as our name. And if you look at the find all method, you see it returns a list of your entity. Now that we have this list of books that corresponds with every book in our data store, we will iterate through that book and print out the value of its fields so we can see what books we have returned from our data store. Now you'll want to be careful. In our case, we only have 7 records. But could you imagine if we had, let's say, a whole college library here full of books, so maybe hundreds of thousands of books? We want to be careful when using the find all method in instances where there is a large set of records. So let's run this demonstration. We'll take a look at our console and see the output we get. So first, let's take a look at the SQL statement that was generated by our behalf. You notice that there is no longer that predicate or that where clause, which is going to discriminate against which books are returned. Instead, we are returned every book within our data store as we expected. Now let's look at one final method on the repository interface, and that is the findAll method that accepts an iterable of all of the IDs that we would like to see returned for each book. So we're going to pass in a collection of IDs, and the findAll method is going to return all of the books that have IDs matching those in our collection. So in a sense, we're not really finding all, we're being a little bit more picky about what we're returning. So to do this, I'm going to pass an array list of longs to our findAll method. And I'm going to use double brace notation to construct our array list. It's a nice concise way of building out a list. And we'll pull back the book with the ID of 1, the book with the ID of 3, and the book with the ID of 7. So we should only get 3 books this time. And you'll notice that we're going to get some complaints regarding not adding the serialized ID to our list. We don't have to worry about that. That's more of an Eclipse issue. So by passing in this collection of IDs to the findAll method, we're able to retrieve multiple books, but at the same time, we're able to specify which books we'd like to retrieve. So let's go ahead and run this example, and we'll inspect our console output. And you see that we have indeed received 3 books back. And if we inspect the generated SQL, you see that Spring Data has now used an in clause in order to selectively choose the records that we would like to see returned. You'll notice there is a parameter for each of the 3 values we provided. So that's Spring Data in action. It's customizing that SQL we're executing against our data store, and we're not doing any of that work. We did not write any SQL. The Spring Data project performed all of the work for us that was required to retrieve our entity instances. In this lesson, we will learn to insert or add new entity instances to our data store using the save method on our Spring Data repositories. To get started, we're going to build a new book entity instance. So I'm just going to create a new book using the noArgument constructor, and then we'll set the title on the book. We'll set its page count, as well as its price and its publish date. We'll import those types, and then we'll simply use our repository and its save method to insert our book into our data store. So with that code in place, we will run our application, and if we check out our console, we see that our new book has been inserted. Pretty simple, we've seen this before. But what we haven't seen is that our repository is capable of persisting multiple books at a time. So what I have done is I have built out a book utility class that is capable of building multiple books. So we're going to create a list of books, and to instantiate all those books, I'm going to use this book util class. And we can invoke its create method and specify how many books we would like to have returned within a list. So there we have declared a list of books, and there will be 5 books within the list. And using the overloaded save method on our repository, we're able to provide multiple entities to be persisted at a single point in time. So if I save our application, I'm just going to run the application, and if we take a look at our console output, we see that the 5 books within our collection were persisted to our data store. So that's just another angle that you can use with your repositories when persisting new entity instances. One thing that you should be aware of is that Spring Data determines that an entity instance is new by looking at the ID field on the entity. So in this instance, Spring Data saw that our books did not have IDs, and therefore it determined to insert our entities as opposed to performing something like an update. In this lesson, we are going to take a look at how we can use the save method on our repository to update an entity. So to begin, we're going to retrieve a book entity from our repository by invoking the find_one method. And we're going to return the book with an ID of 1. After we retrieve the book, we're going to print the book to the console, and then we're going to set the title of the book to War and Peace. Next, we're going to pass the book to the save method on our repository. So we invoke save and we pass in the book as an argument. And once again, we're going to print out our book so that we can see the changes that have been made. So let's save our code, and now we're going to go ahead and run this example. You'll notice if we inspect our console that we will retrieve a book from our repository, and it's going to have an ID of 1, and the title of this book will be Of Mice and Men. Next, we're going to execute an update on that record, and we will change the title to War and Peace. So there's an important thing going on here that we should talk about. When we pass an entity to the save method, Spring Data will inspect the ID of the entity to determine whether or not to perform an update or an insert. So for instance, if we were to modify the ID of the book, so I'm going to invoke the setID method, and I'm just going to pass it a value of 1000. So we know that 1000 is not an ID of any book within our data store. So what will happen is when this entity is passed to the save method as an argument, Spring Data is going to determine that we need to perform an insert instead of an update. So let's go ahead and see this in action. Once again, I'm going to execute our application. And now if we inspect our console output, you'll see that we retrieve our book. It has an ID of 1, and there's the title Of Mice and Men. Now remember, at this point, we have now changed the ID on that object to 1000, and you'll see that Spring Data was intelligent enough to now perform an insert. So returning to our class file, here we can see how the impact of setting the ID on our book caused Spring Data to intelligently select the type of operation we wanted to perform on our data store. So when working with our save method, it's important to know the different types of operations that may be performed given the state of our entities. In this lesson, we're going to look at several approaches to removing entities or domain objects from our data stores. The first approach we're going to look at is by using the delete method on the repository that accepts an ID. So we can simply provide a long to the delete method, and if we look at our console output when we run this example, you see that we get this simple delete from book where book ID is equal to the ID we provided. We can also provide an entity to the delete method. So if we were to use the repository to find an entity, we can then pass that entity into the delete method, and it will be removed from our data store. So there we see, once again, that we are deleting the book from our table. The repository interface also provides an overloaded delete method that allows us to provide a collection of entities to delete. So for example, we can use our repository to find a collection of entities. So I'm just going to select 3 entities from our repository, and I'll pass them to the delete method, and those entities will be deleted from our data store. So we'll save our changes, and now if we run our example, we see that all 3 entities were deleted from our data store using single delete statements. Another approach that we can take to deleting multiple entities is by using the delete in batch method. And this will delete all of the entities passed to the method in one single query. So if we change this to delete in batch, and we once again execute our application, you'll now notice that we only use one delete statement, and we have several predicates that are bound together via OR clauses. This is a little bit more of an efficient approach because we're not executing multiple transactions against our database. Finally, we're going to take a look at the delete all method on the repository. And delete all does what you would expect. It just removes every record from the table for that entity. So there you see, we drop every book within our book table. So you want to be careful when using the delete all method. There's probably very few instances where you would want to invoke that method. Another thing to note that the delete all in batch method exists, and instead of issuing a statement for each entity, once again, we're just going to have a simple single statement that is executed to remove all the entities from our data store. And when we're talking about any of the methods that are in batch, those methods are specific to our JPA repository. Another thing to note is that when we are talking about our methods that perform the operation in batch, they are specific to our JPA repository interface, and they are not found on the CRUD repository interface. So in this lesson, we took a look at several approaches that we can use to remove entities from our data store with Spring Data. When we work with a repository, such as the JPA repository in Spring Data, there's quite a bit of inheritance going on between these interfaces. So for example, the JPA repository extends the Paging and Sorting repository interface, which extends the CRUD repository interface, and we're exposing all of the methods on those interfaces. Sometimes it is preferable not to expose every method on the repository interface type hierarchy. So for example, maybe we don't want to provide the ability for a user to delete an entity, or maybe we don't want them to be able to delete all entities, or maybe we just want to make it a read-only repository and we just select a few of the find methods to expose on a repository. Luckily for us, there is an approach we can use to fine-tune the methods that we expose on our repositories. So I'm going to close all of our repository definitions, and we're going to work to build out our own repository interface that can be used within Spring Data. Our new repository will only expose some read operations on its interface, so we are selectively choosing which methods to expose. To start, we're going to go to our Package Explorer, and within the com.o'reilly.sdata package, we're going to create a new interface. And we're going to name this interface Read Only Repository. This repository interface will extend the base repository interface within Spring Data. Once we have extended our interface, we'll click on Finish, and now we see that our interface is defined. And we need to add some type parameters to our read-only repository. The first will just be the type, and the second will be the ID, and that ID is going to be serializable. So this interface sits within our com.o'reilly.s data package. And if we look at our configuration for the application, you will see that we are scanning this directory for repositories. So if Spring Data were to scan and pick up this class, because it extends the repository interface, it would attempt to create an implementation of this interface. And that is not something we'd like to see happen. In our case, we would only like to extend our read-only repository interface and then have an implementation built out for a particular entity. In order to prevent that, we provide the no repository bean annotation on our interface declaration. And this will prevent Spring Data from picking up our interface and building out a repository. With this annotation in place, we will save our interface, and now we're going to choose some methods to expose. The first method we'll expose is the find_one method. So it returns the type of our entity, and it takes the ID as a parameter. We'll also expose the findAll method, which returns an iterable type of our entity. It's very important that when you declare these methods, that their declaration matches those in the underlying Spring Data repositories. So for example, these methods are found within the CRUD repository, and the signatures need to match what is found in the CRUD repository. At this point, we can navigate back to our book repository, and we will change the repository to extend the read-only repository instead of the JPA repository. And once we save this change, we should get a compilation error because we are no longer exposing the save method on that repository. So let's remove all this code, and we can just execute the find_one method to ensure that our repository is working. And if we look at our console output, we do indeed see that our book is returned. And if we return to our editor, you'll notice that if we look at the exposed methods on our repository, we only have the findAll and find_one method, and then all of the methods associated with the object class. So this concludes our lesson on how to fine-tune your repository definitions in order to customize how we expose different operations. Within Spring Data, there are two ways to define queries. One way is to manually define a query, and the other is to derive a query from a method name. In this lesson, we're going to learn all about derived queries. As a refresher, we're going to revisit a previous slide which discusses derived queries. Derived queries simply look at a method on a repository, and depending upon the structure of the method name, the query will define particular constraints. So here we see a find by first name method, and that corresponds with creating a query that contains a constraint on the first name column. As we include different keywords and specify different attributes, our queries will change. In this chapter, we're going to learn roughly 80% of the keywords that are available to us, and that's going to help us learn to shape and refine our queries to get result sets that we would like to see. So the first objective we have in this chapter is to understand how we construct a derived query, and we'll walk through the syntax as well as the keywords that are associated with these queries we construct. And as we learn these keywords, we're going to be able to develop very specific constraints that target the data that we are looking for within our applications. We'll also learn some extra techniques that teach us how to order our result sets or limit the size of the result sets returned by our queries. Finally, we'll learn how to create constraints that actually transverse nested properties within our entities. Throughout this chapter, you will see the flexibility of working with derived queries and all of the keywords associated with them. You'll see that it's very easy to construct a query that meets the needs of your application. You will no longer be writing out the appropriate query in the respective language of your data store. Instead, you will be defining queries using method signatures, and this is going to save you time and keep you abstracted away from the underlying query language. You'll also notice that as you construct these queries, Spring Data has constructed the keywords in such a way that you really do create self-documenting code. And once you read the name of one of your query methods, you can pretty much assume what will be returned within that method's result set. One of the most useful features of the Spring Data project is the ability of the project to derive queries from our method signatures on our repository interfaces. Using the derived query approach, Spring Data is able to inspect a method signature on a repository, and from that method signature, it will create a query with the appropriate clauses to select our entities in the manner that we have identified. So, for example, if we were to create a new method on our book repository interface, and we'll have this method return a book, and we'll name this method find by title, and then we'll specify a parameter of type string, and we'll name this parameter title. Spring Data will inspect this method signature and notice that the method name has the find by prefix. Because it has this prefix, a query builder in the background will strip off the prefix and then inspect the next portion of the method name. And it sees that portion is title. And if we look at our book entity, we see that there is a title field. Using this information, Spring Data is able to generate a query with the appropriate predicate that we can use to return entities by title. So it's a lot simpler if we just take a look at an example. So we're going to navigate to our application, and we have our book repository defined, and we're just going to print out the result of invoking the find by title method, and we're going to look for the title Animal Farm. So once we have invoked this method, we'll go ahead and execute our application. And if we look within our console, you'll see that we have selected a book, and that is the Animal Farm book. What we're going to do, we're just going to copy this query out of our console output, and we'll return to our book repository, and we'll paste in that query to see exactly what happened. So I'm just going to format our class, and we'll take this hibernate prefix out. And you'll notice that Spring Data generated a query where we are looking within the book table, and it appended this predicate where the title is equal to some parameter. And the parameter value is the value of the argument that we supply to this method, and it determined which column to use for the predicate by looking at the name of the field after our find by prefix. So this was just a general look at how Spring Data is able to derive queries from our method signatures on our repositories. The query builder mechanism within Spring Data is able to inspect any method that has the prefix find by, read by, query by, count by, or get by. When it encounters these methods, it parses them out in order to determine the appropriate clause. As you'll see, these method signatures can increase in complexity, and that allows us to introduce different behavior into our queries. we'll see that there are Boolean logic operators that can be introduced, and there are other sorts of comparisons that we can perform. In this lesson, we will take a closer look at how Spring Data derives queries from our repository methods. In particular, we're going to look at some keywords that can be added to our method names that support string comparisons. So to begin, I'm going to add some new methods to our book repository. Our first method is going to return a list of book entities. So we declare that as the return type, and then we use the find by prefix followed by the field name that we would like to query by. Now, what's different about this method is we're going to add the like keyword, and then we'll provide the string argument to this method. The like keyword is going to cause a like predicate to be added to our query. So I'll go ahead and import our list. Next, I'm going to copy this method because we're going to create another method that uses the containing keyword. And the containing keyword is similar to performing a like clause with wildcards surrounding our argument. Once again, I'll copy our method, and we're going to add another keyword, which is the starting with keyword. And this will simply return all of the entities whose title starts with the supplied argument. Very similar to starting with is the ending with keyword. This keyword will trigger Spring Data's query builder to return all entities that end with the argument that we supply to the method. Finally, we'll add another method that performs a case-insensitive comparison by using the ignore case keyword on our method name. So with these methods on our repository, let's go ahead and run some demonstrations with them. So to get started, I'm going to add a loop within the body of our main method that will iterate over every book returned by our find by title like method. So within the body of this loop, I'm simply going to print out the returned book as we iterate over the collection. Now, in order to use our method, I need to provide a string that will go into the like clause as the parameter. Now, you'll want to remember that you can use wildcards within this string. So I'm just going to look for all of the titles that contain the word of. So I'll save our application and we'll run this example, and we'll see that we return 4 books that contain the word of in their title. Now, if we return back to our application, we can receive very similar results by executing the find by title containing method and simply providing the of string to this method as an argument. The containing keyword will cause wildcards to be placed before and after the supplied argument. So I'm going to save our class and we'll run through our demonstration again. And you'll notice that we get the same result set. And if we actually look at our query, we see we are executing a like statement and that we have provided the wildcards for us. So returning to our application, we are next going to demonstrate the find by title starting with method. And for this method, we're going to find all of our titles that start with O. So we'll simply run through our demonstration, and we'll see in our console output that we have 2 books that start with the letter O. Notice that this is a case-sensitive search. Returning to our editor, we can also test out the ending with method, and we'll look for all of our books that have a title that ends with S. Once again, if we inspect our console output, we'll see that we have 5 books that end with an S. Navigating back to our application, we have one last method to try out on our repository, and that is the find by title ignore case method. And we're just going to provide the animal farm title in all uppercase. And you'll notice now when we execute this method that the query is executed in a case insensitive manner. You see we return animal farm, and if we look at the derived query, we see that it uses the upper function on the column and the argument that we provide. So you can see when looking at our repository methods that there's a variety of keywords that we can use to dictate how we will conduct our searches. One thing that's very nice about these keywords and the whole idea of deriving these queries is that it lends itself to writing self-documenting code. It's very easy to look at these method names and determine what you're trying to achieve with your query. So this concludes our look at the string comparison methods that we can use within our method signatures when using Spring Data. In this lesson, we're going to take a look at some keywords that we can use within our method names to perform relational comparisons within our derived queries. To begin, we're going to add a few methods to our book repository. All of these methods will return a list of books, and they're all going to start with the find by prefix. The field that we'll be using for these methods is the page count field. So we'll go ahead and add this simple method to our repository, and then we're simply going to add the equals keyword to the end of our find by page count method name, and then we'll pass in a page count to this repository method. This will allow us to find all books with a page count equal to the supplied parameter. You'll see that we can use all sorts of relational operators within our method signatures. So here we have used the equals keyword. We can also go ahead and use the greater than keyword, and this would return all books that have a page count greater than the supplied parameter. Now, along with the greater than keyword, there is also the greater than equal comparison. So here we would actually include our supplied parameter within our search results. So if we provided a value of 100 in this query method, we would return the books that have 100 pages, while this query method would not include those books. Now, it's pretty easy to guess that if we have a greater than keyword, we also have a less than keyword, as well as a less than equal keyword. So you can see we cover all of our bases as far as relational comparisons go. The final keyword that we're going to take a look at is the between keyword. So the between keyword is going to actually accept 2 parameters. So we'll put a min and a max, and it's going to find all of the books where the page count is between our supplied min and max. It's important to point out that these relational keywords can only be used in situations where we are looking at a field that has implemented the comparable interface. So in this case, we will actually see that the page count field is an integer, but it will be auto-boxed up into the actual integer type, which is an object, and that type has implemented the comparable interface. So let's go ahead and test out a few of these. I don't see the need to test out every one, but we'll test out the equals and maybe the less than, as well as the between queries. So I'm just going to go to our application, and once again, we're going to iterate through a list of books that are returned by a repository, and we're going to use the find by page count equals, and I'm going to pass in the value of 300, and then we can print out our book. So let's go ahead and we'll run this query, and we'll see how many books have 300 pages. And there's only one book, and that is Lord of the Flies. Now, let me warn you, this information is not exactly accurate, so that may or may not be the page count for that book. If we go back to our application, we can now test out one of our other query methods on our book repository, and we'll just go with find by page count less than. And let's say we want to read a shorter book, so we're going to search for all books with less than 150 pages. And if we look at our console output, we're going to see that we return 3 books, and if we do inspect their page count, they indeed come in under the 150 pages mark. And finally, let's run through what is probably our most advanced method on our repository, and that's the find by page count between method. And we simply supply a min and a max. So let's go between 160 and 220. And with this in place, we'll execute our application, navigate over to the console, and see what our results say. So you'll notice that all of our books that have been returned fall within those parameters, and we can actually take a look at the query that was generated by Spring Data, and we actually see the between keyword being used. If you have the logging enabled, you can look at any of these derived queries within the console output to really get a good look at what's happening behind the scenes with Spring Data. In this lesson, we took a look at some keywords that we can use on our repositories in order to perform relational comparisons with our repositories in Spring Data. In this lesson, we will explore how we can incorporate logical operators into our derived queries. We'll cover the keywords that allow us to adapt our queries to perform logical operations. The logical operators will allow us to connect 2 or more clauses within the derived query. So to begin, we're going to add a few methods to our book repository. And these methods will return a list of books, and once again we'll use the find by prefix. The first clause in our query will check that the title contains a particular string value, and then we'll introduce the logical OR operator that will join another clause that checks if a title contains a particular value. Now, since we have 2 pieces to this clause, 2 parameters will be generated, and we'll need to provide 2 values to our method. So I'm going to name the first argument title and the second argument title2. We'll go ahead and import the list type, and there we see we have defined our first repository method, which uses a logical operator. The next logical operator we're going to explore is the AND operator. If you're familiar with any sort of programming, you'll know that the AND and the OR operators are pretty much counterparts. So we're going to copy our repository method, and then we're just going to introduce the AND operator to our method name, and we're going to go ahead and change our second clause to inspect the page count and check that it is greater than a particular value. So that's going to require us to change the type of our second argument to this function, and so we'll change it to an int and then call it page count. Finally, we're going to look at another keyword that isn't quite a logical keyword, but it's in the same neck of the woods. And this is the not keyword, which is going to negate our comparison. So for example, we can find by title, and then we can specify the not keyword after our field name, and then this query will provide results for all books not matching the provided title. So there we see our changes to our book repository that incorporates 2 logical operators and the not keyword to negate our clause. We'll navigate over to our application, and we'll just run through a few tests with these new repository methods. Since our repository methods will return a list of books, we will use a for loop to iterate through each book, and we'll invoke our repository method to determine all of the books that we are going to iterate through. So we can invoke our different methods that we have added. Here is the find by title containing and page count greater than. So I'm going to look for all of the titles containing of that have a page count greater than 125. And then within the body of our loop, we're simply going to print out the book to the console. So let's run through this first example, and we'll navigate over to our console. And there we see that we've returned 4 books, all of which have of within their title and that have a page count greater than 125. Let's head back to our application and we'll try out our other repository methods. So the next one we'll try out is the find by title containing or title containing. So here we're performing an or operator. So we'll get any books that have of or and within their titles. And if we run this query, you'll see that we're going to get a decent selection of books back, all of which have of or and within their titles. Finally, we'll navigate back to our application and we'll invoke our last repository method. And that is the method which negates the clause within the query. So we're going to return all titles that are not Animal Farm. So we'll just see that book excluded from our return set. So if we look at our console output, you can see that we skipped our 8th book. We go from 7 to 9. And if we were to look at our data set, we would see that the 8th book is indeed Animal Farm. So our not keyword performed the way we expected it to. In this lesson, we took a look at how we can create more advanced queries that contain multiple clauses using logical keywords within Spring Data. In this lesson, we're going to discuss how we can incorporate date comparisons into our derived queries with Spring Data. To get started, we're going to build out a few methods on the book repository, and these methods are going to return a list of books, and they will begin with the find by prefix. In this instance, we're going to use the publish date field since we're going to be using some keywords that involve the date. We'll need to provide a date parameter to our new method, and we'll have to import java.util.date. Within Spring Data, we can use the after keyword in order to return all of our entities where the publish date is after a provided date. Spring Data also provides the before keyword, and this will allow us to inspect a date field on an entity and return all of the entities that have a date before the provided date. You'll also see that we can use the between keyword in order to filter our entities by date. When we use between, we'll need to provide 2 dates to our repository query method. So now that we have our 3 book repository methods that are going to return entities after performing some date comparisons, we're going to navigate over to the application class and we'll run some demonstrations using these new repository methods. Since each of our new repository methods returns a list, we're going to iterate through that list using the for each style of a loop. And we'll just reach into our repository and we'll invoke our find by publish date after method. And then within the body of our loop, we can print out the book to see what is returned. I'm going to construct a date using a simple date format. And we'll provide a format of month, month, day, day, and then a 4-digit year. We'll import the date class as well as our simple date format. and then we will parse out our new date, which is going to be October 22nd, 1995. So we'll put that in place. And now we can save our application and we will run through this demonstration. So if we look at our console output, you'll notice that we returned the book design patterns, which was published in 1996, and that corresponds correctly with the query that we desired. So we invoked the find by publish date after, and we received all books after 1995. Now let's return all books before 1995. We'll run this example, and you'll see that we will retrieve quite a few books that were published before 1995. And then finally, we will run another query that uses our between keyword with dates, and will return all books between 1995 and 1997. So I'll just go ahead and we'll use the between keyword on our find by publish date between method. And now we need to provide a second date, and we'll save this and run through our demonstration. And you'll now notice that we get back the design patterns book. And if we inspect our query, we see that we are checking where the published date is between two different dates which we have supplied. So in this lesson, we learned how to use different keywords that correspond with date comparisons in our repository method names to create a derived query. Another great feature within Spring Data is the ability to order our query results based upon keywords specified within our methods on our repositories. So we're going to create another repository method that returns a list of books, and we're simply going to find by title containing. So we're going to look for a particular string within the title, and we'll return all books that have a match for that string within their title. What we'll do differently this time is we will order by a particular field within the book. To do this, we specify the order by keyword on our method name, and then we suffix another field on our book. Now, we can order by title even though we're searching upon it, and that will cause our results to be ordered by the title, and then we can specify ascending or descending order. So here I have specified the results should be returned in ascending order, and we can also create a method that returns them in descending order. Now, if we navigate to our application class, we can run through a demonstration of these repository methods. So I'll use the repository to find by title containing a particular string, and then we'll order by the title descending. So I'll make it a real simple search. I'll just look for the character A, which is going to return probably almost all of our books. Then we'll print out our book, and if we look at our results, you'll see that our books are now returned and the result set is in alphabetical order. If we navigate back to our application, we can use the order by title descending method, and we can reverse the order of our books. And you'll see now that our books are returned in reverse alphabetical order. And you can also specify other fields to order by, so you can specify a secondary sort on your repository names. It will make your methods a little bit clunky, so I don't know if I'd recommend that. We'll see some other approaches if we have more complex queries that may be more appropriate in those instances. In this lesson, we'll talk about how the first or top keywords can be used within our repository method names to limit the number of results returned by our query. When Spring Data encounters first or top within a repository method name, it's a signal that the returned results set should be limited to a particular size. So let's add some methods to our book repository to see this in action. So we're just going to add a new method that returns a list of books, and then we're going to specify the method name as find top by. And this indicates to Spring Data that it should return the first result within the results set. You'll notice that we haven't specified an attribute to filter by, so it's going to look at all of our entities. And then what we can do is we can add an order by clause. So we're going to order by our page count in descending order. So essentially, what this query will do is it will order all of the books by their page count in descending order, and then return the first item in that list, giving us the book with the largest page count. You'll often see this performed within a query where you order by a particular field in descending order and then only select the first result in order to get the max of some attribute value from your set. You'll notice that we have specified the top keyword between the find and by strings in order to specify we need that one result returned. We could have just as easily used the first keyword, and that serves the same purpose as top. I would recommend just picking one and sticking with it. Here we can return the first result and we'll put the page count in ascending order, essentially giving us the book with the lowest amount of pages. Another thing that we can do when we write these queries that are limiting our results is specify a number of results to return back. So after top or first, you can specify some integer value. Here I specified 5, and that's going to determine how many results will be in your results set. So here we're saying return the top 5 books. Instead of by page count, let's go by price, and we'll look at the most pricey books. So in this result, we're able to combine an order as well as the top 5 token here, and that's going to give us the top 5 priciest books within our data store. We can also use the top and first keywords in combination with a where clause so we can filter by a particular field. So if we wanted to find the top 5 by title, we can just specify our title attribute. And there you see we're really combining a lot of the features of Spring Data. Here we're going to have a where clause where title is equal to the argument we've provided. We're also going to do the price sort. Let's do it in ascending order. So we'll get the cheapest first, and then we're only going to return the top 5 results. So there's a lot of combinations that you can put in place with all of the keywords in Spring Data. Let's save our book repository, and now we'll navigate over to the application where we can test out some of these new repository methods that we've created. The first repository method that we're going to demo is the find top by order by page count descending. So here we are getting the first book in a list of all of the books that are ordered by their page count within descending order. Essentially, we're finding out which book has the most pages. So let's run this demonstration. And if we look at our results, we see that War and Peace has our largest page count at 400 pages. Let's return back to our application and we'll run through another demonstration. So let's find the top 5 books by price descending. So we're going to see our top 5 most expensive books. And if we look at our results set, we see that Lord of the Flies is a lot more than the rest of our books when we consider its price at $119. And we can run through one more of these. We won't go through each one, but let's run through the one where we're specifying a title. So here we're going to invoke the repository method where we provide some sort of title and we get the top 5 books back with that title with the price in ascending order. Now, it's going to be fairly small as far as the results set because we're performing an equals comparison on the title. But there you can see we got Animal Farm back. And if we look at exactly what occurred, we received the book where the title was equal to the supplied parameter. We ordered by the price in ascending order, essentially giving us the cheapest book. And then you can see we also limited our results to the top X amount of results. In our case, it would have been 5. So you can see how that query is constructed and how all of our keywords that we supply to this method name are then applied within the query that is constructed. So in this lesson, we learned how to limit our result sets by using the top and first keywords within our repository method names. In this lesson, we will learn how to create queries that transverse nested properties within our entities by using our repository method names. It's not uncommon for an entity to have a complex type nested within it. You'll notice within our book entity, we have added an author field that is of type author. And when we look at the author type, you'll see that it has its own fields, particularly an author ID, a first name, a last name, and a country. The author type is also marked as an entity, and it has its own table associated with it. Within our init.sql file, we have added records for our author, and they have been associated with the appropriate books. It would not be uncommon to do a search for a book by the author's name. And in that case, we would have to leverage the relationship between book and author. So what we're going to take a look at is how we can transverse that entity association when we perform our queries using our book repository. So we're going to create a new method on our book repository that returns a list of books. And the method name will start out with find by, and then what we're going to do is we're going to define a constraint that transverses the nested properties. So we're going to look at the author field on the book, and then we're going to look within that author type for the first name of the author. And then we provide a string for the first name that we would like to query by. And we'll import our list type. And what this will trigger to Spring Data is to construct a query that filters by the first name field on the author field on the book entity. Now, at first, the query builder is going to attempt to construct a query using the author first name field. It's not going to find an author first name field on the book entity. Next, it's going to divide our field name by the points where we have camel casing. So it's going to break it up into something like this. So it's going to look for the author field on the book, and then it's going to look within that author field for a first name field, and it's going to be successful, and at that point, the query will be resolved. It may also do something like this, where it will look for an author first field, it won't find it, and then it's going to give up on building that query. The point being that Spring Data is using the points where we camel case within the supplied field name in order to define the points where it should transverse a nested property. We can be a little bit more explicit about when we want to transverse into a nested property by using an underscore within our method name. So let's construct a query that searches for books where the author is from a particular country. So we'll change up our parameter to country. And now we can go ahead and add an underscore between author and country. And this is more of an explicit marker to signal to Spring Data that this is where we are going to be looking at a nested property. So it's going to tell Spring Data, yes, look at the author field on the book entity, but then transverse into the author field and inspect the country property in order to construct our query and in order to define our constraint. So with these methods on our repository, let's navigate over to the application and we'll run through some examples. So I'm just going to uncomment our loop, and then I'm going to invoke our first method on our repository, and that's the find author by first name. And we're going to look for all books that have an author with the first name of William. So you notice how we are transversing through that entity association to construct our query. And there you do see that we have returned two books, one written by William Shakespeare and the other by William Golding. And those books correspond with the query that we constructed. Let's return to our application. And now we're going to invoke our other method where we find the author by country. So I'm just going to look for all of the books by an author that originated within the US. So we'll navigate back to our console, and there we receive all of the books that were written by authors in the United States. So here we see that Hemingway, Steinbeck, Orwell, Hawthorne, they have all written these books, and they were all by authors in the US, and that corresponds with the results that we would expect to see within our query. In this lesson, we learned how to define a query that transverses properties within our entities. We were able to look at how to construct our repository method names so that we can define these constraints that look at properties that are nested inside our entities. This chapter will focus on some additional query techniques provided by the Spring Data project. In particular, we're going to learn how to execute JPQL queries with Spring Data. We'll see how to use the query annotation to execute JPQL queries which are bound to our repository methods, and we'll also see how to bind a named query to our repository methods. After looking at how JPQL queries integrate with Spring Data, we'll then take a look at how we can use method arguments to specify the sort order for our query results. We'll be working on our repository methods and supplying a sort parameter which contains information about how we'd like to see our results sorted. We'll also see how we can provide secondary sorts and combine them with our primary sort using the sort object supplied by Spring Data. We'll also take a look at how we can page query results. Paging query results is when we receive a subset of our larger result set, and this is normally done for performance reasons. For example, if we execute a query that has 1 million results, it may be beneficial to us from a performance approach to only receive the results 1,000 at a time. This is a technique known as paging, and we'll learn how we can accomplish paging on our repository methods using different method arguments that we supply to our repository method. Finally, we'll take a look at how Spring Data can return our query results using various Java types. So when we construct a repository method, we have our choice of the return type of that method. Currently, we've been using list quite heavily, but as we'll see in this chapter, we're able to specify different object types that we would like to contain our query results. So, this chapter will teach us techniques to target specific data using JPQL and then how to format the results that we receive back from our queries. Within this lesson, we'll learn how to use the Spring Data query annotation to manually define a JPQL query. When manually defining queries using the query annotation, we place the query annotation on a method contained within our repository. So I'm going to create a new method on our book repository, and I'll just call it query1. And then upon that method, we need to add the query annotation. And this indicates that we are going to manually define our query using JPQL. We're just going to specify a simple query for our first example, and we're just going to select all books from our data store. We can create more complex queries by adding parameters to our query. So I'll create another query, query2, and I'll add the query annotation, and then we will create a little bit more of a complex type of query. So we're going to use a positional parameter within our query. So here I'm going to select all books, and then I'm going to filter this query where the book's page count is greater than a supplied argument. There you see that I'm using the ordinal value of 1 in order to define the parameter provided. And we accept that parameter within the arguments of our repository method. So I can add a page count parameter, and that page count parameter, since it is the first parameter within our method, will be passed to this positional parameter of 1 that is contained within the JPQL query. Now, I would highly recommend not using positional parameters and instead using named parameters. So we're going to create a third query, and we're going to add the query annotation to our repository method, and then we'll provide the JPQL query. And in this query, we're going to select the book from our data store where the title of the book is equal to some parameter that we give a name of title. So here we have a named parameter with the name title, and then what we can do is within our arguments to our method, we use the param annotation, and we specify the name of the parameter, and then we can associate that parameter with one of our method parameters on our repository method. So when we pass in that string to the query3 method, it's going to bind that value to our title parameter. And you'll want to make sure that you have spelled select correctly. So with those 3 queries in place, we are going to save our book repository, and we'll navigate over to the application, and we'll run through a few of these demonstrations. So I'm going to uncomment our for loop, and then we can invoke our different query methods. So here's query 1. We should get all books returned back from our query, and it looks like we got all 14 of our books that are in our data store. And now if we return back to the application, we can invoke query 2. Query 2, if you'll remember, looks for books that have a particular page count greater than our supplied parameter. So let's find all books with over 200 pages. And if we inspect our results, we see that we get all books that have over 200 pages. And if we inspect our query, we see our clause being applied. So there we see the page count, and we're checking if the supplied parameter is greater than the page count. Next, we will run through our third and final method, and that was the query3 method. And for this one, we're just doing a straight match on the title. So we're going to search for Animal Farm, and we'll run this demonstration, and you'll see that we do in fact return Animal Farm, and that our named parameter performed as we expected it to. These query annotations are great when you have a rather complex query that you need to define. Sometimes using derived queries from our method names just is not feasible when we have a query that is rather complex that we can't encapsulate within that method name. So this is one strategy you can use when you need to perform some query that has quite a bit of logic to it. In this lesson, we'll learn how to use Spring Data to leverage JPA named queries. A named query is a statically defined query with a predefined unchangeable query string. Normally, we place our named queries on our entities that they correspond to. So what we're going to do is we'll go to our book repository, and we're going to transfer all of our query annotations over to our entity book. And we'll place them at the type level, and we'll change the annotation from query to named query. Named query has two elements that we must define. The first is a name, and the second is a query. With these two elements defined, we can import our named query annotation, and we want to be sure to use the javax.persistence.named query annotation. At this point, it's time to give our query a name. It's important the name that we choose matches the standards set forth by the Spring Data JPA project. And that standard says that you first lead with the entity name. In this case, it's going to be book, and then use the dot operator, followed by the repository method name that this named query should correspond with. So if we navigate over to our book repository, you see the query1 method, and we're just going to copy that method name, take it back over to our book entity, and we'll paste that in as the second portion of our named query's name. At this point, we have defined our named query, and we can go ahead and move on to our next named query that we'd like to establish. I'm just going to copy this portion of our code, and we can paste that in before both of our queries to achieve some efficiencies. So we'll change our query name to query2 and then query3 respectively. To finish off our named query configuration, the final thing we'll need to do is add our named query annotations inside of a named queries annotation, and that annotation accepts an array of named query annotations. So we're essentially defining an array of named queries and providing that as a value to the value element on the named queries annotation. And once again, we want to be sure to pick the javax.persistence.named queries annotation as opposed to the Hibernate version of that annotation. And with that in place, we'll save our book entity. And now we can navigate to our book repository, and we can save this entity. Now you'll notice that we do get an error message that Spring Data has detected an invalid derived query. So what does that mean? You may see it when working with your repository methods. That basically means that the query parser, which is going to look at our method name and derive a query, cannot derive a valid query from the method it sees on this book repository. Now, this is not something to be concerned about in this instance. In fact, this is due to some pre-compilation of these classes, and it's actually a validator check that you can turn off within STS. In this case, I would argue it's almost a false positive. So we don't have to worry about those markers on our book repository interface, but if we were trying to develop a derived query type approach, we would be concerned if we saw those methods being marked, because it does indicate that a query cannot be built with the method name that we have provided. So with that explanation aside, we'll move over to the application and we'll run through a few examples here. So here you see we have the for each syntax loop, and we're iterating through all of the books returned by our first query, and that's going to return every book within our data store. And if we check out our results, we do in fact see all 14 books. And now if we head back to our editor, we can run through our next example, and we'll just execute our second query. So I'm going to call repository.query2, and for this query we need to provide a page number. So let's find books that have more than 240 pages. So we'll save our application, run our demonstration, and inspect our console output. And if we look at our console output, all of our 5 books returned should have over 240 pages. And if we look at the page counts, that's exactly what we see. I'll spare you the details of running through our last scenario, which is that third query. At this point, I'm sure you can see how Spring Data has accomplished the execution of these named queries. And it's all about providing the proper name for the named query. And once again, that's using the name of the entity as well as the name of the corresponding method on the repository interface. So in this case, query 1. And combining those two items, we are able to join this named query to the repository method, so that when we invoke this repository method, we essentially execute the named query we have defined. In this lesson, we took a look at named queries, which are another approach to defining a complex query within our applications. I would probably recommend the generic query approach, mainly because it's much easier to just place the query annotation right on a repository and have that association be right there in the code. So when you're looking at the query next to the method, it's pretty easy to surmise that this query will execute when I invoke this method. It may be preferable if you are coming from a JPA implementation to just leave the named queries in place, and in maybe that case you would forego switching all of your named queries over to use the query annotation that is provided by Spring Data. In this lesson, we're going to learn how to page our result sets using Spring Data. Paging is an approach where we return same-sized blocks referred to as pages from our larger result set. Paging is commonly used when we have a very large result set that we need to break down into more manageable sized subsets of that larger result set. By breaking down the larger result set into a subset, it makes it easier to do things like display those results on the user interface. You've probably seen this before when using a search engine. You may perform a query on the search engine and it will return thousands of results, but you don't initially see thousands of results on the screen. You may see the first 10 results, and in order to view the next 10 results, you have to page to the next page. In this way, the result set is broken down into more manageable pieces that are easier for our user to work with. In order to accomplish paging, Spring Data provides us with the paging and sorting repository right out of the box. And this repository interface contains several methods that facilitate paging of our result sets. In our first demonstration, we're going to use a method on the paging and sorting repository to page through some of our results. So the first thing we'll do is we will invoke our findAll method that has been overloaded to accept a pageable argument. And this pageable argument will define two things: which page we would like to be on, and how many results we would like to see on that page. So essentially, we're going to return all results, and we're going to be on a particular page of those results, and we're only going to be viewing a subset of our larger result set. To do that, we use a page request. And the page request constructor accepts two arguments. The first argument is the page we would like to see, and we're going to provide a value of 0 because it is 0 based. So if we were to supply the value 1, we would actually wind up on the second page, but 0 will put us on the first page. And the next argument we need to provide to this constructor is the amount of results we would like to see on the page. So I'm simply going to ask for 3 results on our page. And now if we execute this query, you'll notice we don't return the entire result set. Instead, we only receive 3. And in fact, we receive the first 3. So here we see we get book 1, 2, and 3. And if we were to navigate back to our application, we could ask for, let's say, the second page. And if we look at our console output, when we execute this query, you see we now get the second page, which corresponds with books 7 through 9. And you'll notice we are still only getting 3 results back. Now, if we would like, we could also change the amount of results returned. Let's say, give us 5 results and we want to be on the second page. And now we'll see how our result set changes that is returned by our query. So there we receive the last page of our results. There were not quite 5 available to fill everything out, but we get results 11 through 14. And that corresponds with our query. One approach that Spring Data provides us to accomplish paging is the Paging and Sorting repository. The Paging and Sorting repository is a out-of-the-box interface provided by Spring, and it defines several methods that facilitate paging within our result sets. So in our first example, we're going to walk through a demonstration of using the paging and sorting repository methods. So the first thing we'll do is we will invoke the findAll method, which has an overloaded pageable argument. When we provide the pageable argument, we use the new operator and the page request constructor. And this will allow us to define a page request. Now, a page request consists of 2 pieces of information. The first piece is the page that we would like to start on. And in our case, we want to start on the first page. The important thing to remember about this is that our pages are 0 based. So 0 is actually going to correspond with our first page. The second piece of information that we must provide is the number of results we would like to see on our page. So we're just going to say we'd like to see 3 results on our page. And if we go ahead and import the page request object, we can save our application and we'll run through it. Now what you'll see is that while our query is trying to return all results, the page request will only return a subset of our larger result set. So here we see that we get books 1 through 3 from our larger result set. Now, if we went back to our application and we said we wanted the second page, so I'm going to provide the value of 1, you'll now notice that we get the corresponding results, which are 4 through 6. So there we move to the second page. Similarly, we can change the size of our page. So let's just change to 4 results per page. And now if we execute our application, you'll see that we get 4 results back, and we're looking at the second page of results. So we get results 5 through 8. In this manner, we can go about using the paging and sorting repository methods simply by providing this page request object, which is going to tell Spring Data which page I would like to be on and how many results I would like to see. Another approach is to define a repository method on our repository. So I'm going to create a new method where it returns all books with a page count greater than a particular integer that we supply. And then what we can do in order to achieve paging is require a second parameter of type pageable, and that will dictate how many results are returned within our page and what page we are on. So if we define this method, which accepts a pageable argument, we can now apply paging to our query. So let's go ahead and invoke our new method. So find by page count greater than, and we'll supply a page count greater than, let's say 150. And now we simply provide a new page request. And let's say we want to see the second page and we want to see 2 results per page. Now, if we execute this application, you'll see that we get 2 results per page, and we're on the second page. And let's just modify that page request a little. Let's say give us 3 and put us on the second page. Let's see if our data changes at all here. So we'll go to our console, and there you see now we're returning the second page and only 3 results, and our query's being applied because you'll notice we skipped book 6, which had less than 150 pages. So that's another way you can achieve pagination, is by including a pageable type argument within your methods that are defined on your repository. So there are 2 very good approaches that Spring provides us in order to page through our query results. And these are very handy if you've ever had to write the SQL yourself to achieve paging. It's not really that fun of SQL to write, and it can be a little bit of a nuance to fine-tune and make sure you're getting the proper results back, as well as tests. So here you get a proven implementation of a paging algorithm. In this lesson, we're going to take a look at several of the approaches that Spring Data provides in order to sort our result sets. So we have seen the paging and sorting repository, and on that interface there are methods that allow us to sort our result set. So for example, if we were to look on our repository and we look at the findAll method, we see a method that accepts an argument of type sort. If we provide a sort to this method, we can direct Spring Data and tell the project how to sort our result set. Constructing a sort is pretty simple. Just use the new operator and the sort constructor, and then provide a field name to the constructor. So in our case, we're going to ask the sort to sort by page count. And if we run through this demonstration, you'll now see that our results from our query are returned by the page count in ascending order. By default, every sort will be in ascending order unless we specify otherwise. If we would like to change the order of a sort, we can provide a direction as the first argument. In order to specify a direction, we use the direction field on the sort class, and then it has two options, ascending and descending. So in this case, we're going to pick a descending sort by page count. And now if we run through our query, we can take a look at the results, and we'll now see that we start with the result that has the largest page count, and then our result set traverses down until we reach the book with the lowest page count. Another thing that we can do with our sort is we can provide multiple fields to sort by. So for example, we can specify the author.lastname field as another field that we would like to sort by. And I'm going to actually change our sort back to ascending for this example. And what this says is that we're going to first sort by our author field's last name field in ascending order, and then we're going to sort by page count in ascending order. So essentially we have specified a direction as well as two fields to sort by. And this is made possible because the sort constructor has a overloaded form that accepts the fields as a varargs argument that allows us to specify multiple fields to sort by. And we'll save our application, and then we'll run this demonstration, and you'll see that we have sorted by our author's last name, and that is in ascending order. And then when we have a book that has the same author, such as our Hemingway books here, then we are ordering by the page count in ascending order. Now, let's imagine that we wanted to perform the search a little bit differently. We wanted to sort by the author's last name in ascending order, but we wanted then to sort by descending order for the page count. What we can do in that situation is we can use the AND method on the sort object, and this method accepts another sort object that will be applied as a secondary sort to our query results. So all we need to do is specify our sort direction. So we'll use the sort class, pick our direction, and we'll say descending, and then we provide the field we would like to sort by. So there we see we simply use that AND method to attach another sort to our query. So we have two sorts, the first being the author by last name in ascending order, and the second being the page count in descending order. And if we take a look, you'll see that's what we receive. So here we see our authors in ascending order. If we look at our two Hemingway books, you now see the one with the largest page count comes prior to the one with the lower page count. So we can use the methods on the paging and sorting repository if we would like to control our sort for our query results. Another mechanism that we have is much like the pageable argument that we have passed into our find by page count greater than query. We can just pass in a sort argument to our method defined on our repository, and then if we were to invoke this method on our repository, we can specify a sort when we invoke that method. So if we invoke the find by page count greater than, we'll say let's find all of the books with a page count greater than 220, and then we can simply provide a small sort. So let's say sort by the author.firstname, and in this case When we execute our newly defined repository method, you'll see that we receive all the books that have over 220 pages, and we are indeed sorting our results set by the author's first name in ascending order. So in this lesson, we took a look at several approaches that we have to sorting results sets. We saw how we can use the paging and sorting repository, and we can pass in a sort to those methods defined on that repository interface. And we also saw how we can create our own repository methods that specify a sort object as a parameter, and then we can provide an implementation of the sort object to that query method. One of the greatest benefits of defining query methods using Spring Data repositories is that our query methods are able to use various return types to return our query results. For example, we have been using the list to return our query results throughout the course. In this lesson, we're going to see various other types that we can use as return types from our query methods. I'm going to go ahead and change our list over to a collection for our first demonstration. And you'll notice simply changing over to a collection is supported by Spring Data, and we get our results as expected. We're also able to use an iterable type from our query method. So we'll change our return type over to an iterable, and we'll navigate back to our application. And once again, we'll see that Spring Data is able to return our results via the iterable type. Next, we're going to look at a little bit different of a type, and this is the page type that is provided by Spring. So if we import Spring's page, we are able to retrieve that subset of our larger query results that we retrieve when we are performing paging. So in order to perform paging, we need to supply the pageable interface, and we need to specify that as an argument on our query method. With that in place, we navigate to our application, and we provide a new page request. So I'm going to ask for the first page, and I would like to see 3 results on it. And what we'll see is that when we execute our query, we now get a page instead of the entire result set back. If we were to further look at the page object by pulling out the page as its own variable within our code, we'll see that the page type has several methods that can help us make decisions about how to work with our result sets. And 2 of the most important items or methods on the page type are the getTotalElements method and the getTotalPages method. The getTotalPages method tells us how many pages make up our larger result set that this page was a subset of, and getTotalElements tells us how many elements were within the result set that our page is a subset of. So using the page, we're able to get more information about the larger result set that it came from. Now, along the same lines as the page is the slice. So we're going to go ahead and change our application to use a slice, and then we will change our repository to also use a slice. And then we'll take a look at some of the methods that are contained on the slice. So when we look at the slice, we're going to see a lot of the methods that were available on the page. We're able to get the amount of items on the page. We're able to get what number the slice is. But with the slice, you are unable to access information about the overarching query that the slice is a subset of. And this is done because it grants you some efficiencies. Getting that information about the larger result set requires computation time, and that's going to lower your response time when you execute a query. So if you're not concerned about the total number of pages within your results set, you can use slice. And on the slice interface, you'll see that there is a has next method, which is going to indicate if there is another slice available. So you can use this when you're determining whether or not you need to be almost paging through your results set to determine if there are more slices in the overarching results set available for you to query. In this lesson, we took a look at the different return types that can be used by our query methods and how they can be used to represent our results sets as objects. This chapter will cover a collection of advanced Spring Data JPA features. The features we'll cover will teach us how to use Spring Data to create better performing applications and how to encapsulate some of our custom defined logic. These features will not be used frequently during your work with Spring Data. However, it's good to know these techniques because they can provide you with benefits that improve your application. The first thing that we'll learn is how to provide custom repository behavior. We know that we can go the derived query route. We can define some method on our repository, and if it has the appropriate keywords, it is going to execute a query with the appropriate predicates that return us the results we would like to see. Sometimes the keywords provided are not enough. We need to actually provide an implementation for our repository methods. To achieve this, Spring Data exposes components of JPA that we can work with inside of a repository method that will then be available to either a single repository or all repositories within our application. So we'll take a look at how we can build out that custom behavior for our repositories and then place it across all repositories, or if we choose only a single repository. Another neat feature we'll take a look at is executing queries asynchronously. You may be familiar with asynchronous types of communication because of AJAX. When we talk about asynchronous execution, we're normally talking about how our application's execution kicks off some other task or thread, and that task or thread goes off and performs work on its own while the main execution of our application continues. This allows us to execute tasks within our applications in a parallel manner, and it can be used to optimize the way we perform our logic. Spring Data allows us to execute repository methods asynchronously. In other words, we can fire off a query against our data store, and then our application's logic continues, possibly firing off other queries against our data store while those queries are executing and eventually returned. It allows us to execute query methods asynchronously with very little code in place. For the amount of work being done, querying a database and also the threading to accomplish that query in an asynchronous manner, Spring Data boils this down to a few annotations placed on the appropriate methods. We'll also take a look at how we can automate the auditing of our entity. So as we modify entities within our applications, we want to keep a trail of who made the last update and when. Spring Data provides us with features that can automate this type of tracking. It's very easy to put in place, and we'll learn that in this chapter. Finally, we'll take a look at how we can manually define a query that modifies entities. Normally, when we think of a query, we think of returning a results set or some collection of entities. In this case, we're going to take a look at how we can define a JPQL query that actually updates entities instead of returning a result set. So this chapter is going to teach us some advanced techniques that really fill some niche use cases, but knowing them is very beneficial to any Spring Data developer. One requirement that often arises when working with Spring Data is to create a repository method that has a custom implementation. With Spring Data, we can provide custom code for a repository method which integrates with our repository interfaces and their functionality. Within this lesson, we are going to define a new method and provide a custom implementation for that method. We will then integrate the method and its implementation into our Spring Data repository. To get started, anytime we want to provide custom functionality, we need to define a new interface. So I'm going to use the new dialog, and I'll create an interface, and I'm going to name this interface Book Repository Custom. And once we have our interface name provided, we'll add a method to this interface that we will provide the custom implementation for. Our method is going to save and log a book entity. So it's going to be a public method that returns a type of void. We'll name it save and log, and then we'll pass in a book argument to this method. At this point, I'm going to save our new interface so we can proceed to our next step, which is creating a new class that implements this interface. So I'll navigate to our Package Explorer, and I'll use the new dialog to create a class, and I'm going to name this class Book Repository Custom Impl. And we want to have this class implement our Book Repository Custom interface. So I'll click on Add, and we'll specify the Book Repository Custom interface. And then we'll hit Finish, and we'll see that our new class is created. Now, within this class, we will define our custom implementation for our save and log method. To get started, we'll first annotate our new class with the repository annotation, and then we are going to add an instance of a logger. So I'm going to create a logger, I'll name it logger, and then we'll use the logger factory, and we'll use the getLogger method, and then we simply provide our class to the static factory there. So we'll import the SLF4J logger. And then the next thing we're going to do is we're actually going to auto-wire an entity manager into our class. Now this class will be a bean, so we're able to perform things like auto-wiring just like we can do within any other bean. So we have Spring's dependency injection right at our fingertips within our custom repository. Next, we'll add the transactional annotation to our save and log method. That way, any operations performed by our entity manager within the save and log method are performed within a transaction. Now, since this method is named save and log, the first thing we'll do is we will log the operation that we're performing to our log using SLF4J. So I'm just going to say saving the book entity, and then we can print out the book by invoking its toString method. And then next we'll use our entity manager to persist our book, and that's going to save it within our data store. So at this point we have provided the implementation for our repository method. The next step is to link our custom repository implementation up with our book repository. So one thing you'll need to notice is that our book repository custom impl is implementing the book repository custom interface. So that is going to provide the link between our book repository and our actual implementation. So we see that we're currently extending the JPA repository, and now within the declaration of this interface, we're going to also tell Spring Data that our book repository should implement the book repository custom interface, and that's going to link in our custom implementation to our book repository. So that's how those two pieces of code are connected. We can connect our book repository, which will be built out by Spring Data, and we'll get all of the custom implementation provided by the book repository custom impl, and we'll also get all of the out-of-the-box implementation from Spring Data's JPA repository. So with that interface in place, there is only one last piece of configuration that we need to provide, and that's within our application context.xml file. If we look at this file, you'll see that we are using the JPA repositories tag to specify our base package to scan for repositories. Well, there's another attribute on this tag that we need to provide a value for, and that's the repository impl postfix. What's going to occur is as Spring Data scans the com.o'reilly.sdata package, it's going to look at the names of all the classes within that package, and if it recognizes a class that has the repository impl postfix value, and in our case that's going to be custom impl, it's going to then consider that class as a candidate for a custom repository implementation. So that's another way that our book repository custom impl is going to get tied into our book repository. This is also how our book repository custom impl is going to be picked up and created as a bean. We'll go ahead and save our configuration, and now we're going to navigate over to our application where we can run through a demonstration of our new custom repository implementation. Within our application, we're simply going to invoke the save and log method on our repository, and that is the method that we provided the custom implementation for, and then we'll just pass in a new book using our bookUtil class. We can simply create a book. So with that code in place, I will run our application, and if we look at our output, you'll notice that the debugging information has provided us with our output. So here we see that we are inserting into the book table, and if we look further up, we see our book repository custom impl, and we are printing out the logging message that we had within our custom repository. In this lesson, we learned how to create a custom repository method and provide an implementation for that method. In order to do that, we needed to create a book repository custom impl class, which defined the implementation of our new method, and we also had to create a book repository custom interface, which defined our new method that we wanted to provide the custom implementation for. We then extended our book repository custom interface using the book repository. So we had our book repository interface extend our new custom interface, and that linked up our book repository with the custom repository implementation that we defined. Now, one thing I'd like to point out here is that we have only provided custom functionality to one repository. If we want to provide custom repository implementations globally, there's another technique that we must use. In this lesson, we will learn to build a custom repository implementation that has its behavior shared across all of our Spring Data repositories. Being able to define a set of custom repository methods on a custom repository implementation is beneficial because it provides us with some code reuse and it allows us to adhere to the DRY principle, which is do not repeat yourself. To get started, the first thing we need to do is declare a new interface. So I'm going to use the new dialog to create an interface, and I'll name this interface base repository, and I'm also going to provide two type parameters on this repository. The first will be T, and that will represent our entity's type, and then ID is our next parameter, and that's going to represent the type of the ID, and it's going to extend serializable. In addition to specifying our two type parameters, we'll also need to extend the JPA repository interface. So we pick an interface to extend, and then we click on Finish, and our new interface will be defined once we import our types. Our new interface will be used to declare the custom methods that will be shared across all of our Spring Data repositories. It's important to remember that this interface should not be made into an actual repository implementation. We want to annotate this interface with the no repository bean annotation. And now we can go ahead and declare that custom method that will be shared across all of our repositories. So I'm going to build out a method that returns a list of our entity type, and I'm going to name this method findByIds, because we're going to allow the client code to invoke the findByIds method and supply a vararg list of IDs, which we will then use within our query in order to specify a where clause. With our new repository method in place, I'm going to save our interface, and now we can move on to creating a new class that will provide our implementation for this method. To create our class, I'm going to navigate to the Package Explorer, where I will open the new dialog and build out a new class. I'm going to name this class Extended Repository Impl, and we're going to provide two type parameters on this class, one being the type of the entity, the other being the ID, which extends the serializable object. And we'll create our class, and we'll import the serializable type, and then we're going to start extending some additional classes. So we're going to inherit from the simple JPA repository, and that's going to provide us with the implementation for all of our JPA specific repository methods. So things like save and things like remove are going to be found within the simple JPA repository. We're also going to implement our base repository interface that we have just created. So we will change our parameter over to an ID, and at this point we have our class declaration down, and now we need to provide a constructor. And we want to use the constructor that accepts the entity information. So here we see our constructor, which invokes the superclasses constructor, which accepts entity information and an entity manager as arguments. And we need to keep those two objects stored within our class. So I'm going to create a new field of type JPA entity information, and I'm going to use a wildcard here as the second parameter, and I'm going to name this field entity information. Next, we need to create a field of type entity manager, and I will name this field entity manager, and we can go ahead now and assign these fields to the arguments passed in. So we're going to pass over the entity information object and assign that to our field, and then we'll do the same with the entity manager. Finally, we need to add a implementation of our findByIds method that is contained on our base repository. So we will add the method definition and provide an implementation. So the first thing we do is declare a query object, and then we use our entity manager to create a query. We'll define the query in a string, and we're going to select our entity from, and then we are going to pull the entity information to get the entity name. We'll continue to concatenate our string by adding an alias for the entity, E, and then we're going to select the ID attribute on E. So we will once again consult our entity information, and we will get the ID attribute, and we'll get its name to include within our query. Finally, to complete our query, we're going to use an in clause and an IDs parameter. Be sure to import the query type and select the javax.persistence.query type. Now we need to set the parameter on our query. So we'll invoke the setParameter method, and we'll provide the string IDs for the first argument. And now we need to convert our varargs argument over to a list. So I'll simply invoke arrays.asList and pass in our IDs object. And now we need to return our results. So the first thing we do is we cast our results to a type of list with a generic type of T, and then we get the results from our query. So we've completed the build out of our custom repository implementation. We must now integrate it with all of the repositories in our application. In order to do this, we must first change our book repository to use our new base repository interface. So I'm going to remove all of the other repository interfaces from the book repository. We'll specify the entity type of book and the ID type of long, and that's everything for our book repository. And now we just need to go to the application context.xml file, and here we will add the base class attribute and provide a value for it. The base class will be equal to our extended repository impl class, and that will tell Spring Data what our base class is for our custom repository implementation. Now if we navigate to our application, we can test out our repository by using the findByIDs method. So let's find the book with the ID 2 and the book with the ID 7. So we'll put that in place, we'll run through our demonstration, and you'll see that we eventually do indeed receive books 2 and 7 from our data store. So the really nice thing about our findByIDs method is that it is not specific to the book repository. If we had other entities that had their own repositories, we would simply need to extend our base repository, and the findByIDs method would be made available to those repositories, and the implementation would be defined within a single location, making it much more maintainable. In this lesson, we will learn how to execute our repository query methods asynchronously. When we execute a query method asynchronously, the method is immediately invoked and execution continues while our query is executed in another task or thread. This is accomplished using Spring's Task Executor feature. In order to effectively work with asynchronous methods, we're going to add some logic to our extended repository impl. You'll remember that this class serves as a custom repository implementation for all of the repositories in our application. To demonstrate the asynchronous nature of our method invocations, we're going to add a random wait time to our findByIDs method. Within this method, we are going to add a variable of type long, and we'll name this variable weight. And then we're going to use the random object to get an integer between 1 and 10,000. So I'll simply subtract 1 from 10,000 and then add 1. We'll import the random object and we'll invoke next int on that random object. And now we can print out our wait time, and then we will tell our thread to sleep for the specified wait time. Now we need to surround that method invocation on thread.sleep with a try-catch block, and then we can print out some debugging information to our console that tells us which IDs we are executing the query for. So we'll simply pass in the IDs to the arrays.toString method, and then we'll pass that to our console output. And then we can just clean up our method. And at this point, we've introduced our random wait. With these changes in place, I can now navigate to our application context.xml file. Within this file, we will define some configuration to enable our task executor within Spring. Enabling Spring's task executor feature is pretty easy. Simply click on the namespaces tab within our application context.xml file, and then select the task namespace, which will provide us with some shortcuts for configuring our task executor. Using the task namespace, we'll define an executor with an ID of executor, and we'll specify that we would like to have 10 threads within our thread pool. Once we have created our executor, we can once again use the task namespace to enable task annotations. This will allow us to provide annotations on our query methods within our repositories that indicate we would like to execute our method asynchronously. The only thing we need to do to configure our annotations is to specify our executor, and we're just going to provide the ID of our task executor we have defined above. So at this point, all of our configuration is in place in order to perform method execution asynchronously. There's only one thing we need to do, and before we do that, I'm just going to run our application in order to demonstrate the current behavior without asynchronization. If you look at our application, you'll see that we iterate through a loop 4 times, and each time we pass in the long to our findByIDs method. Let's go ahead and run this application and take a look at its output. You'll see that we have hit our wait time, and it's saying we're going to wait roughly 8 seconds. And then in 8 seconds, our query is going to execute. It's going to make us wait another 9 seconds. And then we will see the second query execute. And now we got a lower wait time of 2. We see our third query execute. And then finally, our fourth query executes. And these queries are all performed in a serial nature. In other words, we wait for one query to finish executing before we proceed and execute our next query. Let's take a look at how asynchronization changes this. To enable asynchronization, all we need to do is navigate to our base repository and add the async annotation to our method. With the async annotation in place, this signals to Spring Data that the method should be executed in a parallel type nature. Now, if we return to our application, we can now run our application, and if we take a look at our console output, you'll notice that it performs quite differently. First, we get all of our times up front, and then you'll see we start executing our methods. But they didn't execute in the serial type nature as before. Our methods were executed, and then we moved on and executed the next method in the loop and the next method, so we kept going through our loop and invoking the findByIDs method. The difference this time is that we didn't wait for our query to return our result set. So here you see that the result set that was returned first was actually our last query that we executed. And you'll see that our first query we executed came back in the third position. So we executed our last query, then our second to last, then our first query, and then our second query. And that's all because of how they were spaced out with sleeping the thread, but it was able to be executed in that parallel nature by the asynchronous features within Spring. In this lesson, we're going to learn how to enable auditing within Spring Data. Spring Data's auditing allows us to capture who made the last change to an entity and when the change was made. To enable auditing, we need to add an additional dependency to our pom.xml file. The artifact ID that we will add is Spring Aspects. So we'll want to choose the artifact with the group ID org.springframework, and then we're going to choose the 4.1.7 release. And we'll add that to our pom.xml file, and then we can go ahead and close our POM. Next, we're going to make some modifications to our entity to allow for auditing. The first change that we'll make to our book entity is to add the entity listener annotation to our book type. This annotation allows us to specify a Spring auditing entity listener that will record any changes that occur to an instance of an entity. An entity listener triggers when certain events occur in the entity's lifecycle, such as when it's persisted. When this occurs, our auditing entity listener provided by Spring will update some fields on our entity that correspond with who made the latest change and at what time they made this change. In order to capture this information, we need to add some additional fields to our entity. The first is going to be a string field named created by. The second will be a string field named last modified by. We'll also provide a date that will contain the date the entity was created, and another date that records the last modified date. Once these fields are in place, we're going to provide some annotations to signal to our auditing entity listener that these fields need to be populated. The first annotation we're going to use is the created by annotation, and we're going to put that on our created by string. We'll also use the last modified by annotation, which is provided by Spring Data. And then we'll use the created date annotation. And then finally, we will add the last modified date annotation. And we'll add the setters for these new fields to our entity. And I'm going to regenerate our toString method while I'm here. I'll just make sure I include every field within our toString method. And that completes all of the changes to our entity that we must make to enable auditing. Spring Data can easily discern when our entities are modified. But what's not so easy is determining who has modified our entity. In order to do that, Spring Data must know who the logged in user is. Luckily, there is an auditor-aware interface that we can implement and create as a bean that will tell Spring Data who our currently logged in user is. To do this, we're going to create a new class within our project, and I'm going to name this class Custom Auditor Aware, and this class is going to implement the Auditor Aware interface. And we're going to specify a generic type of string for the Auditor Aware interface type parameter. And this is going to create our new class And this class is responsible for telling Spring Data who our logged in user is. Now, one thing you should know about this class is that the generic type parameter you provide to the auditor-aware interface must match the created by or the last modified by field types. So in our instance, we define them as strings, so we can simply return a string. And I'm going to make this very simple for our purposes. I'm just going to return my name. At this point, we have provided an implementation for the auditor-aware interface, and Spring Data is able to determine who our logged-in principal is. The next thing we need to do is we need to modify our application context.xml file. So we'll navigate to this file, and we'll then make some configuration changes. The first change we'll make to our Spring Bean configuration file is we will declare a new bean and we'll name it custom auditor aware, and we need to provide a type for this bean, and it's going to be the custom auditor aware class that we just created. So we're going to make our custom auditor aware class a bean within our Spring IOC container. And then what we're going to do is we're going to use the JPA namespace, and we're going to use the auditing tag to specify our auditor aware bean. So here we're just going to point to our newly created bean, and this is going to tell Spring Data what bean to use in order to find out who's logged in. Now, as we mentioned, our custom auditor aware bean is very simple. Normally, it would be integrated with something like Spring Data. Now we're going to go over to our application, and we're going to build some code to test out our auditing. This demonstration code is going to be pretty simple. We're going to create a new book using our book util, and we'll invoke the create method. And then we're going to use our book repository to save our new book. And then we're simply going to return the book from the repository. So I'll just use find one, and we'll look for the book by its ID. And then I'm simply going to print out the book that is returned by our query to our console, allowing us to inspect our newly created book. Run through this demonstration, and we'll take a look at our console output. And you'll see that we have inserted a book into our data store, and then we pull that book out of the data store. The book's title is Adventures of Huckleberry Finn, and if we continue to examine the fields on this book, you'll notice that all of our auditing fields have been populated by Spring Data. And that was because we have defined our custom auditor aware bean, and we have registered our entity listener, which allows us to perform auditing. You'll see that the created by, the last modified by, the created date, and the last modified date fields were all automatically populated for us, and that's thanks to Spring Data's auditing features. We know that Spring Data allows us to manually define JPQL queries that are then attached to our repository methods. These JPQL queries return an entity or a collection of entities. What we haven't seen is that Spring Data allows us to define queries that modify our entities. In this lesson, we'll learn how to use the query and modifying annotation to write queries that modify or update our entities. This approach is very useful when you're looking to update multiple entities at the same time. To get started, I'm going to add a new method to our book repository. This will be a public method that returns an integer, and we'll name the method setPageCount. On the method, we're going to add a query annotation. So we'll import that annotation, and then we'll begin writing our JPQL query. The query is going to update the book entity, which will give an alias of B, and we'll set the page count field on that entity equal to our second supplied parameter. And then we're going to add a where clause where the title of our book is like our first parameter. With this query in place, we now need to add parameters to match our JPQL statement. So for our first parameter, we're going to accept a string named title, and for our second parameter, we're going to accept an int named page count. And these two arguments to our setPageCount method will determine which book gets updated and how many pages that book will now have. The next thing we need to do is we need to add the modifying annotation to our setPageCount method. And this is an indicator to Spring Data that our method, which is annotated with the query annotation, contains a query that is going to update or modify entities. We're also going to add the transactional annotation. That way our updating query or our modifying query is executed within a transaction. So this is pretty simple, and we're just going to save our book repository, and now we'll navigate to our application class where we're going to walk through a demonstration of our setPageCount method, which contains our modifying query. The first thing that we're going to do is we're going to output the result of invoking our setPageCount method. I'm going to supply a title of Animal Farm and a page count of 1000. And what we'll see is that our setPageCount method will return an integer that corresponds with how many records were updated by our modifying query. I'm also going to loop through and print out all of our books just so we can see the actual page count changes take place. So with this code in place, we'll run through our demonstration and we'll see that we should update one title. So if we look here, we print out 1, which is the integer returned by our setPageCount method. And then when we look at our list of books, we see that Animal Farm's page count has been set to 1000. Let's run through one more demonstration to see a little bit of the power with our modifying query. If we were to change our title to include a wildcarded AND, now we're going to update any book whose title contains an AND to have a page count of 1000. Now you will see that we're going to modify multiple records with our single query. So let's run our demonstration and we'll take a look at our console output. And here we see, if we scroll up in our console, that we did indeed update 3 books. So let's go and find the books. There's one. Of Mice and Men has a page count of 1000. There's War and Peace with a page count of 1000. And we should have one more. And there it is. The Old Man and the Sea, also updated to have 1000 pages. So in this lesson, we took a look at how we can add the modifying annotation to our JPQL queries, which update an entity or a collection of entities. These annotations are placed on a repository method, and they can include parameters. In our case, we chose to use ordinal parameters, but we could have used named parameters had we chosen to. In this chapter, we'll take a look at several of the ways that Spring Data integrates with Spring MVC. Our primary focus for the chapter will be to discover how we can perform these integrations. We'll take a look at 3 ways that Spring Data can be used within Spring MVC. The first is establishing a domain class converter. Within Spring, we know that there are converters that can convert an object of one type to another. Out of the box, Spring Data provides us with a domain class converter that's able to take the ID of one of our domain classes and convert it to the actual domain class itself. So for example, we know that the book ID is of type long, And what the domain class converter is able to do is take that long ID, use a repository, query our data store, and return an instance of our book entity. We'll also see how Spring Data provides paging capabilities that we can pull into Spring MVC. With the integration, we're able to supply specific request parameters in our requests, and Spring Data will take care of the rest as far as our paging goes. We'll also see that Spring Data provides very similar integration for sorting within our Spring MVC applications, and that's all driven by registering some out-of-the-box components from Spring Data and then supplying the appropriate request parameters. In order to work through this chapter, we do need to have a Spring MVC project to perform our integration. We're not going to walk through step-by-step configuration of a Spring MVC project, but I will provide the Spring MVC project within your working files. And what you'll see is that we have used Maven to pull in our Spring Data project that we have been working with throughout the course. If you'd like to brush up on Spring MVC project setup, you will see some lessons included in this course as part of an appendix for Spring MVC. O'Reilly also has another Spring MVC course that I've authored that can help get you up to speed on this prerequisite. In order to understand how Spring Data integrates with Spring MVC, we need a Spring MVC project. The project you are currently seeing in your browser was created to provide us with that environment to test out the integration between the two projects. You'll see that the Books application is displaying our list of books which was created within our Spring Data project. Within the list of books, I can click on any book and it will drill down into that single book and provide some information about that title. As we explore Spring Data's integration with Spring MVC, we'll take a look at how we can apply concepts such as paging, sorting, and adding a domain class converter into our Spring MVC project. Before we do that, let's take a look at the underlying components that make up our new application. First, you'll see there is our Spring Data course, and that's our project that has all of our work with Spring Data and contains our book and author entities as well as the book repository. We also have our Spring Data MVC integration project, and this project is a web project that uses Spring MVC. And when we use Spring MVC, one of the most important pieces is the dispatcher servlet and how it's configured. So here we see a very basic setup for a Spring MVC project. And this is going to allow us to pick up our book controller because we are component scanning our base package. If we look at our book controller, you'll notice that we are using our book repository within our controller logic, and that book repository is used when we render some of our views because it is consulted to place objects within our model. So here you see that when we display our list of books, we invoke the findAll method, we add the result to our model using a books identifier, and then we return our books.jsp file. If we take a look at that JSP file, you'll see that it simply builds out a dynamic table of all of our books. You'll notice that we then link to individual books using a Spring URL tag. That's going to invoke our showBookController method, which accepts a path variable of type long that corresponds with the book ID. The repository is then used to query our data source and pull out the respective book for the ID. This object is then added to the model and given the attribute name book. We then return the string book, which will cause our book.jsp file to be rendered using the information about the individual title. So throughout our chapter, we're going to be looking at how Spring Data makes working with Spring MVC easier by facilitating things such as paging, sorting, and converting some of our domain classes. When building a web application, it's pretty common to have a situation where you need to access an individual item within a list. In our case, we have a list of books, and then we would like to drill down into a single book and view its details. When that occurs, a common scenario is to have almost this RESTful URL type situation where we use the /books/path and then we append a book ID, and that book ID is then gathered within our method arguments to our controller method. And the next thing we do is we access our repository and execute a query using that book ID. Well, using Spring's domain class converter, we can provide our domain types within our method signatures for our Spring MVC controller methods. We're no longer required to manually look up our entity with a repository within the body of our controller method. So let's discuss how this would impact our showBook controller method. First, we would no longer have an argument of type long within the method arguments for the showBook method. Instead, our long would turn into a book because the repository would be consulted in the background and used to query the individual book that corresponds with the provided book ID. So we can change our parameter name to book and remove the statement where the repository is finding the book and simply pass the book to our model. In order to achieve this, we simply can't rely upon out-of-the-box configuration. We need to provide some of our own configuration that integrates Spring Data and Spring MVC. To do that, we provide some configuration within the dispatcher-servlet.xml file. The first item that we need to add within our configuration file is a conversion service. So we'll declare a bean and we'll give that bean an ID of conversion service. And now for its type, we're going to use a formatting conversion service factory bean. So that factory bean is going to return a conversion service. And a conversion service is used to convert objects between different types. Within the conversion service, there are several converters registered, many of which are provided by default by Spring, and they're able to take one type such as a long and convert it to another type such as a book. So basically there is a source and target type, and the converters know how to perform that conversion. They're registered in a conversion service, and that conversion service is able to pick the appropriate converter to perform the conversion. Our conversion service must be registered with Spring MVC. So on the MVC annotation driven tag, there is a conversion service attribute where we can provide the ID of our conversion service. Finally, we must declare a domain class converter. The domain class converter is really what performs the integration between Spring Data and Spring MVC. In order to register a domain class converter, we declare a bean and we give it the type domain class converter. And that converter is able to look at a particular source type and convert it to a target type, which is normally one of our domain classes or one of our entities. In order to do that, it needs to have a reference to our conversion service so that those converters can be registered. So what we do is we provide the conversion service constructor argument, and then we provide a reference to our conversion service bean. And once that's in place, all of our configuration has been included that we need in order to use a domain class converter. So just to recap what this achieves, it's going to allow us to take our book ID, which is included within our path, and convert it to a type of a book within our controller method without using the repository. So let's go ahead and we'll restart our Pivotal TC server, and then we'll navigate to our application, and we're going to visit our list of books, and then we're going to invoke that controller method by drilling down into a single book. So there you see there was no disruption when we needed to grab that individual title from our list of books and display some information about it. And that's because we had a domain class converter in place, and Spring Data's MVC integration was able to convert that ID we provided to the entity type book behind the scenes for our controller method. Another aspect of Spring Data's integration with Spring MVC is the ability to support paging. Spring Data allows us to provide pageable parameters to our Spring MVC controller methods. So for example, I can add a pageable parameter to our showBooks controller method, and this pageable is going to allow us to page through all of the books within our data store. I can simply pass that pageable argument into our findAll method, and now Spring Data will return a page of the book entity instances from our data store. So following the practice of self-documenting code, we'll switch the name of our model attribute over to page. Now, one thing you should be asking yourself at this point is, where does the information about the pageable argument come from? The information is discerned from our request. The integration between Spring Data and Spring MVC will pull out a request parameter named page, and it will inspect the page request parameter to see which page we are on. In order to set up this connection, we need to add a page parameter to our books.jsp file, which will be used when we want to page through our results. So I'm going to add a new anchor tag below our table, and this anchor tag is going to use a Spring URL. That way we get the proper root context, and it's going to navigate to the books path, and we're going to supply these parameters, the first being the page parameter, and here we need to supply a page number, and we can pull our page from the model, and we can decrement for a previous link, and we'll end our anchor tag here, and we'll finish off our final quote there. And all we need to do then is increment for a next link. So here we have established that approach for how we send the page parameter over to our controller so that it can be mapped to the pageable argument and then passed into our repository in order to supply us with a subset of our larger results set. You'll notice that when we return the page from the repository, we place that page in the model with an attribute name of page, and then we're leveraging that within our JSP file by looking at that page attribute, looking at the number field on it, and then using that to get the previous to next page. Now, you could dress this up so you hide or show the link depending upon whether you're at the first or last page. One thing to remember, paging is always zero based, so if you pass 0 as the value for the page parameter, you are going to be on the first page, and that's an important concept to keep in mind. Another thing to remember is that when using a page, we must access the content field on the page in order to get our list of entities. So I need to swap out our books attribute, which is no longer in our model, and use the page attribute and grab the content of that page. And that's going to send our collection of books into the for each tag for our iteration. With all this in place, the final thing to do is provide the configuration that will enable the integration that's going to allow Spring Data and Spring MVC to work together for paging. To do that, we're going to navigate to our dispatcher-servlet.xml file, and within this file, we are going to configure an argument resolver. When we specify argument resolvers, the best place to do that is within the annotation-driven tag, and you'll see that the Spring MVC namespace will provide us with an argument resolvers tag, which can be placed within the body of the annotation-driven tag. Inside the body of the argument resolver tag, we place our bean, which is going to be of type pageable handler method argument resolver. And this is going to enable the pagination support. And within this bean, we need to specify one property, and the property's name is max page size. And as you can probably guess, this is going to determine how many results that we display per page. Normally, you wouldn't pass that in as a request parameter. It's normally fixed unless you're allowing the client to dynamically choose that on the front end. In our case, we're just going to specify a fixed value of 3 results, and at this point, our configuration is complete. We can restart our server, and we'll test out the newly set up pagination that we've put in place. You'll see that we now get the 3 results, and that corresponds with one page, and we can use our next link to navigate through the pages within our larger results set. And we can always go back to our previous pages. So in this lesson, we saw how to enable pagination support by providing the integration between Spring Data and Spring MVC. To do that, we used a pageable handler method argument resolver within our configuration file, and that was specified as part of our annotation-driven configuration. And then within our controller method, we simply added a new pageable parameter to our showBooks controller method, and that pageable parameter has a link set up with the page parameter that is passed by our JSP file through the request to our controller. In this lesson, we will see how to integrate Spring Data's sorting capabilities into a Spring MVC project. To get started, we need to add a sort parameter to our controller method. So I'm going to navigate to the showBooks method, and I'll simply add a parameter of type sort, and I'll give it a name of sort. This method parameter will be assigned the value of a request parameter named sort. So we need to be able to pass that parameter in from our books.jsp file. We'll go to books.jsp and we'll add an anchor tag, which will use a Spring URL to define a link that contains a sorting parameter. So we will add our anchor tag as well as our Spring URL tag. And for the value of our Spring URL tag, we're going to use /books, and then we're going to provide a page parameter. We're always going to start out at the first page, and then we're going to also supply a sort parameter, and in this case, it's going to sort on title. And I need to make sure that I close off my anchor tag. And at this point, we have a table header that includes an anchor tag that can be used to sort our page of books. We're going to go ahead and build out a header for each of our columns. So I'm going to build one for author, and we'll actually specify that we're going to sort by the last name property on the author object. And we'll just specify author as the value. For the anchor, we'll go with page count, and we'll supply a value for our sort parameter of page count. And then finally, we'll include the price. And I'll go ahead and remove our old table headers. And at this point, our page would be set up for sorting. Sorting integration does not occur out of the box, however, and we do need to supply a bit of configuration in order for Spring to support sorting. So all we need to do is within our argument resolvers, we add a new bean, and that bean is of type sort handler method argument resolver. And that's going to enable the sorting integration between Spring Data and Spring MVC. Now, if we restart our application server, we can navigate to our browser, and you'll see that when we navigate to our books.jsp file, we see now that the column headers are hyperlinked, and we can sort by author, by page count, by price, by title, all in ascending order. Now, you'll want to be sure, though, that you do build this into your previous and next links, because we need to pass that sort parameter when we page. If we navigate back to our IDE, we can go to our controller. We will supply a new model attribute, and we'll name this attribute sort, and we'll just do some quick logic to pull out the sort. So we'll check if the sort object is equal to null, and if it's not, we will just get the first item in the list of sorts, and we'll pull out the property. So this is going to be the field that we're sorting on, and if sort is null, we will just supply an empty string. And then we need to close off our add attribute method. So here basically we are assigning a value to a sort model attribute that corresponds with the field that we are sorting by. And then what we can do is we can navigate over to our books.jsp file, and down here where we are paging, we can simply add in our sort parameter to the URL. And we'll say append that sort model attribute, and we can do the same thing within our next link. So now we will retain sorting as we page through all of our results. And we'll navigate back to our list of books, and once our page is rendered, we can run our demonstration. I'm going to sort by the author. And now you'll see that as I navigate through the pages within our results set, we are retaining that sort. So in this lesson, we learned how to use the integration between Spring Data and Spring MVC to achieve sorting between our web and data tiers. We used a sort handler method argument resolver, as well as modified our book controller to accept a sort parameter, which corresponds with a sort request parameter that we are passing in via various hyperlinks within our application. From this point forward in our course, we'll be focusing on Spring Data Mongo. Spring Data Mongo is a Spring Data module that integrates with the MongoDB NoSQL data store. In this chapter, we are going to introduce MongoDB and lay some of the groundwork to start working with Spring Data Mongo. Specifically, we will discuss MongoDB and NoSQL technologies. We'll learn how these technologies came about and what some of the main drivers were for their inception. We'll take a look at how MongoDB differs from a traditional relational database by doing a comparison of the features of both data stores. After we've talked a little bit about Mongo and NoSQL, then we'll begin to install the MongoDB software. It's a pretty simple installation, and we will set up the software and take a look at how we can use the Mongo client as well as the Mongo server in order to get a working version of MongoDB on our workstations. Once MongoDB has been set up, we will then walk through a simple Spring Data Mongo project. You'll see how Spring Data Mongo can facilitate interactions with the MongoDB data store. Specifically, it will provide a nice layer that will provide a facade for working against a Mongo client. So it really abstracts some of the basic commands that you might issue through the Mongo client provided by the Java driver. Finally, we'll take a look at how we can put some basic security in place on MongoDB. Out of the box, the database is going to ship with no security enabled. So we'll take a look at how we can require authentication when connecting to our MongoDB data store. This lesson will provide a quick overview of MongoDB and NoSQL for those of you who may not be familiar with the technology. MongoDB is an open source NoSQL data store that was created in 2009. NoSQL databases and MongoDB are meant to handle large volumes of data and also providing the type of performance we would expect. Organizations are collecting more and more data, so there's a need for a database that can handle a high volume of data and still be able to perform. MongoDB and NoSQL data stores get their performance from their scalability. They are very well suited to operate within the cloud. NoSQL data stores scale horizontally by sharding the database over multiple server instances. This approach is very conducive to the cloud computing environment, where we often spin up new server instances when we need better performance from our applications. In the cloud, when you need to scale out your database, all you need to do is create new server instances and then shard your MongoDB instances over those new servers. This is in contrast to the traditional approach of vertical scaling, where we just simply throw resources at an existing server, or we get a bigger box to handle our needs. MongoDB also helps ease agile development. As we'll see in a moment, MongoDB is schemaless. In other words, we do not adhere to a rigid structure for the documents within the MongoDB data store. This allows us to develop in a more fluid manner because we no longer need to change our rigid schema within a relational database by making alter table statements or all sorts of changes to our data model. Having discussed MongoDB, I'd like to now compare the technology to a relational database. So within a relational database, we traditionally use rows and columns to build out our tables. MongoDB operates on the principle of documents, and as you can see, a document is a JSON-like object that gets stored within our data store. Documents operate on the idea that they contain fields, whereas within a relational database, we're storing information in our columns, and our columns are defining the fields within our tables. You'll also see that within a document, we don't perform joins. Instead, we embed objects. So here you see on the left side of your screen that we have an author field within our document, and that field is an object itself. Whereas in our relational database table, we point to an author ID, which we will inevitably join to an author table. In this way, a document stores much of the object's hierarchy in one place, requiring us no longer to join to other tables to retrieve information. Documents are also schemaless. In other words, each document does not need to have the same structure. So here you see that we have two objects, and they're both representing books, and while Of Mice and Men has information about the page count and the publish date, the Grapes of Wrath does not, and that is perfectly legal within a MongoDB collection. Now, a collection is a set of documents, and as we just discussed, those documents do not need to have the same structure. This is in contrast to a relational database, because in a relational database, every row has the same structure. This is where the folks in the NoSQL camp talk about the efficiencies you achieve with development. If we were to add a new field to one of our documents, and I emphasize one of our documents, it wouldn't need to be the whole collection, we would simply specify that field on our entity, and then it would wind up showing in our JSON-like object that gets stored within our NoSQL data store. If we wanted to do that in a relational database, we would need to go in and alter our table structure, where that's not required when we use MongoDB. In this lesson, we will download, configure, and install the MongoDB data store. To start out, we're going to navigate to the mongodb.org website. And on the home page for the site, you'll see the link to download MongoDB. If we click on this link, we'll be taken to a page where we can then select the appropriate distribution for our operating system. Here you see that there are MongoDB installations available for Windows, Linux, Mac, and Solaris. In my case, I'm working on a Windows workstation, and I'm going to select the Windows 64-bit 2008 R2 distribution of MongoDB. This should be used by all users that are using Windows 7 64-bit. So if you click on the Download MSI button, you'll see that we are prompted to download the installer. Now, I have already downloaded the installer on my machine, so we'll just navigate to my desktop and work from there. On my desktop, you'll see the installer, and to start out, we just need to double-click on the installer, and the operating system will ask permission to run the installer. You'll be presented with a setup wizard, which you'll just click on Next on the first screen. You'll need to accept the license, and then we want to proceed with a custom installation. The reason we're using a custom installation is because we're going to place MongoDB within a directory on our desktop. So I'm going to navigate to my user profile, go to my desktop, and then create a MongoDB folder where the software will be installed. Once I have that directory created, I can click OK, and we will do a full install with every tool within this package. Now just click on Install, and you will be prompted one more time to provide the installer with permissions to proceed. And once we have done that, you'll see that the installer proceeds rather quickly. There we see our MongoDB directory just got created, and we can now click on Finish. The next thing we'll do is open the MongoDB installation directory, and within this directory, we're going to create a configuration file. So just right-click, hit New, and then go to Text Document, and we'll change the name of this document to mongodb.cfg. And then we're going to open this file with Notepad. Within the configuration file, we're going to specify the logging directory as well as where the database should be stored. To do that, we use a YAML style configuration. So we're going to specify a system log, and then we're going to indent using spaces and specify a destination property, and we're going to set that to file, and then we're going to set the path of this file. The file is going to be stored on my desktop, so I'm going to navigate to my user profile, to my desktop, And then within the MongoDB directory, I'm going to create a MongoD log file. Copy this path because the next configuration item that we must specify is where to place our database. And to do that, we use a DB path field, and I'm going to place the DB path within a directory on my desktop, and it's going to be data, and then within that's going to be a subdirectory DB. So I can go ahead and save that configuration file. I'll navigate back to our file system, and within my desktop, I'm going to create a folder named data, and then within that folder, I'm going to create a folder named DB. And that's where the Mongo database will be created. So now I can close the File Explorer, and now I'm going to open a command prompt as an administrator. Within this command prompt, I'm going to navigate to the MongoDB installation directory. So that was within my profile, on the desktop, within a MongoDB folder. And from here, I'm going to navigate into the bin directory. And if we look inside this directory, we're going to see all of the executable files within the Mongo installation. The executable we're particularly interested in right now is the MongoD executable. This is the executable for the database server, and we're going to use this executable to set up a Windows service. So the first thing that we do is we provide a configuration argument, and this is going to point to that configuration file that we have just created a minute ago. If you'll remember, I stored mine on my desktop within the MongoDB directory, and I named it mongodb.cfg. You want to be sure that path is correct to your configuration file. And then we're going to specify the install flag, and this is going to cause MongoD to create a Windows service that is going to use our mongodb.cfg file to specify the configuration settings for our MongoDB service when it starts. So we'll create that service, and now we can start the service by specifying the command net start, and by default the service is named MongoDB. We see that our MongoDB service has now started, so we can begin to use the Mongo client, so that's just the mongo.exe file, to begin to work with the Mongo database that we've installed. The first thing we're going to do is create a new database, and we'll just call it Sandbox. And we're just doing a little bit of testing to make sure our install was successful. So now we have a database named Sandbox, and we'll create a collection on that Sandbox database, and we'll just call it test. And once that collection is created, we can then insert into the test collection any record we would like. So here we're putting in a document, and I'll just supply a test parameter with a value of test. You'll see that we're using a JSON type syntax to insert a document into our collection. And there we get our results that it was successful. And if we would like to find that document that we have just inserted into the collection, we can use the find method. And there we see our document. So it appears that we have successfully installed MongoDB on our Windows workstation, and we'll be working with this MongoDB data store that we've installed throughout our next few chapters to get a better understanding of the Spring Data Mongo project. In this lesson, we're going to walk through a simple setup and demonstration of Spring Data Mongo. To get started, we're going to add our entity to our base project. So we are going back and starting from that base project we created earlier in the course. I'm going to first open the new dialog, and we'll create a class. And this class is going to be our book entity. And we're going to place this entity within the com.o'reilly.sData package. So we'll build that class out, and then I'm just going to copy our book entity and all of its code into our class. At this point, we can close our book.java file, and we'll proceed to open our pom.xml file. Within the pom.xml file, we need to switch up some of our dependencies. We're no longer going to be using Spring Data JPA, so we can remove that artifact from our POM file. Next, we're going to go ahead and add the Spring Data Mongo artifact into our POM. So you'll see the org.springframework.data group ID, and then the spring-data-mongodb artifact ID. And with that in place, we have the appropriate Spring Data libraries to work with Mongo. Next, we're going to head to the Package Explorer, and we're going to create a new Spring Bean configuration file, and we'll call this file applicationcontext.xml. And we'll click on the Finish button, and when our XML file is available, you'll notice if you click on the Namespaces tab, you now have a Mongo namespace available to you. So we'll click on the Mongo namespace, and then we'll return to our source. So we're going to go ahead and use the Mongo namespace to create a Mongo client. A Mongo client provides us with a connection to our Mongo database, and we can invoke different methods on the client to interact with that database. We're going to give our client an ID of Mongo client. That way we can access it within our application.java file, which we're now going to create within our com.o'reilly.sData package. So I'll use the new dialog and create a class named application, and we'll place that within our package. And inside the application class, I'm going to add a main method. And now we're going to start building out our application. The first thing we'll do in our main method is start building our application context. So I'm going to use a class path XML application context, and I'll name this variable context, and then we'll use the new operator along with the class path XML application context constructor to reference our application context.xml file, which contains the bean definition for our Mongo client. You'll want to be sure that you have the spelling of your XML file correct so that you appropriately load the configuration file. Next, we're going to pull the Mongo client from the Spring IOC container using the getBean method. And we're going to provide our ID of Mongo client. And since we're using an ID, we're going to have to cast to a Mongo client. And at this point, we have a client that can interact with our MongoDB data store. Next, we're going to use the DB object, which we'll obtain from the client by invoking the getDB method. And we're going to get the sandbox database that we have created. And next, we will reference a collection on that database. So I'm going to declare a new variable of type DB collection. I'll just name it collection, and then we're going to use our DB object to get our collection, which we're going to name book. We'll import the DB collection type, and now we'll go ahead and use our collection to insert a document into the collection. So I invoked the insert method, and what we can do is provide a basic DB object that we'll use to build out our document. So I'll import that type. You'll notice it has an append method, and all we do here is provide our key value pairs. So I'm going to go with a title field, and then for the title we're going to go with Harry Potter. So this is going to insert a new document into our book collection, and that document is going to have one field named title, and that field is going to have a value of Harry Potter. So this is pretty simple. Let's go ahead and run our application, and we'll take a look at our logs, and there we see that our application has terminated. And if we navigate to the console, we can go ahead and open up the Mongo client, and then I'm going to navigate to the Sandbox database. And within the Sandbox database, I'm going to find every document within the book collection. And there we see our recently inserted document where we have the title field set to Harry Potter. Now, we'll go ahead and work with this book collection more throughout our lessons. And I'd just like to point out that at the moment, we only have one document and it has one field. But as we work with the collection, we can insert other documents, and those documents don't have to match the same format of our recently inserted document. You'll see that the documents can vary in their structure, and that's part of the whole NoSQL philosophy or approach to storing our data. If you develop with security in mind, you're most likely noticing a huge red flag within our simple Spring Data MongoDB application. Looking at the application and our Spring Bean configuration file, you never see a point in time where we are authenticating with MongoDB. The reason for this is that out of the box, MongoDB does not require authentication. So in this lesson, we're going to take a look at how we can configure MongoDB to require authentication, and then how to provide those credentials within our Spring Data Mongo application. This will allow us to secure applications that use MongoDB. To get started, I'm going to navigate to a command line, and I will open the Mongo client. You'll notice that the Mongo client has started us out in the test database. Instead, we want to be using the admin database. Once in the admin database, I'm going to use the create user method on the Mongo client, and this method accepts a JSON-like object for the user that we would like to create. The first field that we supply is the user field, which corresponds with the username. The next field is the PWD field, which is the password, so I'll supply a value of password, and then I need to supply some roles for this user. We supply roles using an array of role objects. The role object has a role field, and we can now specify a built-in root role within MongoDB. Next, we need to identify the value of the DB field, which says what database this role applies to. In our case, it's going to apply to the admin database. Basically, we have just built out a root user. Once I submit the command, we'll get a success message, and now I'm going to navigate to our Sandbox database. Within the Sandbox database, I'm going to create another user. So once again, we supply our JSON-like object, and this user is going to have the name books. For the password, we'll keep it simple with password, and then we need to supply the roles for this user with our array and our role objects. So the role for this user is going to be DB admin, and it's going to apply to the Sandbox database. So we'll go ahead and build out our new books user, and then we're actually going to grant this user a new role. So we can use the grant roles to user method on the Mongo client, which accepts the user name as the first argument, and then an array of roles that we would like to grant to an existing user. We once again need to use a role object and specify the role field, which is going to be read, write, and then we're going to specify our DB field, which is going to be sandbox. So we'll go ahead and provide that role to our books user. At this point, I am going to exit the Mongo client and we'll clear our console. To continue our security setup, I'm going to navigate back to STS and I'm going to open our Mongo configuration file. You'll remember I put that file on my desktop within the MongoDB directory and within the mongodb.cfg file. So if we open that file, we're going to add a security section, and within that security section, we're going to specify the authorization field, and we're going to say that it's enabled. So we'll go ahead and save these changes to our mongodb.cfg file, and then we'll close the file. At this point, we need to navigate back to our command line, and we're going to stop the MongoDB service. So there we see that I have stopped the service on my machine, and now I'm going to start it back up for those configuration changes to take effect. Now I will navigate back to my application context.xml file in order to add the credentials to connect to the Mongo data store. Adding credentials is very simple because of the Mongo namespace. On the Mongo client, there is a credentials attribute, and all we need to do is supply our username and then a colon, followed by our password, and then the database that we are connecting to. And with that change in place, we are able to execute our application, and I'll insert a different book this time. So let's go with David Copperfield, and you'll notice that we now authenticate with MongoDB prior to inserting our new document. So I'll run this application, and there if we look at our console, you can see that the application has completed. And now we can head to the command line, we'll open Mongo, we'll go to the sandbox database, we will authenticate, and when we authenticate, we need to use the auth method on the client, and we provide our username followed by our password, and that's going to allow us to connect. And now we can look within our book collection to find our newly added documents, and it looks like I ran our application twice because we see 2 records. But had we not provided those credentials within our application context.xml file, MongoDB would not have authenticated our client and we could not have inserted our new documents. When working with Spring Data Mongo, there are 2 main approaches that we can use to perform operations against our MongoDB data store. The first is to use the Mongo Template, and the Mongo Template provides a set of predefined methods that we can invoke when we want to save our documents into the MongoDB data store. The other approach is to use the Mongorepository. In this chapter, we're going to focus on the Mongo Template. The Mongo Template is really the core class within Spring Data Mongo. Underlying the Mongorepository approach is actually the Mongo Template. So we haven't seen repositories yet for Spring Data Mongo, but if you were to inspect those repositories, you would see that underneath the interface and when we see the implementation, they are actually using a Mongo template instance to perform all of the different CRUD operations against the underlying data store. So in this way, Mongo template is really the closest thing we get to interacting with our MongoDB data store. For example, you're going to find methods such as find1, insert, update that appear on the MongoDB driver classes within the Mongo template. The way you interact with these methods may be a little bit different, but there is a mapping between the methods on the native Java driver and the Mongo template. So this makes it easy for those of you who are familiar with the MongoDB driver to start using the Mongo template because of the relationship between the methods on the driver and on the Mongo template. Now let's take a look at what we're trying to achieve within this chapter. As with almost every Spring feature, we need to know how to configure an appropriate bean. So in our lessons, we'll take a look at how to establish a Mongo template bean within the Spring IOC container that we can then use within our client code in order to perform CRUD operations against our documents. We'll learn how to map the domain objects within our project to the BSON format used by MongoDB. Now, don't be intimidated by BSON. It's basically binary JSON, and it follows the JSON format very closely. In fact, you'll hear me use the terms interchangeably. If you can understand JSON, you can easily understand the BSON format used by MongoDB. Once we have our objects mapped and our Mongo template established, then we'll work to use the template to insert, remove, update, and delete documents within our collections in MongoDB. So this is pretty straightforward. You'll see some new methods out there. If you're not familiar with an upsert, it's kind of interesting how that works. So we'll see all of the different methods that are provided by the Mongo template and how they allow us to work with our underlying data store. We'll take a close look at the query and criteria objects within the Spring Data Mongo module, and we'll learn how we can use these objects to construct complex queries against our MongoDB data store. At the end of this chapter, you'll have a good understanding of how to work with MongoDB using Mongo templates, and it will also reveal to you some of the underlying principles that are used within the repository approach to working with MongoDB. In this lesson, we will take a look at some of the features within the Spring Data Mongo module that can assist us when configuring our applications. Looking at our previous application, you'll see that we have used the Mongo namespace and the Mongo client tag on that namespace to configure a Mongo client. If we were to inspect our application where we use the Mongo client, you would see that the Mongo client is located within the com.mongodb package. And this is actually part of the MongoDB driver API. So it's a class that is provided by the folks at Mongo, and it's not a part of the Spring Data Mongo module. If we return to the class, you'll see that we are also using other native Mongo classes such as DB and DB collection. You'll notice that the DB class requires us to specify the name of the database we'll be working with. We're going to look at how the Mongo DB factory can eliminate this need and help us with our configuration of the Spring Data Mongo module. To get started, we're going to navigate to the application context, and within the application context, we'll look at the Mongo namespace. You'll see that we have a DB factory tag within that namespace. Let's put that in our configuration file. While we're in the configuration file and looking at the Mongo namespace, one thing I do want to point out is that you will see this Mongo tag. And this tag is used to specify a com.mongodb.mongo object, and traditionally this has been the entry point to the Mongo driver API. It has currently been replaced by the Mongo client. It is much more preferable to use the Mongo client because in fact the Mongo class within the Mongo libraries could possibly be deprecated in the near future. So we want to avoid the Mongo tag, and we always want to prefer the Mongo client tag when providing our configurations. So just a side note there that's rather important. Let's proceed with configuring our DB factory. The DB factory requires us to specify a DB name attribute, so we're going to provide a value of sandbox to correspond with our database. We're also going to point to a Mongo ref. Now, our Mongo ref is actually going to be our Mongo client, which has specified our credentials to connect to the Mongo data store. If we would like, within the Mongo client, we have the option to specify some more options about how we would like to configure our Mongo client. You'll see several attributes that we can specify on the Mongo client options tag. Let's just go ahead and set a timeout that we can use, and we'll set our timeout to 1000. So at this point, we have configured our application context.xml file to use a Mongo DB factory, which is going to ease some of our configuration of our Spring Data Mongo module. Now we're going to navigate over to our application, and we're going to modify the application to use our new Mongo DB factory. So within our application.java file, I'm going to replace our client with a Mongo DB factory, and I'm going to name this object factory. We'll import the MongoDB factory type, and then we're going to pull a MongoDB factory bean from our Spring IOC container by the class. So there we see we pull out the factory, and now we're going to use the factory to get our DB. We do not need to specify that we are connecting to the sandbox database, and I'm going to actually remove the Mongo client from our list of imports, and we'll change up the title of our book to a book, let's say, using MongoDB factory. So let's save our application, and we'll run this example, and if we look at our console, we see that our application has terminated. So we'll head over to our command line, and I'm just going to query the book collection for all records to see if our book was inserted. And there we see our book with the title using MongoDB factory. So if we return to our configuration, we can see how we configured our MongoDB factory. And you might say, wow, big deal, we don't need to specify the database name in our code. But you will see that having the MongoDB factory aware of our database name will be beneficial when configuring other Spring Data Mongo components. In this lesson, we're going to take a look at the Mongo Template. The Mongo Template is a key part of Spring Data Mongo's support for the Mongo data store. The Mongo Template can be used to perform all sorts of CRUD operations with our domain objects. So instead of using the native Mongo classes that are part of the Mongo Driver API, we'll be using our domain classes that can be persisted through the Mongo Template. To get started, we're going to add the Mongo Template bean to our application context.xml file. And to do that, we'll use the Mongo namespace, and on the Mongo namespace, we're going to find this template tag. Now, the template tag has a DB factory ref attribute, and the value for this attribute should point to a DB factory. So you see that we have declared a DB factory within our configuration file, and I'm just going to name that bean MongoDB factory. So we'll go down to our DB factory tag, and we'll specify the ID of MongoDB factory. At this point, our template is configured, and we're ready to pull it into our application code. So we're going to navigate to our application.java file, and within this file, we are going to use our Mongo template. So we're going to remove our MongoDB factory, and we're going to add a new variable of type Mongo Template with the name of template, and we'll switch up the bean we're pulling out of the IOC container to be a Mongo Template. The next thing we'll do is get rid of the native DB object that we're creating, which is out of the Mongo API, and we'll also get rid of the DB collection object, which is also part of the Mongo API. And we can remove the invocation of insert on that collection. Now we're going to use the book util to create a new book. You'll see that the book util has been added to your working files, and very simply we just need to grab the template and we can invoke the insert operation on the template and we pass in our book. This concludes all of the application code that we need to modify. Now there is one other thing we need to do. We need to navigate to our book entity, and we got to remove all of our JPA annotations. So I'm just going to go down through and remove these annotations, and we'll clean up our imports. Next, we need to specify the ID annotation on our book ID field. Now it's very important that we choose the org.springframework.data.annotation.id, and we don't pick the JPA annotation. So with that annotation in place, the next thing we'll do is we will change the type of our ID. So we want our ID to be a string or a big decimal. In our case, we're going to choose string, and I would recommend going with that most often. Since we've made that change, we'll need to adjust our accessor methods. So we'll change our get and set methods to use a string instead of a long. And we're going to now update our toString method on the entity. So we now have our entity configured to be used by the Mongo template. I'm going to navigate back to the application and I'm going to clean up our imports. And at this point, we are ready to run our demonstration. We'll next navigate to our logs, and we see that our application has terminated. And if we head over to the command line, we can look within our collection and see if we can find our newly created book. And there we see our book object, which has been added to our Mongo data store. So this document is now part of the book collection, and one of the unique things you'll see is the object ID. And you'll notice that within our entity, the book ID was a string, but here you see this underscore ID field on our document, and it's of type object ID. Well, there are converters within Spring Data that take that object ID and map it to our string book ID. So we'll talk about converters a little bit later. You'll see also that there is a date object which is stored in our document, but overall we were able to successfully insert a document into the books collection using the Mongo template. Now, returning to our application class, one of the things I'd like to show is that when using the Mongo template, it's a good practice to use the Mongo operations interface, which is implemented by the Mongo template. The Mongo operations interface attempts to mimic some of the methods that are available on the collection object, which is part of the MongoDB driver API. So developers coming from a background where they have worked natively with the Mongo API will be able to identify the methods on Mongo operations and map them over to what they've experienced using the native Mongo API. In this lesson, we got our first look at the Mongo template, which allows us to persist our domain objects to a Mongo data store without using a lot of the native Mongo classes. In this lesson, we're going to take a look at how we can map our domain object classes to MongoDB BSON. BSON is the JSON-like format that we use to structure MongoDB documents. We're going to take a look at a set of annotations within Spring Data that can be placed upon our domain objects, and that will guide our MongoDB implementation when it is interfacing with the Mongo client to put our documents into collections. To start out, we're just going to take a look at our simple application. You'll notice that we are inserting a book into our MongoDB data store. That book object will wind up in a book collection. However, if we take a look at the book class, you'll see that the domain object does not specify any collection. So how did Spring Data Mongo know where to put our book object? Well, it came down to relying upon a convention. By default, Spring Data will look at the class name, and then it will lowercase the first letter in the class, and that is the collection that the document will be inserted. If we would like to control which collection the document is inserted, we can place the document annotation on our class. Within the document annotation is a collection element that we can use to specify the name of the collection where we would like to store our domain object. So in this case, we're going to go ahead and specify that we would like to save any book object within a collection named book. The document annotation also indicates to Spring Data that our class is a candidate for mapping to the Mongo data store. This is much like the entity annotation within JPA. Next, you'll see an ID annotation that has been provided on the book ID field. This is also a Spring Data annotation, and this marks that our field should be used for identity purposes. If we persist an object and the ID field is null, MongoDB will automatically populate that field with a unique identifier. Within each JSON document that is stored within the data store, there will be an _ID field, and this acts basically as the surrogate key for that document. Each document is required to have an _ID field. Now, the nice thing about Spring Data is that it allows us to specify our ID field in the string data type. There is an object ID data type, which is a JSON type, and it can be used within your domain objects, but luckily for us, Spring Data is able to convert between the string and the object ID, which is expected by MongoDB. Next, we're going to take a look at the field annotation. And the field annotation is also provided by Spring Data, and it allows us to specify the field name that we would like to use on our JSON document. So on the document for our title field, we're going to have a field name of title. We can also specify the order of the field, so this will determine the order that our fields appear on that document. We're going to abstain from specifying an order because really it's of no concern to us. So these three annotations can be used to determine how our domain objects are mapped to a document within our MongoDB repository. Now, looking at this entity, you'll also notice a few things. We have added an author field as well as a list of strings that we're calling tags. And we'll be using these two fields to perform some different operations using the Mongo template throughout this chapter. Just be aware that we have modified our underlying domain object to include these new fields. So in this lesson, we learned how to map our domain classes to MongoDB using the annotations provided by the Spring framework. Looking at our application, you will notice that we are currently invoking the insert method on the Mongo operations interface, and this is the most simple form of the insert method. There are various other overloaded forms that we can use. The simplest form accepts an object, and it looks at that object and inspects its class. So for example, it's going to look at the book class and see that it has the document annotation and that it specifies a collection, and our object will be placed within that collection. We know that there is a default approach using the class name to determine the collection if we would not have that document annotation in place. It's probably best just to put the document annotation there and specify your collection. Another approach is to use a different form of the insert method. So there's an overloaded form that accepts a collection name as the second argument. So here I have specified a collection name of library, and if we run our application and navigate over to a Mongo client, I can find all records within a library. And there we see our newest addition to the library. Returning back to STS, you will also see that there are other forms of the insert method. So for example, there are two forms that accept collections, and then those collections are placed in an appropriate collection either by specifying a string with the collection name or a class that will have its document annotation consulted or its name consulted in order to determine the collection. There's also an insert all method. We're not going to cover this one, but in a nutshell, here's what it does. You see that it accepts a collection of objects. So if we generically type a collection and make it abstract enough, we could put a varying amount or types of documents into that collection. So for example, we could have a book, a magazine, maybe a film, and they could all be in that same collection as long as it's generic enough, and we would pass that collection into the insert all method, and our Mongo template would add those documents for each object into the appropriate collection. So you can have different document types within that collection, and Mongo template will handle inserting them into their respective collections based upon the methods that we have described to determine the collection for a domain object. We're not going to run through a demonstration, as I said, for insert all, but we will walk through inserting a collection. So in order to do that, we need to have a collection of books, and we're going to use a list, and we'll change up our object's name to books instead of singular book, and we'll use the book util to create 4 books. We'll import our list type, and now we can pass our list of books into the insert method in the first parameter position, and now we can specify that we would like to put that list into the book collection. Run this demonstration, navigate over to our client. This time we are looking within the book collection, and there we see the books that we have created to be placed in the book collection that correspond with the list that we build out. So if we return back, you'll see the other form of this method is to specify the class instead of just a string with the collection name. This class will be consulted using the approaches we discussed previously to determine the appropriate collection for these books. It gets a little complicated because we're talking about Mongo collections as well as Java collections, but we're going to put all these books into a Mongo collection. And we can see now, if we head to our client, we have more book documents within that collection than before. And we were able to direct where those books were going by specifying our class. We still have another approach to discuss, but at this point, we're going to take a break in this lesson, and we'll pick it up in the next video. To complete our lesson, we're going to discuss the save method on the Mongo operations interface. The save method is another approach that we can use to add a document to a collection. However, there's a little caveat to the save method. So if we were to invoke the save method, we can provide a single object. So we're going to get rid of our list of books, and we will just create a single book object and pass it to the save method as an argument. Now, the save method will inspect the ID of our domain object book. If it sees that the ID has been set, it will then proceed to update any document with the same ID within our MongoDB collection. If it does not find an ID on the book, it will go ahead and insert the new document into our book collection. So let's create a new book. I'm just going to run this application, and we'll navigate over to our client, and we'll look within the book collection, and there we see our newly inserted document. You'll notice that the title of the book is Brave New World. So what we'll do is we will pull that book from the MongoDB data store using a basic query. We'll discuss queries in a later chapter, but for now we just need to return that same document. So we'll import the query type, and now we need to provide some criteria for the document that we're trying to retrieve. And we're just going to specify that its title must be Brave New World. So we have our query, and then what we can do is use the template, and it has a find method that accepts a query as well as the type of the document that we would like to return. So we specify our book class, and we're also going to get the first item within the list that is returned by our query. We'll assign that item to our book object, and then we're going to update the title on that book to I have been updated, just so it's nice and obvious. And then we will save our book using the save method on the Mongo operations interface. So what we will see is that because we have an existing book object or book document that does have an ID, the respective document will be updated within our MongoDB data store. And that's exactly how save behaves. And we'll run our application, we'll navigate over to our Mongo client, and we will find all records within our book repository. And there you see that if we inspect the title, towards the end of the second line, it says, title, I have been updated. So instead of performing an insert as it did the first time when no ID was available, the save method performed an update. This concludes our lesson on the various approaches we can use with Spring Data Mongo to add documents to our collections. In this lesson, we're going to take a look at several methods we can use to update our documents with Spring Data Mongo. Looking at our application, we already see one very simple approach. You can query for an object and return the results of that query into a domain object or a collection of domain objects, and then you just work within your client code to set the appropriate fields or make the appropriate adjustments to your objects. And then you can use the Mongo operations interface to save that document by just using the save method. And this is going to issue an update within the MongoDB data store. So you always have the option of just returning that result from a query and manipulating it within your code. In some instances, this may not be the most efficient approach. So we're going to explore some other options that are provided by the Spring Data Mongo module. In order to help us with this, we're going to remove all of our current code, and then we're going to clean up our imports as well as add a few static imports. And these static imports are going to allow us to invoke static methods without fully qualifying them. So for example, on the criteria object, we are going to pull in the where method. We're also going to pull in the query method on the query object, and these are all provided by Spring Data. And finally, we're going to use the update object and its update method. With those in place, we can invoke those methods without going through their static class. Now, if we return and look at our Mongo template, you're going to see there are two varieties of update methods. One is the update first variety, and another is the update multi variety. Update first is going to update the first document that is within a query that we provide. So the first object you see that we pass into this method is a query. And that query is going to return a set of documents, and then we're going to pass an update object, and this update object is going to be performed on every document within that result set. Next, we specify an entity class, and we can also specify a collection name. Technically, we only need to provide one of these, so I'm just going to use the 3-parameter form of the update first method. But what we do need to do is we need to construct our query. So we can use the query static method, and within that method we provide a criteria. So we can use our where static method to say where the title is equal to some value. So we can use the is method on our criteria, and we're going to say where the title is I have been updated, because we know that we have a book with that title inside of our MongoDB data store. At this point, we have defined our query, and we'll just import the types. And now we can go ahead and specify our update object. For the update object, it's going to dictate what operations we're going to perform on the results returned by this query. So in our case, we're just going to adjust the title. So we're going to create a new update object, and we'll import that type. And if we invoke the set method, we can provide a field, and then we can provide a value. So let's say something else. And here you see that we have provided an update object that is going to set the title to something else. Now there is the update object that we had imported, and that's just shorthand for invoking the set method. So we can do something like this, and we need to return that static method so we can call it unqualified. Looks like cleaning up our imports took it away. So now we don't have any problems there. And you see we've passed our query in, we pass our update object in, and now we're going to pass our book class so it knows what type of document we are working with here. And in this case, if we execute our application, we can head over to our Mongo client, and we'll look at the book collection, and we'll pull back every object. And there you see that our title has indeed been updated to something else. Now, as I stated previously, I could have just executed a query and had the result go to an object, work with that object, and then invoke the save method. That would probably be my preferred approach when updating one entity. One thing to note with the update first method, if there were multiple books with the title I have been updated, we would have only updated a single book because we're using update first. If we wanted to update every book that met our query's criteria, then we would need to use the insert multi method. So what we're going to do is we're going to set up a quick example where we will work with insert multi. You'll notice we really don't even need to change any of the parameters that we provide to the update multi method from the update first method. but we do got to set the stage a little. So we're going to save a few books by using the template save method and the book util. And we'll just add 3 books in. So now we'll have 4 within our Mongo data store. And then I'm going to create a new query. And this query is just going to return every document within the collection. And then we're going to update it to set the title of each book to using multi. So at this point, we're going to select every document within the book collection, and then we're going to update its title, and we're going to do all this by invoking the update multi method. So let's run our demonstration, head back over to the client, and we will once again look at the documents within our collection, and there you see that every one of our documents has had their title updated to using multi as we had specified within our update object. And finally, I'd like to end our lesson by taking a look at the actual update object. So the queries that we have been executing and the updates we've been performing are pretty tame. If we look at the update object, you'll notice that on this object are a variety of methods that actually correspond with Mongo operators. So for example, here you see the inc method, which is going to increment a number. And you actually see over in the information we get through the IDE, it says see also, and it's actually pointing to a mongodb.org webpage that's the reference for that actual operator in Mongo. And you're going to see all of the Mongo operators appearing on this update object so you can perform more complex updates. We won't dive into each one of these features just for time constraints, but if you understand the underlying MongoDB operator, it's pretty easy to see what the update methods are going to do for you. And there are references to the documentation where you can find out what their behaviors are. So in this lesson, we learned several approaches to updating our documents using Spring Data Mongo. In this lesson, we'll take a look at how to perform an upsert using the Mongo template. An upsert is a combination of an insert and an update. When we perform an update, we create a query, and that query is passed into our update method. Well, with an upsert, if no results are returned from the query, we will perform an insert using the criteria specified within the query as well as our update condition. For example, let's say we wanted to search for a book document with a title, and that title is going to have a value of "To Kill a Mockingbird." So we'll go ahead and add in our static imports. So we're going to put in our criteria, and we'll add the where method in so we can start to develop our criteria for this query. We're also going to say and the author.firstname is Bob, and we'll also chain on there and the author.lastname is Smith. So we've established our criteria, and you'll notice it specifies many conditions. And what we'll do is we will update the page count on that book document if our query returns a result, and we'll set the page count to, let's say, 1. We'll make it something very distinct. And now we're going to switch our update multi method over to an upsert. And you will see that the parameters remain the same for that method. So what we're saying here is if we find any results that match this query criteria, we're going to update their page count to 1. If we do not, we are going to insert them into our collection. So before we execute our application, I'm going to navigate over to the client, and we'll just take a look at our book collection. And you'll notice there's no records. So when we execute this application and we head back to our client and we now execute the find method on the client, you see that our object, our book document, was inserted into the book collection. Now that the document is in the collection, if we were to execute our application again, and let's say provide a different page count of 1000, now when we execute the application, you'll notice that our page count is going to go up to 1000. So this time we performed the update. So an upsert is a way to perform an insert if a document does not exist, or to perform an update if the document does exist. It does provide us some consistency in our code because we can be sure that the upsert is going to result in a document being within our collection. So this concludes our lesson on upserting using the Mongo template. Removing a document from a collection is one of the simplest operations to perform when using a Mongo template. If we inspect the template, you'll see that there are several overloaded forms of the remove method which can be used to remove a document from a collection. The easiest form is simply to pass in an object to the remove method, and that document will be removed from the collection. You can also pass in an object which corresponds with the document in the data store and a collection name. Other forms of remove use a query that we specify along with an entity class, and that's what we're going to look at. So we already have our query constructed, and we're just going to provide a class to indicate what collection our document should be removed from. So in this case, if we look at our book collection, you'll see that currently we have To Kill a Mockingbird within that collection. Once we execute the remove operation within our application, we're going to remove that document from the collection in our data store. So if we execute our find method again on the client, you now notice that that document has been removed. So removing is very simple, and you can always use a query, or you can use the actual object instance that you would like to remove from the MongoDB data store. In this lesson, we're going to take a look at two simple query methods that we can use on the Mongo template. So I'm going to remove our application code, just leaving our template in place. Next, I'm going to create a new book using our book util, and I'll just invoke the create method. Next, I'm going to use our template to save the book. And now we're going to use the find by ID method to retrieve our book object from our collection. So to use the find by ID method, we're just going to get the ID from the book, and that ID has been populated by the Mongo data store, and then we need to provide the class of the book, and that tells Mongo which collection to look in. We'll assign this to a new book, and then we can print that book out to the console. So it's very simple. It fits in with a lot of what we see in Spring Data, being able to find a domain object or a document by its ID. And if we run this example, we can look at our console, and you see that we do indeed retrieve our newly created book. Now, while we're working through this lesson, we're going to take a look at one more find method on the template. So the template also has a find one method, and using the find one method, we can create a query. So we'll build a new query, and the query accepts a criteria. So we're going to use the where method on the criteria, and we can specify our book ID, and then we can say is, and we need to make sure that's a string, and then we'll pass in the ID of our book. And we also need to specify the entity class, so that's going to be our book class. And in this way, we can retrieve our book from the underlying data store. So we'll go ahead and run this example. And there you see we were able to pull out our newly created book using a find one query. And you actually see within the console output that we're using the find one query, and you see the criteria that was being used by the Mongo template. In this lesson, we took a look at two approaches to finding entities within our collections. There are more advanced approaches out there, but these are two of the simple approaches that you can use within your applications. In this lesson, we will take a closer look at the query and criteria objects to see how they can help us execute complex queries within Spring Data Mongo. To get started, we're going to need some sample data. So we're going to import a JSON file using the Mongo import utility. So I'm going to navigate to a command prompt, and if I look within my MongoDB bin directory, I see all of the executables, and there I see Mongo import. You'll also notice that there is a populate.js file within this directory. And this file is available in your working files directory, and you should pull it out of there and place it within your MongoDB bin directory. Populate.js contains several JSON documents that we're going to import into our MongoDB data store. So to do that, we use the Mongo import utility, and we need to specify some options to this utility. First, we specify the database, which will be Sandbox. Next, we specify a collection, which will be book, followed by a username, which is going to be books, and then a password, which will be password. We're also going to specify the drop option to drop any existing documents within the book collection. And then finally, we specify our file name, which is populate.js. Now, when we run the Mongo import command, you'll see that we get 16 documents placed into the sandbox.book collection. So we can log into Mongo, and we can use our sandbox database, and then we can authenticate with that database using the books and password credentials. And then we can look within our book collection, and if we select everything, there we see all of the documents that were imported into our collection. So now we can execute some queries against that collection of books that we've just imported. To proceed, I'm going to remove all of the code within our main method, except for where we declare our template and pull it from the Spring IOC container. And next, we're going to create a query object, and we can do that by just using the default constructor for query. And there we see that we import the org.springframework.data.mongodb.core.query.query object. And this query object allows us to pass in a criteria into the constructor. So we're going to go ahead and add a criteria object to our main method. And to do that, we invoke the where method on the criteria object. So this is a static factory method, and basically it accepts the field name or the key for the field within the document that we would like to establish our criteria against. In our case, this is going to be title. Now you'll notice there's a lot of chaining that goes on with this criteria object. And we're able to invoke all of these different methods which correspond with a lot of Mongo operations. So there we see the LT method corresponds with the less than operator within Mongo. And we see that relationship between these methods and their Mongo counterparts as we look through the documentation. So there's quite a few of them, and we're just going to look at probably the most simple right now, and that's the is method, and that is pretty much equivalent to an equals. So we're going to check where the title is equal to Moby Dick. And what we can do then is pass that criteria into the query constructor. Now, in order to execute this query, we can use our template. And the template has multiple find methods on it. And if you look through, there we see two simple find methods, but then there's find all and remove, find and modify, find one. So if we only want to return one result, we can invoke find one. We pass in our query along with our entity class, and we can assign that to a book. And then in our next line, we can print out the book. So here we see ourselves passing this query object as the first argument in the find one method. And then we specify our entity. And we can execute this example. And if we look in our console, there you can see that we are returning the Moby Dick book. So let's return back to our application. Next, we're going to take a look at another criteria that we'll establish. And this criteria is actually going to use a regex. So in order to use the regex, we invoke the where method, passing in our field, in this case title, and then we are going to invoke the regex method. And for the regex method, we can use a pattern and we can compile that pattern. And in this case, we're just going to do a like search with wildcards, and that's what our regex is specifying here, for anything that contains of within the title. And this is going to return multiple results, so we can use a different approach by invoking the find method. So here's singular find. We pass in our query along with our entity class. And now we got to change this to a list because we're going to return a collection of books. And at this point, we're going to need to iterate through our list of books and then print out the book as we iterate through our list. So we're going to return every title with of inside of it. So there we see we get several books back: Lord of the Flies, The Call of the Wild, A Tale of Two Cities, and you see we get all the information about those books. Another thing that we can do is if we look at the query object, you can see that it has an add criteria. So we can chain on more criteria. So we can do something like criteria where, and we can look at our page count field and say where it is greater than 300. So now we're going to return all results that contain of with a page count greater than 300. And you see how we're chaining our different criteria together using the add criteria method. And we can execute this example. And there you see that we return two book documents, and both have of within their title. And we see that their page count is greater than 300. So we saw how to combine our criterias in order to perform a more complex query. And we can continue to keep chaining on these criteria to develop quite complex queries against our MongoDB data store. So in this lesson, we learned how to use the criteria and the query objects to perform complex queries against our collections within our MongoDB data store. In this lesson, we will learn to configure a Mongo template using Spring's Java configuration. Java configuration is an alternative to the XML configuration that we have seen thus far. In order to get started with Java configuration, I'm going to navigate to the Package Explorer and I will create a new class. I'm going to call this class config. And once our class is built, I'm going to add the configuration annotation to our class declaration. This signals to Spring that our class will contain bean definitions that should be instantiated inside the Spring IOC container. In order to declare a bean within our class, we use the bean annotation and we place that annotation on a method. In our case, our method's going to return a MongoDB factory, and we're going to name this method MongoDB factory. And we'll go ahead and open up the body of our method. And within this method, we need to construct a MongoDB factory. In order to do that, we need to use a Mongo client URI, which is a dependency of the Mongo client, and it will be dependency injected into the Mongo client's constructor. We'll go ahead and build the Mongo client URI using a constructor, and this constructor accepts a string that defines your connection string to the underlying data store. If you're familiar with a connection string to a database, it starts out with a protocol, and then that protocol is preceded by the username and the password, and then you specify the server name or the host name, and then you specify your database name. So there we have constructed our Mongo client URI, and now we're going to build our MongoDB factory using a simple MongoDB factory constructor. This constructor accepts an instance of Mongo, so we're going to instantiate a new Mongo client object, and we're going to pass our URI into that constructor, essentially dependency injecting it. And then we specify the name of the database that we're connecting to. You'll notice that we also need to throw an exception from this method. With that in place, we have our first bean, and now we need to set up a bean for our Mongo template. So I'll declare a new method that returns a type of Mongo template, and we'll name this method Mongo Template. And it's real simple. From our return statement, we just instantiate a Mongo template with the constructor, and then we invoke our MongoDB factory method to inject an instance of a MongoDB factory. And then once again, we're going to add the exception handling by throwing our exception. With this in place, we're going to save our config file, and then we're going to navigate over to the application file. And here's where we're going to switch up our application context to use an annotation config application context. Initially, I'm going to declare the context object of type application context, and that's a more generic form. But when we construct the application context building our IOC container, this is where we're going to use the annotation config application context. This constructor accepts a class, so we're going to pass in our configuration class to the constructor for the annotation config application context. You'll see that with this new application context in place, we can simply pull the Mongo template bean from our Spring IOC container and use it just as we had done before with the XML configuration. So with this in place, let's run our demonstration, and there we see that we were successfully able to execute our query, and that confirms that our Java configuration was set up. This concludes our lesson on configuring a Mongo template using Spring's Java configuration. Our new chapter is going to focus on the Mongo repository. Throughout this chapter, we're going to take a look at repositories within Spring Data and how we can use them to work with an underlying MongoDB data store. We'll see how the Mongo repository adheres to Spring Data's notion of a repository within the project. Let's take a look at our chapter objectives. So we have the Mongo repository, and it is a bean that will be declared within our Spring IOC container. So we're going to learn how to configure a Mongo repository for a particular entity within our project. In our case, we're going to configure a book repository, and we'll see how that repository is then able to perform persistence operations against our underlying data store. We'll see how we can use Spring Data's populators in collaboration with our repositories to populate a collection in our MongoDB data store. The populator relies upon the repository to read a sample file, which is in JSON, and it reads that JSON and then creates entities and places them within our MongoDB collections using our repositories that we construct. We'll also take a look at the basic repository operations. We're only going to take a glance at this because of how Spring Data is actually designed. It is designed around a repository interface. So a lot of what we have learned when working with repositories in other lessons is applicable to the Mongo repository. You'll remember, though, that Spring Data attempts to preserve the specific features of a data store. So we get this abstraction, but we also get the rich features that make us choose a particular data store. So we're going to take a look at some MongoDB features such as a full text search, as well as some geospatial searches that we can perform, and we'll see how these data store specific features are facilitated by Spring Data Mongo. Finally, we'll take a look at a common problem that every developer faces when building an application. Sometimes our object model doesn't match our data model, and we need to know how to perform the appropriate conversions between our entities and domain classes. So we'll take a look at how we can register some converters with our Mongo template. Throughout this chapter, we're going to gain more in-depth knowledge of how to interact with MongoDB using Spring Data Mongo, and particularly from a repository perspective. In this lesson, we will see the basics of working with a MongoDB repository. To get started, we're going to configure our repository within the application context.xml file. So if we look at the Mongo namespace, you'll see that we have the repositories tag. And we can use the repositories tag to specify a base package. So for example, I'm going to scan the com.o'reilly.sdata package for any repositories. This is very similar to how we configured our repositories using JPA configuration. Now that we are set up to scan this package for repositories, we can navigate to our Package Explorer, and within the Package Explorer, we're going to create a new interface, and I'm going to name this interface Book Repository, and we will have this interface extend the Mongo repository interface, and we need to provide a type of our entity as well as its IDs type as the generic type parameters for our new interface. Here we see that STS has built out our interface, and we can now use this interface within our client code. So let's copy our interface type, and then we're going to navigate to the application.java file. Within this file, we are going to pull a book repository from our Spring IOC container. So I'll call this book repository repo, and we'll use our context to get our bean. And here we'll specify our book repository type. With this in place, we can now save a new book into our Mongo repository. So I'll simply use the save method on our Mongo repository, and then I'm going to use our book util to create a new book that will be passed into our save method. And in this way, we can test out the configuration of our repository. So let's just go ahead and execute our application, and we'll take a look at the console. And there we see that we have inserted our book object using our repository. We see here that we are inserting a DB object, which is actually a Mongo type. So there you see that the repository is really just delegating to the Mongo template as we have discussed. So in this lesson, we learned how to configure our Mongo repositories, and we created a new Mongo repository for our book entity. And then we walked through an example where we were able to insert a book document into a collection within our Mongo data store. Now that we have set up our Mongo repositories, we can use another approach to populating our data store with some pre-configured data. This is often useful when performing development in order to have a sample set of records that you can perform operations against. In our case, we're going to use our populate.js file to insert several JSON documents into our MongoDB data store. If we inspect the documents within the populate.js file, you'll see that we have provided a _class field for each JSON object, and this specifies the type of the object that we are trying to populate. In this case, we're specifying the com.o'reilly.sdata.book type, and we need to make sure that there is a repository available for this type so that it can be added to our MongoDB repository. You'll also notice that on our JSON document, we are specifying a location object that is embedded within our book. This object contains a name and a coords field, and the name corresponds with a library within the United States, and the coordinates are the longitude and latitude of that library. So we have the Library of Congress. You'll also see that we have the San Francisco Public Library, as well as several others. There's Chicago's Public Library, and we also have a public library within New York City that we do specify. Now, the coords field is actually specifying, as we said, longitude and latitude of our particular location. If we look at our book object, you'll notice that we have created a library field that contains the coordinates field that we're talking about. And our coordinates field is of type point, and this is a Spring Data Mongo provided class that helps us work with geospatial information. So in order to import and populate our Mongo data store with the documents specified in our populate.js file, we need to do a couple of things. First, we need to specify within our application context.xml a repository populator. This is very simple. We just go to the namespaces tab, and we include the repository namespace. Then we navigate back to our source for our application context.xml file, and we use the repository's namespace to specify a Jackson2 populator. And we need to provide the Jackson2 populator with our populate.js file. So this is the location of the file that contains the documents that we would like to populate within our Mongo data store. Now, you'll notice that it's referring to Jackson, which is a JSON parser. It allows us to serialize and deserialize JSON. In order to use Jackson, we need to add the appropriate library to our pom.xml file. So I'll go ahead and open up our POM, and if we navigate to the Dependencies tab, we can then add the Jackson-databind artifact, and you'll see that there is the com.fasterxml.jackson.core group ID, and we're going to make sure that we use the 2.54 version, and we also want to change our bundle over to a jar file. So with that change in place, we can save our pom.xml file, and we'll actually close that file. So Jackson is going to be responsible for turning the JSON that is contained within our populate.js class to an instance of a book, and then the book is going to be inserted into our MongoDB data store by the book repository, which is created using Spring Data Mongo. One of the trouble points of this is if we look at the library type, you'll notice the point type specified for the chords field. One of the problems is that Jackson, while it's able to handle a string, or let's say a long or an integer, it's able to handle these simple types and it can easily serialize and deserialize them. However, it's not familiar with Spring Data's point type. So we need to specify a way that it can convert from our chords field within our JSON that we see here to this point type. And that's what we're going to do next. We're going to set up a custom deserializer for Jackson so that it can make that conversion. Let's navigate to our package explorer, and within the com.o'reilly.sdata package, we're going to create a new class which we will call point deserializer, and this class is going to extend the JSON deserializer class. So we'll hit finish, and then we need to specify a generic type parameter here. So we're going to say that we want to have this deserializer take effect for the point type, and then we can add the methods we need to implement. And I also noticed that I spelled this wrong, so I'm just going to correct that. And that will adjust our type information. And now we can begin to build out our deserialize method. So what we'll do is we will grab the object codec from our JSON parser, and then we're going to get the JSON node using the codec and its read tree method, passing in our parser, and we'll import those types. And then we're simply going to create a new point using that JSON node. So we'll first read the longitude and we'll convert it to a double, and then we'll get the latitude, which is the second item in our array that we specified in populate.json, and we'll convert that to a double. At this point, we have taught Jackson how to deserialize a point object. Now we need to set up our deserializer on that specific field. So if we go to the library field, we can add an annotation to specify that we should be using that deserializer. So the JSON deserialize annotation, which is part of Jackson, has a using element, and here we can specify our class. So we're saying use that deserializer that we created when deserializing the point field on the library. Finally, we just need to navigate to our application.java file, and I'm going to remove invoking the save method on our repo. And if we start up our application, you can see that we will persist all of the documents that are within our populate.json file. So we can navigate back to our application class, and everything was successful. And just to validate this, we'll head over to our Mongo client, and we can check out all of the documents within the book database. And there we see that the book collection now contains more documents that have a location specified with their geodata. So in this lesson, we learned how to insert JSON data using a Jackson populator, and that can be used to supply some sample data when we are performing development. We had to put some deserialization customization in place with Jackson to support our geolocation data, and we'll be working with this data throughout the remainder of this chapter. In this lesson, we're going to take a look at some of the basics of working with a Spring Data Mongo repository. As you'll see, you're probably more familiar with the Mongo repository than you know. If we navigate to our book repository and we start to inspect the Mongo repository type, you'll see that it extends the Paging and Sorting repository, which extends the CRUD repository. Now, this type hierarchy should look very familiar to you because it is the exact type hierarchy shared by the JPA repository that we have worked with. So you're going to see a lot of the same methods that were on the JPA repository be contained on the Mongo repository. As a developer, this provides us with a huge advantage because we already know how to interact with a Mongo repository because we understand the overarching repository abstraction within Spring Data. Working with different data stores becomes much easier because we understand the approach used by Spring Data, and as long as we can work with the Spring Data project, we can normally interface with the underlying data stores through a familiar manner, regardless of the actual underlying data store. Now, do remember that Spring Data does retain data store specific features throughout the different modules. So let's navigate to our application, and here we have an instance of a book repository which we have received from our Spring IOC container, and we're just going to inspect a few of the methods on the repository. So let's use our new object, and we'll use IntelliSense to inspect the interface of our book repository. You'll see right away there is the delete method, which we're familiar with. We saw that on JPA repository. We also have find all and find one. We're familiar with them, as well as their overloaded forms that accept a pageable and a sort object. You'll also see the save method is available to us. So all of the methods that we saw on our JPA repository are pretty much available on the Mongo repository, and we just pass those methods the entities that we want to work with. Now, you will see some specific methods. For instance, here's the insert method, which is specific to the Mongo repository type. You would not find this on the JPA repository. You'll also see that deriving queries is the same as when we worked with our JPA repository. So for example, if I created a method that returns a book, so we'll say find by title, and we'll return the book by the title, this is exactly how we would create this method on a JPA repository. So once again, the repository abstraction is really allowing us to work with a data store that we may not be completely familiar with. And now if we go and invoke this method on our repository, we can find by title, and let's look for Moby Dick, and you'll see that we can log this book to the console. So let's go ahead and we'll run our demonstration. And if we look at our console, you'll see that we do indeed use the Mongo repository to return the document for our book Moby Dick. So in this lesson, we talked about the basics of the Mongo repository. Now, we didn't dive in and look at every method on the repository, and that's because we have already seen these methods in action, and it's very similar to working with any repository in Spring Data. Really, the takeaway from this lesson is that Spring Data provides you with a consistent approach to performing CRUD operations on a variety of data stores. And that's very powerful as a developer. It really keeps our code looking very uniform and very consistent, and we have this steady approach that we always use. And that's very advantageous because it allows us to transfer our work between different data stores. So I might be working with a relational database and I switch over to Mongo, and it's not completely foreign to me. It's also good because it allows us to introduce new team members that may have experience with Spring Data but not our underlying data store. So there's a lot of advantages to consistency within your approach to data persistence. In this lesson, we'll learn how Spring Data Mongo supports some of the geospatial features within the Mongo data store. You'll remember that our library entity contains a point, and our point field contains the longitude and latitude of our particular library. So what we're going to do is we're going to see how to query using the geospatial information stored within this field. In order to do that, we need to navigate to our command line and we need to add an index on our book collection. To do that, we specify our database and then we specify our collection and then we use the create index command. And you'll remember that our index was on the location.chords field. And then we specify that we want to use a 2D sphere index. And this is an index that supports geospatial features within MongoDB. So we submit that command, and now we see that our indexes are in place. And we can double check that by using our collection and running the get indexes command, and there we see our newly created index. Now let's return over to STS and we'll navigate to our book repository where we're going to add a method to our book repository interface that is going to use the geospatial features. So we're going to find by, and then we specify our field. So we're going to look on the location field, and we're going to look at the chords field, and then we're going to use the near keyword. And we're going to specify a point, so we're going to say where we're starting at, and then a distance of how far away we'd like to search. So you'll see that Spring Data provides us with the org.springframework.data.geo.point class, as well as a distance class to facilitate how we work with geospatial features within MongoDB. At this point, our repository method is set up, and Spring Data can derive a query from our method. We're going to navigate to the application context now, and we're actually going to remove our populator since we have already populated our geolocation data within our MongoDB data store. Now we simply just have to invoke our find by location chords near method in order to test out the geolocation features and compatibility within the Spring Data Mongo module. The way we do this is by creating a point. So we're going to create a point called Boston. And for our point, we provide two values. The first being the longitude. I'm going to give the longitude of Boston, which is in Massachusetts in the United States. And then I'm also going to give the latitude of Boston. And we'll import our point type. And now we need to specify a distance. And we'll use the distance to say how far away from Boston we're going to search. So we can use the distance constructor, and this accepts a value. So we're going to say 200, and then we're going to specify a metric in miles. Next, we're going to invoke our newly established repository query. So it's going to return a list of books. and we'll name that list books. And then we're going to use our repository, and we'll use the find by location chords near method that we have established. And I'm going to remove this extra space. And now we simply pass in our point. So that's going to be Boston. So that's where we're starting our query from. And then we're going to search 200 miles from Boston. And then what we'll do is we will iterate through our collection, and we'll print out all of the books that we find with our query. And we'll execute our first demonstration where we're searching 200 miles from Boston. You'll remember that our data contained a library in New York, a library in Washington, D.C., I believe one in Chicago, and one in San Francisco. So let's see what comes back. I'll go ahead and execute our application, and there you see that we've gotten a few books back. And if we look at those books, we see that they are all from the New York City Public Library. So we know that New York City is within 200 miles of Boston, so that makes a lot of sense. Let's look 600 miles from Boston and see what gets returned now. So we execute our application one more time, and now we see that we have received considerably more books back from our query. So if we scroll over, we can see our different locations, and now we're picking up the Library of Congress, which is in Washington, D.C. Now let's really open up our query, and we're going to search for anything within 6,000 miles of Boston. And if we execute our query one more time, now you're going to see we basically get our whole collection back, and we are picking up books from the libraries in Chicago, there's the library in San Francisco. This just gives a good overview of how we are increasing our distance and our query is responding with different results. So in this lesson, we learned how to use some of the geospatial features within the Mongo data store by working with the Spring Data Mongo module. In this lesson, we'll see how Spring Data Mongo supports full text search within the Mongo database. When we perform a full text search, we are able to search for a particular token over multiple fields within our document. This is very similar to something you would expect on a Google search, where you may input some text string, and Google really doesn't compare that string to a specific field. It looks through the entire text that it has for a web page, and it matches up your text search token against particular strings within that page, or maybe metadata that it has against that page. The point being, you are entering text in one place and searching across many fields. This type of search is also very conducive to weighting our results. So you can specify that a certain search token is more important or more relevant than another. To get started, we're going to take a look at our populate.js file. And you'll notice on this file we have added a description field. So we're going to load this data using our repository Populator. So just navigate over to a Mongo client and first remove all of the documents within your book collection so there is a fresh start within our database. Next, we're just going to navigate to our application file, and we'll just run the code within our file, and this is going to populate our data store with several books. Now that we have those documents in place, let's go to our application context.xml file, and we can remove our populator. At this point, I'm going to close our configuration file, and we can navigate to our book entity. When we use the full text search feature within the Spring Data Mongo module, we need to have a text index on our Mongo collection. We're going to add an annotation, which is the text indexed annotation, to several fields on our book entity that we would like to be part of that text index. Basically, we're marking the fields that we would like to search across when we perform our full text search. So here you see we're adding the text index annotation, and you'll see that this annotation has a weight element, and this allows us to specify how much weight each of our fields should carry. So maybe we want our title to be very important, whereas a match within the description is not as important. So we can go ahead and add weights. Let's navigate to our author entity, and we'll add some indexing to these fields. And what's going to happen is when we start our application, Spring Data Mongo is going to build this index for us. Navigating back to the book, we're also going to add a new float, which we're going to call score. And the score field is going to be annotated with the text score annotation. And this is going to be where Spring Data Mongo is going to return the score of our result within our full text search. So think of this as a field that is going to store our relevancy for each document. I'm going to add a accessor for this new field, and we can reconstruct our toString method to include our new score field. At this point, we can save our book entity, and we have all of our indexing in place. Now we're going to navigate to our book repository to add a new repository method to the Mongo repository. Spring Data Mongo allows us to construct a derived query method which uses a text criteria object as a parameter. So we're going to construct a new method, and we're going to name it findAllBy, and then we're going to specify a parameter with a type of text criteria, and we will name that parameter criteria. We'll import our types, and at this point we have our new repository method that's going to allow us to perform a full text search. Now we're going to navigate to the application to learn how to invoke this method. All we need to do is build out a text criteria object, which I'm going to name criteria. On the text criteria object, there is a static method that we can use, and it's for default language, and that's going to be English in our case. And then we can invoke another method which is going to actually construct our text criteria. You can see where we're able to specify where we match a string, we can match a term, we can look for a match against several strings, and then we also have some methods of negating a match. We're just going to focus on a simple match, so we're going to say where it's matching, and then we're just going to supply the term Dickens. And with that token, we can conduct our search. And then at this point, we need to invoke our findAllBy method and pass in our criteria. With that in place, we're going to go ahead and execute our application. And there you see that we return 3 results when we search for Dickens. If we inspect these results, you'll see that Oliver Twist only specifies Dickens on the author last name field. It does not specify Dickens within the description, while the other 2 results do specify Dickens within the description as well as the last name field. So there we see how our results are also scored. So here we can see that the author field caused a score of 1.0. We can see that having the author and the description matches gave us a score of 1.92. So you can see how we're getting some weights associated with these documents that are returned by our full text search. So let's navigate back to our application. Now let's run through one more demonstration. When working with the score, it could be very helpful to order by the score in descending order, and that's going to give us results back with the most relevant results first. So let's change up to use our new method, and we're just going to add some ordering to this method that we are deriving from our repository. And now you see that if we execute our query, that we get the documents returned with the highest score coming back as our first document and the lowest score coming back as our last document. So that can be helpful when you're working with weighting your different results. In this lesson, we will learn to perform queries against our MongoDB data store using a JSON query string. So if you interact with MongoDB through the client, you'll notice that when you execute queries, you specify a query string. We can do the same on our repositories within the Spring Data Mongo module. To get started, we'll need to add a method to our book repository interface, and this method is going to return a list of books, and we're going to name this method findLargeBooks. And we're going to pass in a int that we will call page count, and that's going to be a parameter for this method. Next, we're going to add the query annotation to this method, and using the query annotation, we can provide a JSON-like query string. So when we provide these methods, the first thing that we do is we construct a string for our field name, and for our field name, we're going to look at the page count field, and we're going to look and see where it is going to be greater than a particular number that we provide. So with our field name specified, we're going to build out our predicate. So we'll create a new object, and then we're going to use the greater than operator, and then we can specify a parameter. So when we invoke this method, the page count that will be provided as an integer to the method will be bound to the parameter and used in our greater than comparison against our page count field on our book repository. Let's save our book repository, and now we can navigate to our application and we'll test out our newly constructed query. So I'm going to remove our text criteria, and we're going to invoke a different method on our repository. There we see the findLargeBooks method, and we can provide an integer to this method. Let's say we want to find books that have pages over 300. So any book that has more than 300 pages will be returned by our query. So with that in place, we can execute our application. And there we see that we have, it looks like 5 books that have over 300 pages. And if we inspect, we do see that the page count is indeed greater than 300 pages. Let's navigate back to our book repository and look at another feature of the query annotation. You'll see that there is a fields element that we can provide a value for. So we just need to add a value, and we can provide a string which will contain another object that specifies the fields we would like to return from this query. So for example, if we only wanted to return the title field, let's say that's all we're interested in, we can specify the title as the key of the field and then provide a value of 1 to say that it should be included. Let's also include our page count, so we'll add another field to this object, and we'll provide a value of 1. Now, if we navigate to our application and we execute our query, if we look at the returned results, you'll notice that all of the other fields, although they are available within our documents in our MongoDB collection, you'll see that all those fields are null. And that's because our query has specified that we only want to return our page count and title fields. So this can help a little bit with performance or if you're looking to not provide all that information. So in this lesson, we saw how we can execute queries against our MongoDB data store using a JSON query string and the query annotation provided by Spring Data Mongo. When building out an application that persists data, it's not uncommon for there to be a disparity in how the data is stored between your domain class and your actual data store. So, for example, within our author entity, we are separating our first name and our last name. Maybe we inherit some set of data that has the first name and the last name combined within a simple name field. Luckily for us, Spring Data provides us with converters that allow us to convert our domain objects into the appropriate form of a document and our documents to the appropriate form in our domain objects. In this lesson, we're going to learn how to put those converters in place so that we can manipulate the entities or documents being stored into our data store. So let's go ahead and build our new converter. I'm going to create a new class, and I'm going to name this class author to DB object converter. And this class is going to implement the converter interface, and make sure you choose the interface which is within the org.springframework.core.convert.converter package. And we'll go ahead and specify the generic type parameters for this interface that we are extending. And we need to first provide the source type, which is author, and then our destination type, which is DB object. Hit the finish button, and then we'll import our DB object type, and then we will add our unimplemented methods. So this method teaches Spring Data how to convert between an author and DB object type. The first thing we'll need to do is build out our DB object, and we're going to use the new operator as well as the DB object constructor to create our DB object. And this acts almost like a map where we can put different keys and then provide values. So we're going to get the first name from our author field, and then we're going to do some concatenation of the first name and last name. And then we simply need to put the country, and that field will not require any operations. We'll just use the accessor. And then we simply return our DB object. So that converter is complete. We just need to register it within our application context.xml file. And you can see how it combines the first name and the last name to place them within one field. So we'll navigate over to our config file. Within the configuration file, we're going to use our Mongo namespace to specify a mapping converter. I'm going to give this bean a name of converters, so we specify the ID field, and then we provide a custom converters element within the body of this tag, and inside of that tag is a converter tag that is nested, and we can declare our new converter as a bean within this converter tag. So here we just use our author to DB object converter type to declare a bean, and now we have our converter registered. So there you can see our full XML for this. And now what we need to do is we need to register our mapping converters. So we're going to go to our template, and we're going to specify a reference to our converters. And at this point, everything is configured. We're also going to add our populator back in. So we're going to add the populate.js file, which when we start our application will populate our collection with all of the documents specified within that JavaScript file. Before we run our application, let's navigate to our Mongo clients within our command line, and we're going to drop our book collection. Now we're going to navigate back to STS, and if we go to our application class, we can simply run this class, and you'll see that all of our documents will be placed within our collection in MongoDB. And we can confirm that by finding all of the documents in the book collection. Now, one thing I want to point out, and let's narrow this down a little bit. We're going to look where the title is equal to Moby Dick. So we just have one book returning. And here, if we look at the Moby Dick document, you see that our author is declared right here. And then we start to create an object, and there is the name property, and we do have the first name and the last name of our author concatenated. That's great, our converter worked. So let's navigate back to STS, and we can go back to our application class. And from here, we're going to run our next demonstration. So this is going to be a very simple demonstration where we will find by title, and we're going to find our favorite book here, Moby Dick. So I'm going to save our application, and we'll execute it and inspect our console. And what you will notice is that the Moby Dick book, if we inspect it, will not have a first name or a last name specified for the author. And that's because Spring Data Mongo doesn't know how to map from our document, which contains the name field, to our domain object, which has the first name and last name fields. So conversion is normally a two-way street, so we're going to have to build another converter. So I'll just declare another class, and we're going to call this class our DB object to author converter. And you notice how we're being very explicit with that name. And we're going to have our class implement the converter interface, and we're going to be converting from a DB object to an author type. Hit finish, and that will build out our new class. And we can add our new convert method that we must implement. Now within the body of this method, we need to build out our author objects. So we'll use the new operator and the constructor, and then we're going to set the country, and we can get our field from our DB object by specifying the key. And we also need to make sure that we convert our field to a string. And now we can set the first name. So we're going to get the name field from our DB object, take it to a string, split it by the space, and then we're going to access the first index on that array. And we can do pretty much the same thing for the last name field, except we're going to access the next index on that array, and then we return an author object. We'll now copy the name of our newly created converter, and we'll head over to the application context to register this new converter. So we're going to specify a Mongo converter, and then we declare a bean, and we have to provide the type of that bean. And now we have our newly constructed converter registered, and we can head to our application to run our demonstration. So let's look at our console while we run our demonstration. There we see that we did indeed receive our Moby Dick book back. And if we look at our author, first name and last name, we do in fact see that we now receive values. And that's because we provided a converter that was capable of converting a DB object to our author domain class. So in this lesson, we saw how to construct converters and register them within our Spring IOC container for their use by the Mongo template. And this allows us to account for disparities between our domain layer and the underlying document structure within our MongoDB repositories. In this chapter, we're going to take a look at Spring Data REST. Spring Data REST is a module within the Spring Data project that sits on top of our repositories and exposes a REST API. You'll see that the REST API that is exposed uses HOW. HOW provides some metadata about the API, which makes it easily navigated because information about the API is provided through the API. Within this chapter, we'll learn how to set up a Spring Data REST project and how to provide the appropriate configurations for the project. Once we have set up our configuration and our project, we will then have a REST API available that exposes our domain layer. So our entities will now be accessible via HTTP requests against our REST API. On the API, we will see several resources. There will be a collection resource as well as an item resource that provide information to end users of the API. We'll take a look at how to use these resources to request information from the API and how to do things such as paginate and sort the information that is returned. As we interact with the API resources, you will see how flexible Spring Data REST really is. It is actually going to expose the derived methods on our repositories as well as provide us with REST resources to access all of the different functionality of our repositories. Spring Data REST also provides us with many opportunities to customize our REST API. By default, it will apply some conventions. However, if we would like to deviate from these conventions to create a more custom API, we are able to do that via a set of annotations provided by Spring Data REST. We are also able to customize the way data is returned to the user by using projections, which can limit the information that we expose to a client of our API. Within this chapter, you'll see that our REST API exposes a Spring Data JPA project. Spring Data REST can be used with several other Spring Data modules, such as MongoDB, Neo4j, Cassandra, and a few others that you can work with. But it's a great way to expose your Spring Data projects via a REST API. You can have your persistence layer within your application that you use internally, and then expose this API to any clients who may want to use your underlying data layer. In this lesson, we will learn to configure a Spring Data REST project. A Spring Data REST project is essentially a Spring MVC project that serves REST resources. Therefore, we're going to see that the configuration of a Spring MVC project and a Spring Data REST project are very similar. To get started, we are going to create a new Java project, and we're just going to name that project Spring Data REST. We'll leave our JRE at Java 8, and we won't change our perspective when asked. Next, we're going to go into our project properties, and we're going to click on Project Facets, and we're going to convert the project to a faceted form. This allows us to register the project as a dynamic web module. Now, we'll also want to right-click on the project, go to Configure, and then Convert to Maven Project. We'll specify a group ID of com.o'reilly.sdata and hit Finish. Now we will need to create some source files within our project. So I'm just going to use the New dialog, and I'll add a source folder. And I'm going to name this source folder Source Main Java, and I'm going to update our exclusion filters to resolve the nesting issues. Next, we'll go ahead and make another source folder, and we'll name this folder Source Main Resources. And once again, we'll resolve any nesting issues, and at this point we can actually delete our source folder. Next, we're going to add a web app folder within the source main directory. And then inside that folder, we're going to add a webinf directory. We'll then delete our web content directory and then go to our project properties. If we look at the deployment assembly, you'll see the web content folder is still there. So we can remove that folder and we'll add in our new web app folder. So we can add that folder in and then we'll hit OK. And then we'll go right back in and we're going to go to the advanced option and we can select our source main web app directory as the folder for our deployment descriptor. Now we can add our web.xml file or our deployment descriptor by right-clicking on the project, going to Java EE Tools, and then Generate Deployment Descriptor Stub. And you'll see that that's going to put a web.xml file within our project. Now inside our web.xml file, we're going to be registering a repository REST dispatcher servlet that's going to route all of our requests to the appropriate REST resources. In order to have that servlet within our project, we need to include some dependencies using our pom.xml file. So we're going to look for the Spring Data REST Web MVC artifact, and we'll include that into our project. While we are in our POM file, we're also going to include our Spring Data course project that you see within our Package Explorer. This is a Spring Data JPA project that we worked on earlier in the course. And it is a Maven project, so we can import it via the POM file. And now within our web.xml file, we're going to set up our servlet. So we'll use the servlet tag. And within the servlet tag, we're going to specify a class of org.springframework.data.rest.webmvc.repository REST dispatcher servlet. Now take a moment to make sure that you have specified this fully qualified class name correctly. Next, we're going to specify the name of the servlet, which we're going to make REST. And then finally, we're going to add the load on startup, and we'll specify it should be the first servlet loaded. Now we can provide a mapping for this servlet, and that requires us to specify a servlet name. So we want to map the REST servlet, and then we need to provide a URL pattern. And we're going to use /API/*. So any request coming in that has a URL containing /API/ will be handled by our repository REST dispatcher servlet. Next, we're going to add a context loader listener, and it's very easy to do that using IntelliSense. And we'll specify that we want to load our context from the webinf spring root context.xml file. So that's going to require us to create the Spring folder as well as a new Spring Bean configuration file named root context.xml. Within our root context.xml file, we want to configure our persistence layer. And as we said, that is within our Spring Data JPA project that was within the Maven artifact we registered. Let's go to our project properties and make sure we add that in. So here you see that the Spring Data course is included on our web deployment assembly. And if we take a look at our build path, we should also add it to the build path so it's available for compilation. And then we see that it does indeed get added there. So we'll click OK. And now we'll head back to our root context.xml file, and we'll use the import annotation to pull in the application context.xml file from our Spring Data course project. So that's going to configure the persistence layer that contains our book repository, which will be exposed as a REST resource. At this point, our Spring Data REST project should be configured. So if we navigate to the Run menu item, you will see Run As, and we can click Run on Server. We will then be prompted to select our Pivotal TC server and just hit Finish, and our application will be deployed to this server. Now, if we inspect our console, you'll see our application being launched, and we'll see that our Spring Data JPA project was consulted. We got our book repository registered, and we ran through all of our data load scripts, and then we start having the repository REST handler adapter map all of these REST resources for us. And you see there's quite a few that are actually registered. And when they talk about this repository, they're actually referring to our Spring Data repository, which in our case is the book repository. So now if we navigate back and look at the launched internal browser here, we can actually hit the API. And you'll see that when we hit the API, we're prompted for a file download. And that's exactly what we want at this point, because the internal browser doesn't understand the header type that is being served to it. So it asks us to pick an extension. But at this point, we have configured our Spring Data REST project. And this allowed us to expose our book repository via a REST API service. We'll learn more about the Spring Data REST features as we move through this chapter. When we attempt to access our REST API, you'll see that we are prompted for a file download. And as we discussed before, that's because the response type is coming back in an unknown format. In order to better interact with our REST APIs, there's a great tool out there we can use. It's CURL or curl. Curl allows us to interact with our REST APIs via a command line. So if you navigate to the curl homepage at curl.hacks.se, or you can just Google curl, we can then go to the download section, and there are various packages available that we can download. You'll want to pick the package that corresponds with your operating system. So for example, I'm using Windows 64, and I like to use the version that includes SSL. So if you click on the link, it will take you to a page displaying more information about the download, and there's also a mirror link that you can download from. If you click on that mirror link, it will then prompt you to save the software. Now, I've already saved this software to my desktop, and it's very easy to install. Just extract the files using your favorite extraction tool, and then you can easily open it via command line. From a command line, I'll just go to my desktop, into the new curl folder, and there you can see curl. When using curl, we simply specify the curl command, and then we provide a URL that we would like curl to visit. So we're going to hit our REST API, and that's on our local server, and we'll use port 8080. Our context route was Spring Data REST, and then we had the API path that we need to use in order to hit our repository REST dispatcher servlet. So when we do that, you'll see that we get a response back. And that response is telling us a little bit about our REST API. It's actually some metadata. It's showing us what resources are available. So we see that a books resource and a profile resource are available. And we also see the links to those resources. So this is Hypertext Application Language, or HAL. And HAL is a simple format that allows us to easily hyperlink our resources within our API. It makes our API explorable because it includes links that we can use or follow to access additional resources inside of the API. When sending a request using curl, we can specify the verbose command, and we will get additional information about our traffic. So for example, there we see that our content type is application HAL plus JSON, and that's why we were not able to see our traffic via the browser. If we provide further path information, we can then access the resources exposed by Spring Data REST. In our case, we're going to access the book repository, which will serve us the book entity. The way Spring Data REST determines the path for a particular resource is by taking the entity name and using the plural form. So when we hit the books resource, you'll see that we were returned a list of all of our books. You'll also see that we got additional metadata about the resource itself. So you'll notice that there is a search resource exposed, and we could go ahead if we want and hit that resource. And this is going to expose additional information about our REST API. Throughout this chapter, we're going to be adding and exploring different features on our REST API. As we do that, we'll be using curl to test out that functionality. You'll see that curl is quite versatile in the fact that it allows us to perform almost any operation against our REST APIs. In this lesson, we will see how to configure our Spring Data REST projects using a repository REST configure adapter. To get started, we're going to navigate to our Package Explorer, and within the Spring Data REST project, we're going to create a new class within our source folder. I will open the new dialog and create a class, and we're going to put this class within the com.o'reilly.sdata package, and we'll name this class Custom Repository REST Configurer Adapter. This class is going to extend the repository REST configurer adapter, so we can simply locate that class within our superclass selection dialog, and once we have extended that class, we can hit finish. Within our new class, we want to override one of the configuration methods. So we will right-click within the class and go to Source and then Override Implement Methods. The method that we will override will be the Configure Repository REST Configuration method. So I will go ahead and select that method and then hit OK. The new method is now added to the body of our class for us to override. You'll notice that the Configure Repository REST Configuration method accepts a repository REST configuration parameter. We're going to use this object to set different configurations for our Spring Data REST project. One we're going to look at is the base path, and this is the entry point to our REST API. The base path is set using a string, so let's just say we wanted to change our entry point to my API. We just go ahead and provide that string. You'll also see that we can set the default media type. So this is the content type returned for our responses. To do that, we use the media type object, and there are several different media types that we can specify. In our case, we're just going to pick application JSON. You'll see there are quite a few options that we have, and we'll just go ahead and pick JSON. On this object, you'll also see quite a few methods that allow us to customize the parameter names. So we'll see in a little bit that our APIs are pageable as well as sortable, and we pass in different parameters that can control paging and sorting. We can customize those parameter names using our repository REST configuration. In our case, we're just going to set our default page size, and we'll set that to 5. You'll also notice on this object there is the option to configure how we use how. We talked about how and how that was impacting our browser and how it returned data. Now, that's not really important because most clients of our REST API are going to be able to handle that format, but we are able to enable or disable it via our config object here. Another thing to look at is return body on create and return body on update. When we use our REST API to create a new record, we can return the new record once we have invoked that operation, and the response will contain the newly created record. Now, we won't set any of those features, but it's good to know they're there. At this point, we have provided some custom configuration for our Spring Data REST project. Now we need to get this configuration registered. So I'm going to copy our class name because it's going to become a bean. Let's navigate to our root context, and within this context, we're going to declare our new bean. There we specify our custom repository REST configure adapter type, and we can use autocomplete to expand the fully qualified name of our class. Now we have our configuration in place within our root context.xml file. Since we changed our base path, I'm going to navigate back to the web.xml file and simply have this repository REST dispatcher servlet handle every request coming in. That way, all of our REST API requests start with my API as we have specified. With this in place, I'm able to restart our server, and then we can navigate over to our command line, and we'll use curl to issue a request against our REST API. So our root context is Spring Data REST, and our new base path is my API. And when we hit that, we now see that our API's entry point has in fact changed. You'll also notice if we enable the verbose flag that our content type has changed to application JSON instead of including how. So there was another one of our configuration changes taking place. Finally, you'll see that if we hit our books resource, we are now only returning 5 results instead of the entire collection. So there's 1, 2, 3, 4, 5. And that's because we set our default page size, and we see that reflected in some of the metadata that is provided by accessing our REST API's book resource. So in this lesson, we learned how to modify the configuration of our Spring Data REST project using a repository REST configure adapter. In this lesson, we will explore our new REST API by looking at several of the resources exposed on our Spring Data REST project. When we talk about a resource, it's really a generic term for a collection of entities that are exposed on an endpoint. Spring Data REST focuses on resources by looking at our repositories. It sees that we have a book repository, which corresponds with our book entity. And then if we look at our API, you'll see that it exposes a collection of the book entity via the books resource on our REST API. If we were to further navigate down into the books collection, this is actually referred to as a collection resource. And if we hit that URL, which corresponds with our collection resource, in this case /books, we're going to see that all of the books are returned, or at least a page of the books are returned. So this is very similar to invoking the findAll method. When we work with the collection resource, you'll see that there are 2 main operations we can perform. We've already seen how to perform a get against our collection resource of books, and we saw that that returns some data. But we can also perform a post against this collection resource in order to insert a new entity into our collection. To perform a post using curl, we need to specify some headers for our request, that specify the content type of application JSON, and this simply says we're going to be passing JSON to our REST API, and then we provide the -d option to specify the data we'll be passing. So we need to specify an object, and then within that object, we're just going to build out a simple book, and we're just going to specify the title. And the book is going to be The 7 Habits of Highly Effective People. Now, you'll notice I'm using 2 quotes, and that's to get the proper escaping within Windows. Now that we have specified our data, we'll use the X option to specify that we are now performing a post instead against our API. You'll notice that when a post is performed against the API, it tells the API to insert the data that we have provided. Now, you'll also notice that we get some links back with this post, and the links point to the newly inserted entity. So let's go ahead and we can query our new entity. To do this, we simply use curl, and we're going to perform a get. Curl performs a get by default, so we do not need to specify whether we're performing a post or some other form of request. And then just our server, our port, then our context root, as well as our API entry point, our collection, and then we need to specify an ID of the entity that we would like to access. So in our case, it was entity 15. Now, when we use this form of a URL to access our REST API, we are accessing an item resource. And when we perform operations against an item resource, we have the option to perform a get, and that's simply going to return that entity to us via a JSON object. You'll also see that we can perform a put against that item resource. When we perform a put, the syntax with curl is very similar to when we perform a post. So all we need to do is go into our former post and tell it we're going to perform a put, and instead of using our collection resource, we need to use the item resource by specifying an ID. And then we need to change our data. So a put is basically going to perform an update against our entity. And what we can do, we'll just add in another property. Let's say the page count, and we'll specify the page count at 400. We'll say it's a very long book. And then we can go ahead and pass this put request over to our REST API. And there you'll see that we have updated our book to include a page count. Finally, we can also perform a delete against the item resource. Performing a delete is pretty simple. We just need to use the item resource. We change over our request type to a delete, and that means we can get rid of the data we're passing as well as our content type. And with that in place, all we need to do is pass the command to curl, and you'll see that our entity has been removed. So if I simply perform a get against this item resource, you'll notice that we no longer return a JSON object. So in this lesson, we took a look at the REST API that gets exposed by a Spring Data REST project. And we saw how that API is associated with a collection of entities which are also associated with our repositories, and how our REST project associates those resources with our repositories and those entities. We also saw the different operations that we can perform against a collection resource and an item resource by specifying different types of requests. In this lesson, we will see how to perform paging and sorting on our REST API that has been created using the Spring Data REST module. To get started, we're going to navigate to our command line where we can use curl to access our REST API. So we specify the server, as well as the port, and then our context route followed by the entry point into our API. When we do this, you'll see that we have a books collection exposed as a resource, and we can navigate to that collection and see several of our results. If we inspect these results, you'll see that the books we have are Of Mice and Men, One Flew Over the Cuckoo's Nest, For Whom the Bell Tolls, War and Peace, and The Grapes of Wrath. You'll also notice that in this links object that has been added to our results set, there are several other fields that provide us information about paging. For example, if we look at the first field, you see it provides a link to the first page of our results. You'll also see a next link that provides us with a link to the next page of results within our collection, as well as a last link that provides us with access to the last page of results within this collection. So we can specify our page by using the page and size parameters when we submit our request. So for example, let's navigate to the last page. And that means that we're going to specify a parameter where the page is equal to 2, and we don't need to specify the size because that's set by default. But if we wanted to, we could change the size of our page. In our case, I'm just going to leave it to the default. Now you'll notice that when we submit that request against our REST API, the response we receive contains another links field, and that links field contains, once again, the different links to the various pages of our results set. You'll notice that in this case, we do not have a next field available because there is not a next page of results. We also receive this page field at the bottom of our results, and it contains an object that tells us a little bit more about the collection that we're working with. We see that it has 14 elements. There are a total of 3 pages, and we are on page number 2. When you consider zero indexing, we are actually on the last page. Now let's take a look at sorting. Sorting is very simple. All we need to do is change our parameter to sort, and then we specify the field that we would like to sort on. So here we're going to return all books, and we're going to sort on the page count field. Now, when we issue this query, what you'll see is that our results are sorted in ascending order. So we have a book with 120 pages, which is our design patterns book. We move on to Animal Farm at 126, and you see we continue to extend. Now, I will forewarn you, these are not the actual page counts for these books. But you can see how we can specify an order for our results that are returned when we access a particular resource on our REST API. So what if we really like long books? How do we get the books with the most amount of pages? Well, all you need to do is after your field provide a comma and then specify either ASC or DESC. We want descending. And then you'll notice that it changes the ordering. So if we scroll up, now we see that we are returning books with the most pages, and War and Peace coming in at 400 pages is our first result. Moving to The Grapes of Wrath, One Flew Over the Cuckoo's Nest, and we continue, there's A Tale of Two Cities, and you can see how we were able to change the sort parameter on our request against the REST API, and that in turn changed the collection that we received back. So you can use this for multiple fields. Let's say we wanted to sort by the title, and now if we inspect our returned response from our REST API, we start out with A Tale of Two Cities, moving to Animal Farm, and you can see that we're going in alphabetical order. What's great about this approach is if you're working with a Spring Data REST generated API, You are not responsible for building out these paging links within your client-side script. Instead, they're provided for you, and you even notice that Spring Data REST has modified the provided paging links, such as next or last, to include my sort parameter, performing a lot of work for me. If you've ever built paging into an application, you'll know it's not complex, it's more tedious, and you just do a bunch of one-off testing. Well, Spring Data REST takes the guesswork out of that, and that's worth a lot because it allows you to focus on other more important tasks, while paging becomes something that's provided out of the box from the actual framework you're working with. In this lesson, we will learn how to customize the way that our REST resources are exposed on our API. So to get started, let's head over to our command line, and we'll use curl to head to the root of our API. And you'll see that the books collection is exposed, and we receive an href to access that books collection. Well, what if we wanted to change the endpoint? So instead of /books, we wanted it to be something else. Let's say /classics. Well, to do that, Spring Data REST provides us with some annotations that we can add to our repositories. So we know by default that Spring Data REST takes the entity name, in our case books, pluralizes it, and that's how it comes up with the resource endpoint's name. So that's how we get books on our API, and that's how that path is created. If we want to modify that, all we need to do is change our annotation to a repository REST resource. And this annotation will provide several elements that allow us to modify how this resource is exposed. We can set the path attribute on the repository REST resource, and let's just set it to classics. At this point, we will save our changes, and we'll restart our server, and then we'll navigate over to our command line, and let's inspect our API again and see what happened. You'll notice that if we look at the href field on our books object, that our endpoint or our path has been changed to /classics. So now we can access our books collection by using the /classics path. You'll also notice that if we were to look at our root of our API again, that we're specifying the books object there. And we can actually work with that too. So if we go back to our repository REST resource annotation, there's an element on here that allows us to specify the collection resource rel, and that will change the field name on our response. So let's change that over to classics, and we'll save those changes. We will restart our server to sync everything up, and then once our server starts to restart, we can head back over to our command line, and if we navigate to the root of our API again, we'll see our changes take effect. Now you see we have an object that has a links field, and within that field there's an object, and it has a classics field instead of a books field. And we were able to accomplish that by changing the rel attribute on our annotation. So let's go ahead and clear our command line, and let's further look at our classics collection. We see that we get a list of books returned, and you'll also notice that we have modified the field name for the array containing all of our entities to include classics instead of books. So we're changing up what our response looks like. Now, with each of our collections, we have the option of accessing the search resource, And that's going to tell us what methods are exposed on our repository that we can use to query entities. So here we see we have a find by title resource where we can specify a title and it will be returned to us. What we would like to do is switch that over to use something a little bit more descriptive. Let's navigate over to our STS environment. And within this environment, we're going to annotate our controller method with the REST resource annotation. And the REST resource annotation also exposes a path element that we can use to modify the path that exposes the resources on our API. So let's say that we want to change this over to title, and we'll save our changes. And now we're going to restart our server, and we'll navigate over to the command line. And now we will search our classics collection once again. You will now see that there is a different href for our repository method that is exposed on our repository. You'll also notice, though, that we kept the find by title field name, and we can change that up as well if we use the rel attribute on our REST resource annotation. We can assume what's going to happen once we make that change. We're also going to look at another element. So here you see the exported element on this annotation, and this accepts a Boolean. So let's say we set this to false, and we'll just go ahead and add another repository method just so you can see the difference here. We're going to add a find by page count method where we can search our REST API by page count. So we'll go ahead and restart this. Now just remember that we have set the exported element to false, and it's not going to expose that method on our REST API. Maybe that method's just for internal use and we don't want clients of our API to be able to invoke it. So there you see we have the find by page count resources exposed, but we do not see our title resource exposed because we have specified that it is not allowed to be placed on our API. So these are just some of the ways that you can customize the way the exported API looks using annotations within Spring Data REST. In this lesson, we will learn how to use projections to limit the amount of entity information exposed by our REST API. So let's navigate to our command line, and we'll use curl to access the book entity. We'll pick out an entity within our book collection, and we'll just take a look at the information that is provided. So I'll look at the classics. If we look at classic number 3, we will see that the title, the publish date, the page count, the price, and the author are all exposed. When building out our REST API, we may not wish to expose all the information about our entities or the data that we are providing via the API. For example, maybe we would not like to display the price field in order to not deter anyone from further exploring a particular classic. The next demonstration we're going to work through will show us how to use a projection to hide particular fields. So let's clear our command line and we'll navigate over to STS, and we're going to create a new interface. So within our com.o'reilly.sdata package, I'm going to create an interface, and I'm just going to call this interface Classic Projection, and then we will create getters for each of the fields that we would like to expose. So for example, I'm going to have a getTitle method. I will also have a getPageCount method, and by placing these methods on our interface, and make sure they're public, we are defining a projection that will be exposed via the REST API. So we're really selecting the information that we would like to show about our entity. In order to make this interface an actual projection with Spring Data, is we need to add the projection annotation to the type. So we put that projection annotation in place, and then there are a number of elements that we must provide values for. So the first one is the name. And let's just name this classic. And then we also need to specify an array of types that this projection can be applied to. In our case, it's going to apply to the book class. Now, we have modified our REST resource to display the path of classics. However, we're still using a book type for our underlying repository. Looking at that projection, it's now going to be made available when working with the classic collection on our REST API. So when we're working with that classics resource, we can specify a projection of classic, and we will limit the information that we expose via the API. Let's go back, and now when we access the item resource on our REST API, we're going to specify a request parameter named projection. And all we need to do is supply the name of the projection that we would like to use. And you'll see that when we use curl to submit this request against our REST API, the information returned for our particular book is now limited to the fields that we have specified on our projection. So in conclusion, we learned how to create a projection which allows us to limit the information that is exposed on our API. We're able to create an interface and add the projection annotation, and that projection annotation is picked up by Spring Data and used when we display a particular entity that is exposed through a REST resource. Congratulations, you've completed our course on Spring Data. Let's take a look at some of the key principles throughout the course. The first thing that you should take away from this course is that data persistence is evolving. How we store and access data within our applications is changing. We're no longer using JDBC and working at that low level. Abstractions continue to be put in place that make our job of persisting information easier. There's been a natural progression. We've moved from JDBC to ORM solutions such as Hibernate and JPA, and now we are moving on to solutions that actually provide implementations of an ORM for us. We're no longer even interfacing with the ORM directly, and relying upon more abstract frameworks to perform that work for us. We're also seeing that the data persistence landscape is moving more towards a REST API approach, where we're even further abstracting our data persistence layer behind another layer that allows data to be persisted through the web using RESTful URLs. As we continue to place abstractions over our data layer, the way we interface with that data layer becomes more and more consistent across several data stores. When we interface with a data store, using the repository interface, which is a key interface in Spring Data, you're going to notice a lot of similar approaches used to interact with a data store and to retrieve and store data within that store. You'll also notice that when you use Spring Data across a portfolio of applications, the applications will have a consistency amongst them, allowing developers to freely move from one project to another. This is all thanks to the abstraction that Spring Data provides over our persistence layers. We're getting away from managing our connections with JDBC and worrying about whether we've opened or closed them and writing prepared statements to moving to a state where we deal more with objects and the underlying details are not exposed to us. I would also like to point out how closely Spring Data integrates with other Spring projects. Spring Data is not the only solution out there for persisting your data. You can work with something like Hibernate right out of the box and use the ORM. And there are other frameworks out there that facilitate how we retrieve and store information. What most of those frameworks don't have is a tight integration with a portfolio of projects that are designed to build Java applications. And that's really one of the big benefits of Spring Data. We're using the familiar Spring approach. So we're using dependency injection. We're able to apply a similar approach to configuration. The different projects gel together and allow us to achieve some efficiencies because we understand the Spring atmosphere and we know how to work within it. So you have this great new skill. Where do you go next? Well, if you've seen my other courses, you know I'm a big advocate. Start a project, whether it's at work, personal project, get out there, write code. Writing code is the best way, and using what you have learned will really reinforce the skills that were taught in this course. Within this course, we covered 3 of the Spring Data modules, probably the 3 most popular, I would say. But there are other modules out there that you can work with. So I would go out and take a look at Spring's website and see all of the other modules under the umbrella of the Spring Data project. And you'll see a consistency across all of the modules in how you work with them. Go out and explore. Find a new data store. See the benefits it has to offer you over the data stores that we have explored. Once you've taken a closer look at Spring Data modules, then I would encourage you to continue to expand your skill set by looking at some other technologies out there that have become quite popular. Timeleaf is a templating framework that has very tight integration with Spring, and there is quite a bit of information out there for you if this is something you're interested in learning. There's also Spring's AOP facilities, and I would recommend taking a look at aspect-oriented programming. Finally, I would like to say thank you for working through this course. I'm very fortunate to have the opportunity to produce these courses because I really enjoy teaching other folks technical skills. Spring Data is really one of my favorite Spring projects. It's very easy to see the benefits of this project and what it provides just because it's something that we do all the time when we develop applications. We persist data. And if you were like me, you were tired of hammering out the ones and zeros with the JDBC driver. And having Spring Data come in and perform all this work for you is just very efficient. So I was very happy to be able to make this course, and I hope you took a lot away from it that you can apply in your daily work.